Hi, my name is Leon, and I want to teach you to code for free. I've helped thousands of people learn to code, and I've helped hundreds of folks get jobs as software engineers. I've been running a free 30-week software engineering bootcamp live on Twitch, and what you're about to watch is the culmination or the review of what took us about 10 classes. So it will go fast, but if things don't make sense, I ask you to do two things. One, join our Discord, which is linked below, because when you join our Discord, we have 3,000 plus people that want to see you be successful in learning how to code. And two, if there are any topics that are just too difficult, go back and watch a specific class on that topic that's here on this YouTube channel. That's it. Good luck. And if you have any questions, we'll see you on Discord. Hey, what's up, everybody? How y'all doing? Happy Sunday. Good morning, good evening, good afternoon, no matter where you're coming from. Hope everyone's doing well. How's your weekend been going? Got some love before I got in here. Hold on, let me say what's up. Oh, Rossi with the 8 months. Oh, Rossi, how you been? Hope you're doing well. Hope you're feeling better. Glad to see that you're here. Let's get you caught up. You've been missed. Gonrich with the 5 months of primes. Hey man, appreciate all you've done for the community. Heaps of love from Europe. Hey Gonrich, I appreciate that. Thank you. Hope you've been well too. Jimmy Cabo with the 7 months. Hey Jimmy, appreciate that. Thank you so much. Thank you for being here. Hey Reggie with the 7 months. You all are the best. Micro Leon, I agree. I agree, Reggie. Thank you for being here. Magic Marcos with the 6 months of prime. Hey, I appreciate you. Thank you for being here. What's going on, everybody? Blah throwing out the new emotes. Hey. Covering slowly, but I'm going to try and be here today if I can. Hey, let's go. Hopefully you're able to get through it. We got a lot today, folks. We got a lot. Your last coffee chat was your backyard neighbor. That's awesome, Yubi. Welcome back, everybody. Hope you all had a good weekend. Hey, Reggie with the 5 gifted subs. Let's go. Reggie, I appreciate that. Thank you. That's wild. Starting the hype train off. Whew. Let's go. Appreciate you. I really do. Thank you. L4 had a 3-hour coffee chat yesterday. It was great. Let's go. See the coffee chats, right? The thing about the coffee chats is that they're meant to be like making friends, right? And so when you know that it's gone the distance, you put in that many hours, you know that you and that person are tight. That's what you want to be doing. Quality, right? Got your second one yesterday. Feel like you got hit with the truck. Hey, I was there. That was me 2 weeks ago. I feel you. Abish, hey, glad you're back. One of my coffee chats turned into a standing weekly meeting. Hey. Got 3 coffee chats on Tinder, Kappa. Get out of here. Oh no, blah. Alrighty. Doctor Office has Wi-Fi. Alrighty, folks. Today is our review. We're going to start from the beginning. We're going to cover basic JavaScript just so that we feel comfortable with arrays and objects. Just a quick review, nothing too wild. And then we're going to get into all of our lovely kind of callbacks, promises, async await. Once we have that unlocked, we're going to talk about Node and what it is and what it gives us. We're going to look at some old school building of server code just with the basic FS and HTTP modules. Then we're going to build out our wrap names API from scratch. We're going to look at our to-do list and look at finally reviewing the social network. And we're just going to build. We're just going to build on top of each thing as we go. I have no idea how long this will go. Our last one went 7 hours. This is more kind of code review though, so it could be less, could be more. There's no way for me to gauge how long this class is going to go, because it really does come down to y'all and the questions that you ask. And I really want you all to ask a lot of questions. If things don't make sense, ask. Let's talk through it. Let's Google together if I don't know it, right? And we're going to get through it. Now, the reason why we're doing this review is because we got another project we want to build, and then we're getting into React, right? So you all have your team projects that you've been working on. So you got to finish those up. And then we want to do one more big project before we move on to React. Because the idea here is now that you have a full stack to-do list, you have a social network, you have this wrap names API. So in your portfolio, you have an API that you've built custom from scratch. You have a to-do list that you built from scratch, a social network you built from scratch, and you're going to have one more project that you built from scratch, right? And then you're going to have one more like big React project as well. So you're going to have like 6 pieces in your portfolio that are real. They're full stack web applications that can demonstrate your skill. And a lot of what you're going to be doing is tweaking those projects. So it won't be just a to-do list when you put it in your portfolio. It won't be binary upload boom, our social network, when you put it in your portfolio. You're going to twist them, you're going to tweak them so that they're your own, right? And so that's what you're going to be working on too. So the goal for today is to understand those projects so that you can then go ahead and make them your own, add them to your portfolio, and start to stand out. So lots to review, lots to get into, lots of code to get through. So I'm glad y'all are here. Hope you're all buckled in. You're ready to go. So if you would like the slides for today, you can do !slides, and that'll give you the slides that we're gonna be using today. If you would like to follow along as I progress, the slides will auto advance. If you don't like that auto advancing, you can chop off the /live and the slides are now fully under your control. The code we'll be using today is the code that you've already seen if you've been following along, but on Discord, !Discord, that will give you access to a follow along materials channel. When you join our Discord, you got to do a few things. You got to read the rules. You have to agree to the rules. Once you agree to the rules, most of the channels open up. If you would like to participate in our Bootcamp 100 Devs, there is an additional channel called Join 100 Devs. You have to go in there and click both of the emojis. When you click both of those emojis, you'll get added to also the 100 Devs channels, right? Those are private for folks that want to do the Bootcamp. So if you're new and you're watching this maybe on YouTube, Leon Noel, LeonNoel.com/100devs has all this information for you. You can just click the links there and get involved right away. So we had one other crash course before this. So if you're brand new, you should probably stop what you're doing now and go back and watch our front end crash course. That's going to give you all the things you need to know: HTML, CSS, and then JavaScript. We're just lightly touching the JavaScript beginnings today, just to make sure they're fresh in our minds as we move into the back end. So that would be a really good place to start for you. If you finish the front end crash course and you're jumping into this one, well, we're going to start over with the spaced repetition stuff again and the basic JavaScript. Take it as your spaced repetition. Don't skip it. Work through it. That way it stays fresh in your brain. Alrighty. MB said, are we checking in today? No check-in today because it's Sunday. Check-ins will only be Tuesday, Thursday normally. But thank you for asking. Alrighty, folks. If you're feeling itchy, if you want to check in, you can use the one from last one. How did RC demo day go? It was great. We had almost 200 folks there that were trying to. Well, we had our peak was at like 250. So if you take away all the students and staff, that's like over 200 folks that are hiring partners that came to check out our students, and so that was wild. To have that many people come ready to hire, it's a good thing. We also had some of our really big partners come back and after demo day, they're like, all right, they're the real deal. We're committing to hiring. And so we had a lot of folks commit to hiring. Yeah. So it was great. It was the best it could have went. A lot of students are already getting kind of calls and setups from recruiters and companies that want to hire them. So it was a smash. Is Angie okay? Yeah, they're okay. That was a tweet about just the app that my student built, not that something was currently happening. Can we join RC? Yeah, if you are in Boston, Philly, or Pittsburgh, you can join. We don't have a remote option. We target those cities because we want to improve the economic outlook for Black and brown folks in those areas, and also build up partnerships in those areas. So if you're not one of those 3 areas, unfortunately, RC is not available to you. But good thing you got 100 devs, because that's available to everyone. Next cohort starts July. Yeah. Just got my response from them for the hackathon. Hey, Magic, that's cool. Alrighty, folks. You had a chance to grab the slides. In the following materials channel, there's also the code. It's just the code that we've been using over the past couple weeks. Let's get into this. Let's go into Little Leon here. We're gonna work through some of the basic stuff, and then once we get through the basics, we're gonna keep moving. So like I said, today is about taking our time. It's about asking questions. If things don't make sense, please ask. I want to talk about them. Like I said, there's no way for me to know how long this is gonna go. Like normally I'm pretty good at like estimating lectures. I think like we hit the 3-hour mark pretty consistently. Often I'll say it's gonna be lower, but it takes a little bit longer. Of course, that's the meme, but we really must hit that 3-hour mark pretty consistently. For this, I have no idea. We could go for 2 hours. We could go through 7. So let's keep it going. Let's take our time. If we need to do another Sunday, we'll do another Sunday. That's okay. But I want you to feel that you can ask questions, that we can talk through the basic stuff, and make sure people are feeling good. That's the point of today. The point of today is for you to walk away feeling a bit better about the back end. And so if you're not feeling good, ask the questions. That's the point, right? We're all here early on a Sunday, right? To make sure that we feel good. I got my comfy shirt on. This is my Maurice Ashley, the GM in chess. This is their merch, which I think is pretty cool. Got that on. It's my comfy shirt. Imran got me hydrated with my coffee. I got my my Hufflepuff cup here. Oh yeah. Drinking that California Coffee Company coffee. Do you know where Bob is? Bob is right behind me. All right. I watched that clip. I think that was the funniest moment on stream that we've had so far. Like I watched that back and I was proud of it. I thought it was hilarious. I was like, you all thought it was a joke, but I really was like, I was upset. I had no idea where Bob was, and I got like on stream like visibly flustered. Like when it came back, I was like out of breath. I thought it was hilarious. I watched that back and I was bawling. But yeah, Bob's right behind me. Alrighty, folks. Let's get into this. I'm gonna chill the music here. I can see it in your eyes. I agree. All right. Like I said, today is about the fundamentals. We're going to be walking through the basics of JS, just very, very quickly, just the beginnings. We're going to talk about promises, async await. We're going to talk about node fundamentals. We're going to talk about CRUD and how we can build cruddy apps, create, read, update, delete. We're going to see how most of our applications are really just doing those 4 things. And all the extras, all the accoutrements, these are just ways of like keeping us a little bit more centered when we're dealing with projects that get larger and larger, right? We're going to look at our authentication, specifically the local authentication, just so that we can get another kind of pass through it, understand how it's working, see what it's doing. And then your homework is to finish working on your team projects. So we're going to work through all this together today. And as you have questions, you're going to ask. Cool. Now, we already did a little bit of questions here in the beginning, but any questions before we get started? Happy to answer any basic stuff before we get started. Maybe questions about the day, questions about 100 devs. If not, we'll jump right into it. Seen a lot of John emotes today. I don't know how I feel about that. When are we buying the agency? In June. So June we're gonna have so this was the past week was my most busy week, right? Then June I have off. But June is all 100 devs, all my one-on-ones, everything with y'all. And it's also when I have time to like really build out the agency, really build out blog team, stream team, all that fun stuff. So June is when it's going to pop off. I just bought a new MacBook, never owned one before. Any tips? Watch a YouTube video. Like seriously, like I know that sounds weird, but like watch a YouTube video, like all the Mac shortcuts. And with Macs, use the trackpad. There's a lot of cool stuff you can do on Macs that make your life a lot easier. Like 4-finger swipe that like expands your windows. There's a lot of gestures that you can use. And so watch a video on all the gestures because it really does speed up using a Mac, which is fun. Are you using an ask form for today? No, Jesse, I didn't bring up the ask form for today. I just want people in chat to ask questions. I wouldn't be able to pay, like it's too much. Like I don't know if I'd be able to pay attention to the form and chat. So we're just gonna do chat for today. If there's a question that you really want and I miss it, just ask again. That way I can see it. What would have been the best way to start the project and how to divide the work? We've been spending all day debugging and still nowhere near running server. So the best way to start early on is to do it all together. So when you're first working on these early team projects, dividing work early on is kind of a detriment. So get the server up and running, get your routes up and running, get your controllers up and running. And once you have your controllers all connected and running, then you can start assigning different pieces to folks. Like, oh, you're going to handle the get, I'm going to handle the post, you're going to handle the put, right? But you need to have like that cohesive code base that you worked on together. And working on it together is really important because you all understand what's happening. And then once you have the basic project set up and all the pieces are working together, then you can start breaking it out. So that's the way I recommend it working. Or otherwise, you're going to be tripped up the whole time. Do we need any of the backend applications installed already, or will we install as we go along? We'll install as we go along. Yeah, we're going to do everything together today. If we don't make the June deadlines, will you help us later after we wrapped up those in June? So the tricky thing here is June I have off, right? Like June I have off. And so since I have off, I can help a lot of folks. My time is not mine after June. So that's the hard part there. Yeah. That's how our team approached it. That's good. I've been totally out this whole week with my ankle. Hey, Dab, I hope you're feeling better, though. Cat, all right, I got you. Should we instantiate the database connection only once? Yeah, I think you only need to set it up one time, yeah. All right. Let's get it going, folks. As you have questions, ask. Alrighty. If you only walk away with one thing today, it's the thing that I'm going to sing from the heavens over and over again. Cross, I feel exactly the same way. Did April actually happen, though? How is this May right now? I feel the exact same way. All right. Dab, reach out to me if you need help with anything. I know it'll be rough to get through it all, but reach out. Happy to help one-on-one. All right. So active recall, most important thing that we're going to do. If you are here with me today, if you are coming to 100 Devs for the first time, right? Maybe you're watching both the crash courses and trying to catch up with us. This is the most important thing. If you are not doing this, all your studying is going to waste. So this is a chart from Ali Abdal. Ali Abdal has some videos that I think have changed the lives of a lot of my students. And this one is about something called active recall. And active recall is a very simple concept. Once you are done learning something, stop and talk out loud about the things that you just learned. Right? Now, I have Bob who's behind me. I often have my rubber duck or my Bulbasaur sitting on my desk. And once I learn a new concept, I stop and I talk out loud to Bob or my Bulbasaur. And I just say all the things I learned. And the reason why we do this is because there's evidence that shows if you actively recall, right, you actually learn, right? And so the study that's the big one that Ali Abdaal is using this chart from was I believe it was a biology textbook. They had different groups of folks, and there was one group that had to read the biology textbook 4 times, that chapter 4 times. It was a chapter of biology textbook. They had to read it 4 times, and then a week later take a quiz. All right. Then there was a group of people that read the chapter once, actively recalled. All right, here are all the things I learned. Here are all the things I did, and then a week later took the test. The group that actively recalled, aka just read once and talked out loud, did better than the group that read it 4 times. So could you imagine your life where you do a quarter of the work, but you do better when it comes to your learning goals? That's what active recall can do for you. So please, if you're investing anything in learning or learning how to code, watch this video by Ali Abdaal. They're going to break down why active recall is so important, show you the science, and it has been the difference maker for my students. Please don't watch a tutorial. Don't listen to me. Don't read something if you're not going to active recall at the end. All right. Now, this study is not the most scientifically valid because it was a study of one, but it has been somewhat repeated. But it's an interesting observation nonetheless. So there is this gentleman that started to try and remember 3-digit letter combinations. And so they would learn a 3-digit letter combination and see how long it would take them to forget that 3-digit letter combination. And what they found is that like after 20 minutes, there was like a 40% chance that they completely forgot the 3-digit letter combination, right? And by the end of a month, there was like an 80% chance that they just like completely forgot it, right? So that means if you are embarking on a learning journey and you put in all of this hard work to learn how to code, there's like an 80% chance at the end of a month you forget it all. So please, if you're investing all this time into learning how to code, you have to flatten your forgetting curve. And the way that we flatten our forgetting curve is by resetting it, by seeing the information again and again at the appropriate interval. And the way that we're able to resurface this information that we've learned at the appropriate interval is through something called spaced repetition. The idea that there's an algorithm that's working behind the scenes to show us the content that we need to review at the appropriate time to review it so that we don't forget stuff. Index cards are not spaced repetition, right? Like if you're like doing like notes on cards, that's not spaced repetition because there's not an algorithm behind it. Yeah, it might help you a little bit, but it's not surfacing the right card at the right time. So we use tools like Anki, A-N-K-I, or Anki, however you want to say it, that is like flashcards or index cards, but there's an algorithm behind it that shows us the appropriate card at the right time. And so you want to make this part of your daily practice. This is one of those things that you should be doing every day, getting that repetition in. Right? And the reason we want to get that repetition is so we don't forget stuff. Ali Abdaal has another wonderful video on this that I highly recommend that you watch. If you're ever in chat, you can do !learn That is the Coursera Learning How to Learn course by Dr. Barbara Oakley. Phenomenal course. Teaches you all the study tips that we should have been taught day one in school, but we were never taught. And then if you do exclamation point study tips, that'll link you to the Ali Abdaal video where you can learn these things in a really concrete way. So please, if you're only going to do one thing, if you just click off this video and you never listen to me again, please do the Coursera Learning How to Learn course and watch these videos by Ali Abdaal. It will literally change your life. Okay. Hey, Sam, what's going on? Hope you're doing well. All right. Anki is great. I've been having some great improvements since working on my bank. Hey, that's what I like to hear. Alrighty, let's keep it rolling. Now, the other big thing is, what do you want? Why are you here? And I always like to ask my students this, because the students that are successful are the folks that want it. And there could be so many different reasons for why you want it. This is the average software engineering salary right now in the US at $92,000. And this is the exact number that my students hit in December. So my most recent cohort of students at Resilient Coders, they graduated in December. We have a 94% placement rate, and they have a starting salary of $92,000. And their salary is about to go up because a lot of them have like convertibles after like the first 3 to 6 months, and so our like average base salary is going to jump up to like 101,000 or something like that. It's gonna be wild. So a lot of them had like smaller starting salaries, and then it bumps up once they convert. And so our starting salary matches this right now, and it's actually going to go up. This is the best time I've ever seen for folks to get jobs. And I know it sounds counterintuitive because of the pandemic, but it really has been the best in terms of people trying to hire students and in terms of our students getting jobs. And so please, there's a window open to a job that pays well, that is literally the happiest career for like the past 5 years running. And if you work at certain companies, you might even have a slide in the office. And so I always ask my students, if you want it and there's something that clicks, right? There's something that clicks. And when it clicks and you know your why, learning to code becomes a lot easier. So find your why, right? And use that as the source of where your discipline starts. My wife said you're the Bob Ross of software development. Hey, I'll take that compliment all day long. Appreciate it. Is that the Ticketmaster? I know this is Ticketmaster's office. I don't know where it's at. Probably, if that's their main one, yeah. Sounds awful. Another Amazon recruiter reached out. I feel like it's a sign from the universe to keep going. Hey, yeah. The Google office in Cambridge, they have a fire pole, and you can take the fire pole between the two levels of the building, and next to the fire pole is like this. It's like a big like, I don't know, like you go to like a museum and there's like things on the wall, like the history of something. They have a history of the fire pole, and it's like a timeline. It took them like 10 years and like legit lawyers working with the city of Cambridge to get this fire pole, because they had to like do all this zoning stuff and weird things. But eventually, after like 10 years of like lawyers basically almost suing Cambridge for a fire pole, they have one. And so some of these offices are wild. And I really don't like, honestly, I don't like talking about FANG that much. I think FANG is a goal that a lot of people are trying to sell you so that you buy their course and they make a lot of money and you don't wind up with a great job. So I try to stay away from it. But even at the smaller companies, even at these startups, or not so much startups, but like these smaller companies that just want great engineers, you're going to have good pay. You'll probably be happier. Your work environment is often great. Almost none of my students have to like clock in. Almost all of my students get really great paid time off. Almost all of my students get really phenomenal benefits. Almost all of my students get paid extremely well, and overall kind of just enjoy their jobs. And so that's what I want for all of y'all. I want you to be paid well, to be happy, to have benefits that can take care of you and your family. And right now there's a window open, and it's the widest I've ever seen the window open, that if you buckle down, you learn these skills, right, you can do it. So there's also another tangent to this that I think is really, really important to talk about. And let me pull this up real quick. Let me see. I actually don't know it off the dome because I haven't looked at it in a second. Let's see. Hold on. I'm going to pull up how much money's... I'm not going to do the exact number. I'll release the exact number on Tuesday, I think. All right. Students that have done 100 devs. We already have 7 folks with jobs, which is wild. And they're at great companies. We have 1 person that's at Dropbox. What? All right. So we have 7 folks that already have jobs. And our students have made over $60,000 in freelancing. All right. Over $60,000 in contracts that they've made for web development related stuff. They've contributed to so many open source projects, helped so many nonprofits and grassroots organizations. But that's wild. The fact that you came, you listened to me talk on Tuesdays and Thursdays. You put in a lot of hard work, but the fact that our community's brought in over $60,000 in contract work, we've gotten 7 jobs already. I think that's a testament to that window being open right now. So whether you want a phenomenal job or you want to make some extra money consulting and doing freelancing, it's possible. And it's more possible than I've ever seen it be possible. And so now's the time. Join us. LeonNoel.com/Discord. We have over 3,000 people that want to help you be successful in learning how to code. We have folks that are going to help you with your code. We have folks that are going to help you with your networking. We're going to have folks that are streaming, part of the stream team. We have folks that are writing things for the blog, trying to make it so you have all the resources that you need to be successful. So now's the time. It's the best time I've ever seen. I've been teaching the code for 10 years now. I've helped hundreds of folks get jobs, but this is the best I've seen it. So get in now. Alrighty. If you're learning to code, or maybe you're coming back because you're trying to catch up, there's one thing that my expert in residence at RC said that really stuck with me, and I really believe it. When we're all babies and we're trying to learn how to walk, it comes down to 2 things. It's half hard work, getting up, falling down, getting back up, falling all over again. But the other half is looking around at all the adults and seeing them walking, some of them running, and believing that I can do it too. That's what a baby does. A baby puts in hard work, but they also believe that at the end of the day, they can walk. And learning the code is the exact same thing. It's half hard work and half just the belief that you can do it. And a lot of folks give up because they lose that belief. They start the doubt starts to creep in. They start to doubt that they can eventually learn to walk. But I've had students from all spectrums, right? I've had students from all walks of life. I've seen them overcome some of the wildest adversity and learn to code. I really do believe in my heart of hearts, and I wouldn't say if it wasn't true, that anyone can learn to code. Now, it's not that coding is for everyone. That's an important distinction. But it's that everyone has it in them to learn to code. Now, for some people, it might take them a month. For some of them, it might take 2 years, right? Timeline's a thing. But I really do believe everyone can learn to code, right? And so it's half hard work, and it's half that belief. It's looking around and not getting discouraged because you see some folks walking a little bit sooner, right? A baby doesn't look at somebody else walking and go, God dang it, they're walking. There's no way I'm ever going to be able to walk. Look at how good they're walking. Look at them. Look how great they're walking. I'm never going to be able to walk like that. Like they got 2 steps. Look, they got a little skip in their step. They're doing like the electric slide. The baby's at the barbecue. Auntie's doing the electric slide. The baby's not sitting there going, I'll never be able to do that. They learned that so quickly. Look how good they're walking, right? They've never done that before. Baby doesn't think that way. Baby's like, I'm going to learn how to do that. I'm going to figure out how to walk. I'm going to figure out how to get there, right? And so when people are starting to think about code, for some reason they let it get into their brain. They look at other people coding and they go, I'll never be able to do that. I'll never be able to code like that, right? But it's the same thing. It's the same thing. It's the same thing as walking. You will get there eventually. You're going to fall a lot. You're going to get up. You're going to fall down. Maybe you start to walk a little bit. You start to feel good. Maybe you're at that first barbecue. Your crush is at the barbecue and the electric slide comes on and you're looking at your crush. They start doing the electric slide and you're like, I don't know how to do the electric slide. You start to feel bad. You like go sit back down at the table. You don't want to. You'll get there. Is it going to be awkward? Yes. Is it going to be hard? Yes. Will you stumble and fall a lot? Hell yes. What's the electric slide? The electric slide is a dance that we do at parties. Here in the U.S., I don't know if it's an international thing. It's like a line dance. Right? It's like a line dance. I don't know if you know what a line dance is. Yeah. I still love the sounds. Right? You're at the point where you need to believe that you can do it. Right? You're at the point where you need to put in the hard work. You can't be looking at those around you and getting upset because just like a baby's looking around, they're not going, oh, I'll never be able to walk like that. Right? And you have to understand that there are 2 big things going against you. The first one is something we call imposter syndrome, where you just never feel enough. Right? You just never feel enough. 103, hey, thank you for the hydration. Cheers to you. You just never feel enough. And the really horrible thing about imposter syndrome is there are things that you're good at and you still don't feel like you're good at them. Okay? And so when you're learning to code, imposter syndrome is waiting for you around every single corner. For a lot of folks, they will never feel good enough. For a lot of folks, that feeling of not being comparable to others is the thing that stops them. And so it's the reason why I like to talk about it right now. I've been doing this for 10 plus years. I still feel imposter syndrome on like a daily basis. I still feel like somebody's going to figure it out. The gig's going to be up and somebody's going to figure out that I don't know what I'm doing. Right? It doesn't go away for a lot of folks. And so one of the things that you're constantly battling is this feeling that the things that you actually know, and that you have the skills to learn the things that you don't. And so dealing with this is one of the hardest things to overcome when learning how to code. Learning to code is not an exercise in like logic or math or reading a book. It's really an exercise in feeling dumb constantly and not letting that keep you down, right? And the reason why you don't let it keep you down is because you want it. You want a great salary. You want a happy career. You want to change the lives of you and your family. And so you're willing to overcome this idea that it's going to be really hard to learn how to do it, that every step of the way you're going to feel like you can't do it and that everyone else is doing it better than you, and you're not worthy of learning, that you're not worthy of interviewing, that you're not worthy of working on a team, that you're not worthy of showing up to get things done. But that's all bullshit. It's all 100% bullshit. You'll get there eventually at your pace, and everyone's pace is different. You'll get there. But to get there, you have to go through the trough of sorrow. All right? Hey, Funny, thank you for the 8 months. You are all absolutely incredible. Oh, ready for that back end today, I see. Right? You got to get through the trough of sorrow. And that's the hard part. Uh-oh. Just did something to my throat. My throat don't feel good. You got to get through the trough of sorrow. Right? And for everyone, that process, that making it through, it's a journey. For some folks, it's a short journey. For some folks, it's a long journey. But it's a process. And to get through that process, to make it through the trough, right? To make it through the trough, you're going to have to pull and muster all that strength to make it to the top of Tutorial Hill. You're going to rock it down into this wearing off of novelty. You're going to go through this long trough of sorrow that might take you a year. And towards the end, you might start feeling like you can build stuff, and you're going to crash even further. But eventually you'll make it to these wiggles of false hope. And eventually you'll make it to the promised land. The trough of sorrow is a long journey. For some of you, it might be a few months. For some of you, it might be a year plus. But you can make it through the other side. And the best way to make it through the other side is to have a community. Folks that are going to help you when you get stuck. Folks that are going to help you feel like you're not alone. Folks that are going to help you feel like that it's not just you. And that's one of the best things we have about 100 devs. You can go on 100 devs. We have a couple of really good channels for this. We have all of our help channels where people are helping with your code 24/7. We have our struggle bus channel where you can see other folks that are going through it too. Right? And so please, if you're learning to code, don't do it without a community. Right? Because that's going to be one of the things that help you stay on track. It's going to be one of the things that when you get stuck, you get help. So you can always do !100 devs here in chat, leonnoel.com/100 devs, and join us. We want to help you. Alrighty. When folks are learning how to code, specifically as adults, there's the 3 big things I always tell that they got to keep in check. You got to be able to manage your frustration. You got to be able to stay consistent. And you got to take care of yourself. The managing frustration is a big one. There's this research that went around about like when adults learn the ability to learn new languages, like spoken languages or written languages, like French, Italian, things like that. And what they found is that adults really don't lose that full ability to become fluent. It's just once they're older, they have more responsibilities and they get frustrated way easier, right? And so I think folks that are learning to code later on, the big thing that they don't realize is that it's super frustrating, and every day you're frustrated. Every day something doesn't work. Every day something breaks. Every day it doesn't go your way. And as an adult, your life is in your control, and you can say to yourself, you know what? Screw this. I'm not going to keep being frustrated. I'm going to go watch Netflix, and I have the ability to do that. And that's what happens. People get frustrated over and over again. They start to feel that imposter syndrome, and they say, you know what? Screw this. Fire up the circle. The new season's pretty fire, I'm not going to lie. And they forget the code. The other thing they forget to do is to be consistent. You cannot chunk learning to code. Meaning that you can't just do it one day a week. Because if you just say, you know what, I have Saturdays off, that's when we're going to learn how to code, you can't do it. You'll skip a Saturday, and then one skip Saturday becomes two, and then by the end of the month, you're back to where you started and you're not learning to code. Learning to code should be a daily thing. We know about spaced repetition. We know that resetting our forgetting curve is a really important thing to do, right? Circle watch party on Wednesday. That actually be pretty funny. We can do it on Discord, I think, right? You got to be consistent. It should be a daily practice. You should be coding every day. You should be reviewing your Anki every day. And it really is about resetting your forgetting curve. Even if you only have 20 minutes, that's what I want. 20 minutes of consistent a day. And then lastly, taking care of yourself. Learning to code is a very physical exercise. People think about like learning to code, oh, you're not doing anything like no. Learning to code, you're using fingers you never used before. You're doing repetition that you've never done before. You're sitting a lot more than you might have, right? And so there's like this idea that if you're learning to code, people kind of like get in the zone and they forget about everything else. You can't do that. My wrist constantly hurts. Pretty much this past month, I just haven't been able to give it enough rest. So every single day, my wrist is just on fire, right? Since my wrist is constantly on fire, it's due to early on in my coding career where I didn't take care of myself. And now literally I get pain so bad that I can't use it sometimes. You're going to be doing repetition, hitting keys that you haven't normally hit. You have to be taking breaks. You have to be taking care of yourself. You need to be getting up. You need to be moving around. You need to be changing your position. You need to be giving your hands and fingers rest and breaks. You need to be giving your eyes rest and breaks. Looking out a window, looking at things in the distance, taking care of yourself. All right. My lower back is so numb. I force myself every hour to get up in a chair and stretch. You have to. Rasta, I'm sorry to hear that. But yeah. Try yoga chat. Yeah. Dev yoga. That could be a thing for sure. Yeah. And so make sure you're taking care of yourself. If you're doing this whole journey, you got to put in the work to take care of yourself. All right. And last but not least, don't let your dreams be dreams. Right? Know your why. Know why you want this. And then go after it consistently every day. What up, Neptune? Right? Don't let your dreams be dreams. You can do this. Just like you learn to walk, you can learn to code. You got this. And then one last stab, please. As Dr. Eric Thomas says, you. Do your active recall. Do your spaced repetition. Don't do all this and then not do your spaced repetition. If you're not doing Anki, now's the time to start. Do your Anki. You. I see you slipping. I see you not doing it. And you're going, I don't understand why some of these concepts ain't sticking. Don't understand why some of these things ain't making sense. Not sure how we're building on top. Can't come to me and say, Leon, things don't make sense if you haven't been doing your Anki. You can't come to me and say, Leon, it doesn't make sense if you haven't been doing your active recall. If you haven't been doing your active recall, you haven't been doing your spaced repetition, you get zero excuses and zero sympathy from me. You have to do it. You have to. There's no other way. This is the way. You have to do your spaced repetition. You have to do your Anki, or it's just not going to work. It's just not. All right, folks. Where are we at time-wise? We're in a good spot. Let's go ahead and take our break a little bit early today. So let's go ahead and take a 5-minute break. When we come back from our 5-minute break, we're getting into what is the internet, how does it work, and starting from there. So let's go ahead and take a 5-minute break. If you're new here, we take 5-minute breaks at the top of the hour to stay healthy. I'll put some musics on. Is this a review of everything back up to this point? Yes, it is, EJ. Might as well tidy this garage a bit. Hey. All right, folks, please take a break. If you're able to, get up. If you're able to, get some hydration going. Just gonna go ahead and set up my. Cool. Just gonna get the whiteboard going before we come back. I'm also gonna run some ads, just so that you're forced to take a break, and then also, so anybody that's new joining us doesn't have to sit through the starting ad. So I'll see you all in 3 minutes. What is Anki? Anki is our space repetition tool. It's basically flashcards with an algorithm behind it. I have no idea how long this is going to take. EJ, just Google Anki and you'll see the different programs you can download. You can download on your desktop, your mobile phone. Yeah. It's actually a yellow mug. I don't know, like, it totally does not match my chroma key at all. It's definitely yellow. When I come back this way, like, I'm a little green right now. Like, I still got to figure out the colors a little bit better. So I guess it's still not a full chroma key match, but all right, folks, I'm going to stand up too for a second. Burb. Oh, yeah. I was watching a streamer who had a bunch of tattoos on his arm, full sleeve, with 60% of the colors made it seem see-through. That was really cool. That's funny. I've never heard it pronounced burb, and now it's part of my life. Yeah, there you go. You're welcome. Glad to have an impact. What is your schedule? Our class takes place every Tuesday and Thursday at 6:30 p.m. Eastern time. And then we do office hours every Sunday. You can do !100 devs if you want to learn more. We're running a free 30-week software engineering bootcamp. So far, we've done all the front end. We've learned the back end with Node. We're about to jump into React. But !100 devs will give everything you need to know about how to join us. When is Bob going to be an animated filter? 100 devs. !100 devs. There you go. That's the link. All right, got about 30 seconds left. Can you get a dev job without knowing a framework? Absolutely. !Discord if you want the Discord. I've helped hundreds of folks get jobs. Most of them know full stack web development, meaning HTML, CSS, JavaScript, Node, and a little bit of React. And that's enough to get them jobs. How long will be the backend review? I have no idea. Depends on how many questions you ask. It could be 2 to 3 hours, could be 10 hours. I have no idea. This is a really hard one to guesstimate. Then let me know the name and model of your 3D printer. I have the Ender 3 V2 by Creality. ENDER V2. I think it's pretty good too. Like this is a great, like, that's pretty solid. And I'm not like good at it yet either. Like I'm not really good at like optimizing it. Like some of my friends are like really good at it, but from one of my first prints for it to come out this good, let's go. The details are dope too. You know? And it's like, I mean, when I say it's not expensive, it's really like I understand $300 is a lot, but like out the door, everything for $300, including filament, to be able to build whatever you want to build is pretty wild. Yeah. All right, folks, come on back. Seems like a fun hobby. Yeah, it's really cool. And the neat thing is that there's so many free models out there. Like whatever you want, you can find a model for. And so I've done some really cool stuff. Like I've built like Pokemon, like you saw. I've built like a self-watering planter, cookie cutters for blah. Like I've made a lot of cool stuff. So I have a friend with a 3D printer. It's like having a friend with a pickup truck. I agree. All right, folks, come on back. Yeah, Neurotic, we got to update it. It's Sundays now. We're going to update it after today because we got to add the new crash courses. All right, folks, come on back. We're going to talk about how the internet works. Whoop. We're going to talk about how the internet works, and then we're going to get into it. Alrighty. So, chat. What's the internet? What's the internet here? This was a question on the interview that I did. That's wild. I'm so glad you got this. A lot of folks have been telling me they've been getting questions that we've asked in class. So I think Funny said they got FizzBuzz, which is hilarious. You're getting how the internet works. That's wild. Yeah, I like to think of the internet starting off with a wire. So I'm going to have a wire. And that wire is going to connect two different kinds of devices. We are going to have client-side devices. And we are going to have servers. Now, if this is something new to you, you should probably be watching our front-end crash course first, because we go into this in a lot more detail. So we have client-side devices and we have servers. Chat, what are client-side devices? What are client-side devices? Laptop, that's a good one. Phones, smart TV. Yeah. Client-side devices are devices that we use to consume the internet, whether that be our laptop, our desktop, whether that be our smart TV. Typically, our client-side devices have something like a browser that enables us to access the internet, right? But you could do it through other means as well. So these client-side devices are devices that we use to consume the internet. And on the other side, we have these devices that we call servers. Now, both client-side devices and servers are computers. Client-side devices are consuming. And servers, well, what are they doing? What are servers doing? Chat, what are servers doing? Yeah, they're serving up stuff, right? they're sending, they're figuring out what to send and how to send it back, right? So client-side device, we typically have like maybe a laptop, a desktop, a phone. On that client-side device, we typically have a browser, right? And that browser is typically going to have like a URL bar. We're going to type in a URL. And once we type in that URL, we're going to make a request across these wires and to a server. A server is going to hear that request, and then it's going to start to try and figure out what it wants to do, right? So the age-old example that we like to use here is Domino's.com. I'm not allowed to order Domino's, of course. That's a long story. You come back and watch our crash courses or our first couple of classes to figure out why I can't order Domino's. So we're going to pretend, and we're going to type in Domino's.com into our browser. As soon as we hit enter, we have made a request across the internet to the server, right? And that server is going to hear the request. It's going to hear the request. It's going to hear, oh, they typed in Domino's.com. I heard that request. Now I got to figure out what to do. And so there is going to be code running on this server that hears that request and starts to figure out what to do. This code might need to go and get some data from a database. This code might need to generate some HTML. This code might need to do a lot of stuff. But eventually it figures out what to do, and it responds back to the client-side device. So for a very simple request, like we just wanted to go to Domino's.com, that's a very simple request. That request is going to make it to a server, and that server is going to go, oh, you're just trying to load the home page. So all I need to do for you is get you some HTML, some CSS, maybe some JavaScripts, maybe some images, maybe a video or two. And once I have all this stuff, I'm going to send it back. And then the browser is really good at taking all this data it just received and displaying it back to you, the user. So at a very simple level, our client-side devices are making requests, and our servers are doing everything that needs to happen, right? Doing everything that needs to happen to respond. Now, there's some nuance to this, right? As we start to figure out kind of, all right, how do our servers respond? How do they get the things that they need? That becomes the realm of back-end web development. When we start building out how the servers listen for requests, how they generate the response, eventually we'll call this our CRUD API. Once we start building that out, we're focusing on back-end web development. Front-end web development is coding all of the things that run on the client-side device. So if you're coding out HTML, you're coding out CSS, even client-side JavaScript, that's all front-end. If you're coding out how the server listens to requests and generates responses, that's back-end web development. And with your powers combined, both front-end and back-end, you combine these powers together, you call yourself a full-stack web developer. Okay? So today, we're going to be focusing on the server. We're going to figure out how to make our servers get up and running. We're going to figure out how our servers can listen to requests. We're going to figure out how our servers could generate responses. We're going to figure out how our servers could talk to a database. And we're going to build out our applications so that we're building things that work well for our users. Okay? So that's the quick and dirty of how the internet works. You have client-side devices and servers. They're both just computers. Client-side devices are making requests. Servers can listen, figure out what they're going to do, and then respond. I thought servers were so much more magic before I started this course. Hey, that's what I like to hear. Cool. Questions while we're here before we move on? We're gonna do a quick review of JavaScript, like core JavaScript fundamentals, and we're gonna keep pushing. Questions about how the internet works. If you're new, we have a full 2-hour course on this whole thing. It's our first class on YouTube, ! YouTube. And we go into way more detail. We start talking about DNS, your ISPs, and all that fun stuff. So if you get asked, what is the internet in an interview? What's the 3-sentence response? Oh, so there's 2 different things. There's the internet and the web. So the internet is the infrastructure that enables computers to talk to each other. We have clients and server-side devices. Client-side devices make requests. Servers hear those requests, generate responses, and send those responses back to client-side devices. So the internet is a series of infrastructure that can be sitting on things like IP, TCP, could be sitting on top of things like Tor, but it's a way of sending and receiving responses and requests. Yeah. How long are we going to be doing this? No idea. No idea. This is a crash course. We're taking our time, trying to feel good, just trying to be relaxed, to be chilled, sipping on some coffee, hanging out with some friends, answering some questions. It's going to come as it comes, right? And so it could take us 2 hours, could take us 24, I don't know. Just because the crash course doesn't mean we're going to burn out. Exactly. Hey, Maria. Exactly. Hufflepuff. My guess is 9. Alrighty. Let's keep pushing. So Reggie said hot tub stream is OnlyFans. If you're not aware of the Twitch meta right now, there's a lot of hot tub streams. And so I did price out a hot tub. I was looking online how much hot tubs cost, because I thought it'd be hilarious to do a hot tub stream when we hit the OnlyFans. If somebody hits the OnlyFans, I was going to do a hot tub stream. I think we're really far away from that still, unless some folks get a YOLO. But I thought it'd be funny. Bruh. What influences the response speed between client-side devices and servers? Distance. The closer your client and server are, the faster it can go. And there are dozens of steps in between. I love the sounds. There's dozens of steps in between that can influence it. But our first class does a pretty good job of going through all of them. Yeah. What are CDNs? CDNs stand for Content Delivery Networks, right? And what content delivery networks are imagine if our client-side device was here in LA with me, but our server was in London. So all my requests would have to go from California in the States, across the United States, across the Atlantic Ocean, and to London, and then back with all that information. That can take a long time. What a CDN can do is say, all right, what are the heavier bits of content? Maybe your images. How can we put our images closer to Leon? So they might put my images on a server in, say, Texas. That's a pretty common one. A server in Chicago, maybe one in New York, maybe one in London directly, right? And so the idea here is that my requests don't have to go all the way to London and back. My request might actually go to just Texas and back to California, which would be way faster. So that's what a CDN can do. Today, we're actually going to review the social network application. And one of the things I worked on over the past day or two was one of the downfalls of our social network was that we were just saving the images to Heroku. And I don't know if anybody figured this out, but Heroku is ephemeral. I think I'm saying that right. And what that means is that anything that was new that was saved to the server, once the dynos on that server restarts, all that new stuff goes away. So all the images that we uploaded to our social network, they're all gone because those dynos have definitely restarted. So what I used is something called Cloudinary, right? And what Cloudinary is just a place to store our images. You might have heard of Amazon S3. It's the same kind of similar service. And so what Cloudinary does is just a place to like upload your images, right? And the cool thing about Cloudinary is that they can do things like a CDN. They can make it so that it's faster to get to you. And those are not ephemeral. So those will stay forever. And so when we load all of our images, they're not actually going to be coming from our server. They're going to be coming from Cloudinary. Kat said, what are dynos? So it's DYNO. And it is, so Heroku, the cool thing about Heroku is that you don't have to worry about setting up your server. Like you don't have to provision anything. You don't have to do anything. You just type in a couple lines of code and it just works. Now, the cool thing is that Heroku also like instantly scales. So let's say the 100 Dev social network, somebody submits it to like Hacker News or Reddit. We go viral, right? We go viral. And if we go viral, we want our server resources to scale as more people join us. So with Heroku, we can just have our dynos increase. And as our dynos increase, the amount of resources that our server also increases. Back in the day, if you got what we called slash dotted, you would have to figure out how to make your servers more beefy, bring online other servers, things like that. Heroku handles all that scaling for you, and how they quantize how much resources you're using is by using this word called dynos. That's all. What is serverless? So I'm going to give you a very like dirty overview of what serverless is. But think about our server. Like if you've been like, so this is a crash course. This is a review. Most of you should have already heard all these things before. So if you're new, there's gonna be some things that we're just going to talk about that might not make 100% sense. But I'm doing this crash course in a way that should be review for folks that have been following along. But please ask questions if things don't make sense. Okay. So serverless is this idea that our server is like pretty resource intensive, right? I have a really nice computer in my room with me, right? And in the morning, if I so my computer has a 3960X, which is a Threadripper CPU that pulls in 280 watts of power. My CPU pulls in 280 watts of power. I have a 3090, which I believe is like 350 watts. So that's a lot of watts coming into my computer. It generates a lot of heat. So sometimes in the morning, if I've been running, like I like to run folding at home. Well, not folding at home. I like to run, it's similar to folding at home, but I like to run, right now I'm doing simulations for COVID-19. And so if I leave that running all night, I come in and my office is just warm. It's hot because that thing's been going all night. It's super hot, right? Like the room's just warm, right? And so the idea, our servers are kind of the same thing. We have a server that's running 24/7. What if nobody's using our site? What if like nobody's coming to our social network? Our server's still running. It's still consuming resources. It's still something I have to pay for to keep running. And so serverless is this idea is that what if we kind of made all the things that we needed for our server just to be requests, and those requests would like run automatically, and there's nothing that we had to keep running all the time. So we're consuming less resources. Maybe it might be cheaper. And so the idea of serverless is this idea that maybe we don't need this like huge thing going 24/7, and maybe we can just make requests to things that enable us to have serverless functions and just have them run on demand, right? So that's kind of the idea. I wouldn't worry about serverless right now. I think you should learn this first. I'm a big fan of learning the basics first and then figuring out what benefits you might get from serverless. I'm also not one of the people that have bought into it as an idea. I've tried it. It actually makes things a little bit more complicated for me. I haven't seen like the savings a lot of people see, and so I'm not one of those people that have bought fully into it yet. I'm willing to have my mind changed, but I've seen it hurt a lot. So there you go. What's folding at home? Folding at home is where you can use your computer's resources to do like scientific research that's basically doing protein folding. And so protein folding is really computationally expensive. And so the folding at home project enables you to distribute that research to people and on their computers at home. And so the researchers can say, oh, I want you to do this thing. And then everyone on the network will go ahead and start doing those computations and sending the data back to the researchers. So pretty much the whole pandemic, I've been doing the folding project for COVID-19 and some other fun stuff. Yeah. Cool. Alrighty. Let's keep it moving. How can I volunteer to fold at home? Just look up folding at home, and you literally just install an application on your computer, and that's it. Alrighty, folks, let's get back to it. Let's keep pushing here. All right. Programming. Let's do a quick overview of programming. Let's do a quick overview of the basics of JavaScript. We're not going to spend any too much time on this. Like I said, this is a quick review. If you're new, we have full classes on this. Robo, thank you for the hydration. Cheers to you. Alrighty. Why, hello, Mashi. Come here. Come here, girlfriend. Come on. So if you don't know about Mashi, Mashi has a really wonderful skill. And her skill is that she knows how to open doors. She knows how to open doors. And so Mashi just let herself into the room. Hold on, let's do Big Leon. She just let herself into the room. She hits the door and pushed it open, and now she's here. Hey, Mashi. Her breath stinks. But this is Mashi. And she just woke up, so I guess she's a little tired too. And they're gone. They left. Simba was with her too. Ugh. Burb, let me put them back on. Let's go. It's probably my favorite thing about them is that whenever she wants to come see me, she just boop hits the door and comes in. Is Simba happier now he has a sister? Simba's just kind of indifferent to any other dog, but they're finally like they play a little bit more now together. They've been like laying together. Simba's kind of like me. We both kind of I'm not a people person out the gate. It takes me a long time to get comfortable with people, and Simba's kind of the same way. Did you know that Mashi was going to open doors before adopting, or was it a surprise? It was a surprise. We didn't really know. Leon, that statement is why I left teaching. Hey. I found this thing online called OxyFresh. It's a water additive. Yeah, we've been reading about those. Yeah, we're gonna Mashi has a lot of little things that require a lot of attention. When she came into the pound, she had a huge growth that keeps kind of like coming back. So when we adopted her, we knew that she's going to require like a lot of medical attention, and that's one of the reasons why like she was on a high kill list because of that, because nobody wanted that. So we're taking care of that. She gets these little growths that we got to get checked out all the time. And the other big thing we have to figure out is like getting her teeth cleaned. So we just scheduled all of that, and so. I think it's actually like next weekend she gets all that stuff checked out again. So hopefully like after the teeth get cleaned, we'll do all like the water additives and stuff after that. That way it stays that way. But for now, breath reeks. Alrighty, folks. The big things here that we're talking about when it comes to programming, we had a little doggo break. When it comes to programming, there's a couple big things we got to keep in mind. A computer will do what you tell it to do. And when we're talking about what a program is, all a program is a set of instructions that you write a computer to do tell it what to do. So, computer will do what you tell it to do. A program is a set of instructions that you write to tell a computer what to do. And so if a program is a set of instructions to tell a computer what to do, then programming is the act of writing those instructions, but specifically in a language that the computer can understand. Our computer don't understand, right? Our computers don't understand JavaScript out the gate, right? So let's talk very quickly about how a computer works. Like I said, this is a review. We have full classes on any of the stuff that you want to review. But let's talk about a simple circuit so we can build up to how a computer actually works. So with a simple circuit, we have an LED, we have a battery, and that circuit is complete. Get your nuns ready. So since this circuit is complete, this light bulb should be on. All right. Let's go ahead and do another circuit here. Another battery. This time, however, we're going to have a switch. So right now, the switch is open, so the light bulb is not on. However, if we go ahead and close the switch, the light bulb turns on. All right. So chat, what is a very simple way that I could represent an open or closed switch? Yeah. I could say if the circuit is open, we'll use a 0. And if the circuit is closed, we'll do 1. So let's make our circuit a little bit more complex. Let's have 2 switches. Have our battery down here. And right now, both of our circuits are open. All right. So how could I represent this circuit, chat? How could I represent this one? Yeah, I can say this is 0, 0. All right. This one is open and this one is open. All right. If I would close both of them, how could I represent this circuit now, chat? 1, 1, exactly. And so this 1, 1 is a very, very simple bit of logic. Chat, what is this very simple bit of logic that we have here when we say 1, 1? Yeah, it's a Boolean. It's and, right? We're saying this one and this one are both closed. And so this is a very simple overview of something called logic gates. Our computers at a very, 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 very simple level understand on and off. From on and off, we can build up logic. From that logic, we can build up to a very simple language that our computer can understand, right? Then that very simple language can be built up to languages that are a little bit more human readable. But those languages that are a little bit more human readable often have to be broken down into something that's closer to what the computer can understand. Okay, so we're going to get into Node, and Node actually gets broken down, right? We have an engine that breaks it down for us into something that the computer can actually understand. So you got to keep that idea in our mind because we're going to come back to that later on. And then, of course, chat, how's Independence Day a true story? Bub, binary upload, boom, exactly. I just love that in the last century we've gone from people's computers to what we have today. I agree. Computing is just the most amazing thing in my life. Like it just blows my mind. Exactly. Independence Day is a true story. Aliens attack. We try everything we can. We throw our nukes at them, everything, nothing works. What we did realize is that the spaceship that crashed that we had in Area 51, when the mothership came close, that got its power. So there are some interesting things between like the power system and proximity. And so if we were able to bring down the power on one, maybe it'll bring down the other. Maybe there's like a communication link that's happening due to proximity. And so we had this idea of injecting a computer virus that would bring down the shield or that power system or that communication system. And once that came down, the shields would come down and then we could nuke the crap out of them. And so Jeff Goldblum wrote a computer virus. We flew that into the mothership, uploaded it. The shields came down. We nuked them, saved the world, America. Right? Now, how did Jeff Goldblum write a computer virus for an alien civilization? How is this a true story? How could this be a thing? Ah, yes. Because Jeff Goldblum reverse engineered, took that alien language, broke it all the way down to its universal truth. I like that bit about it, right? This idea that on and off was a universal constant, even with aliens. And so Jeff Goldblum took it all the way down to that binary, all the way down to those zeros and ones, those on and offs. And once it was on and off, built it up to those simple logic back into something that could work on the alien mothership. So Jeff Goldblum broke it all the way down to binary, uploaded that crap to the alien mothership, boom. Binary, upload, boom. Also the name of the best social network out there. Missed that scene, I have to rewatch Independence Day. Hey, you know it's a good day when you watch Independence Day. Leon, do you think you could do that? Hell no. No way. Y'all dead. Sorry. Y'all gone. Peace. No way. And the sad thing is I spent some time like trying to figure it out because I got really into Tamagotchis for a while. Or I never say it right. But I got really into Tamagotchis for a while. And there's this woman that has an amazing talk on Tamagotchi reverse engineering. Hold on, let me see if I can pull it up real quick. Yeah, there's just this amazing talk. Here we go. Boom. Let me put this in chat real quick. So yeah, that talk got me really into reverse engineering. And then there's this other person on Twitch that does a lot of reverse engineering. Hold on, can I find their Twitch real quick? I don't see their Twitch. Here's their website though. I'm going to share this because I think it's really cool. So that video is probably one of my favorite like engineering videos of all time. Many Tamagotchis were harmed in the making of this video. Basically, they reverse engineered Tamagotchis, and I tried getting into it, and it was a lot of fun for a while. But it's a big skill, and it takes a long time to get good at it. Scanlime is one of the best people I've ever seen at it because they do it live. So like you don't get to see people doing it often, but they do it, and it's so cool to see. And they had a thing for a while where you could send them anything and they would try and reverse engineer it, which I thought was really cool. So they would get like these random, just like things, and then they would try and reverse engineer it. So I thought they were pretty cool. If you have time, definitely watch Scanlime and definitely watch that video. Really cool to see like how people that really know what they're doing when it comes to reverse engineering, like do it. Yeah, but yeah, y'all gone. I'm sorry. I apologize. I can't do it. I would try, but it like we would upload it and it would just like change the color. That's what I could do. I could definitely change the color. Maybe like the color of the force fields would change, but I don't know if we're bringing them down. All right. Let's do a quick JS review. Like I said, this is just a quick review. We've definitely spent 3 or 5 classes going over this stuff, so you need to go back, YouTube. Alrighty. Quick review. Variables. Variables enable us to store values to be used later on. There are 2 steps when it comes to our variables. The declaration step, where we declare that variable into memory, and the assignment step, where we give that variable a value, right? We can do both at the same time. So here I'm declaring a variable called age and assigning it the value of 25. We have conditional syntax when it comes to JavaScript as well, where we check to see if a condition is true. We have ifs, else ifs, and else. So if, we'll check the condition. If the condition is true, we'll do what is inside the curly braces and then stop. But if the condition is not true, we'll go on to the else if. And if what is inside the else if is true, we'll do what's inside the curly braces and then we will stop. You can have as many else ifs as you would like. So you can do if, else if, else if, else if, else if, else if, else if, until kingdom come. And if you want, it's not necessary, you can also have an else. An else automatically runs, meaning that it does not need to check anything. If all these values above it were false, the else will automatically run. Cool. So here is our classic conditional syntax. Chat, what is being put into the console here? What would go into the console here? All aboard the train to Flavortown. Exactly. All aboard the train to Flavortown. And the reason why it's all aboard the train to Flavortown is because pizza equals Domino's. That's a const. It's never going to be reassigned, right? Pizza will always be Domino's in this house, right? And so does pizza equal Papa John's? Hell no. So then we go to the else if pizza equals Domino's. That is true. So console log all aboard the train to Flavortown. I read an article like last week about Guy Fieri. Guy Fieri is a real one. like a real one, like donated so much money to restaurant workers during the pandemic. It was wild. Like, big ups, big respect to Guy Fieri. I didn't know that. Like, I didn't know they did all that, but they put in work. They put in work over the pandemic to like keep people paid and like keep restaurants open. Like, they put in the most. Like, there are folks that did stuff during the pandemic. We all try to do our own thing, but Guy Fieri went to town. So big respect. All aboard the train to Flavor Town for real. Danger, Will Robinson. When should we worry about, what is this assignment versus comparison that I'm worried about? Why do I have this in danger here, chat? Yeah, Imran got it first. The thing we have to be careful about is 1 equal sign versus 2 equal signs versus 3 equal signs. 1 equal sign is always assignment, meaning we're assigning a variable a value. 2 and 3 equal signs are comparison. 2 equal signs is comparison in just value. 3 equal signs is comparison in value and type. We can also have multiple conditions here. So if name equals Leon and status equals Ballin, you get a wink. All right, get a wink. Can also have an or. All right, if day equals Saturday or day equals Sunday, you know that it's the weekend. So we saw this kind of conditional logic when we were doing this very simple logic, right? Same thing here. You can do and ors and a bunch of other stuff inside of your conditional logic as well. Just trying to get you all prepared for that OnlyFans. Only 1 million channel points. Could be yours very soon. We'll do a hot tub stream. Y'all don't know if I'm joking or not. That's how I like it. That's how I like it. All right, functions. Functions are just simple sets of instructions. They should be reusable. They should perform one action if it's the best practice, and they form the basic building blocks of a program. So here's the normal function syntax. We have the function name, the parameters, which will be like variables inside of this function, and then the function call. Our functions won't run unless you call them. And when you call them, you pass in arguments. Strike, thank you for the hydration. Cheers to you. Robo says, I can't tell. Only one way to find out if they're joking or not. Exactly. Alrighty. Here's a function. Function's name is yell. It has a word that gets taken in, and then it alerts that word. So if we were to run this, we would pass in hello. Hello is the argument that gets passed in. I should draw this. Wherever we see the word, it's now hello. So when I alert word, I'm actually alerting hello, and we would see a hello come up as a pop-up, right? Very simple. You can pass in multiple arguments. So in this case, hello gets put into word, goodbye gets put into other word. Wherever I see word, it's alerting hello. Wherever I see other word, it's alerting goodbye. Just getting our repetition in here, folks. Loops enable us to repeat an action a certain number of times. We have many different kinds of loops in JavaScript: for, while, do while. We have lots of methods. You should be working on your array methods this upcoming week. And so you're going to see things like map, reduce, filter, these other things that might give us the ability to do looping, for each, things like that. But basic loops: for, while, do while, built into JavaScript. And they just enable us to repeat something a number of times. Here's a simple for loop. We set up our counter or our increment. We say when we want the loop to end and how much that increment goes up every single run. and we're printing I. So in this case, we would see 1 get printed to the console because I is 1. Then we add 1, 2, 3, 4. Then we add 1 to 4. Is 5 less than 5? No. So we stop. So we'd only see 1 through 4 being printed to the console here. Blog, can you put that tweet in chat? That'd be good for folks to have, if you have it handy. All right. Remember, arrays are just data structure to store an ordered collection, right? It's just a way of storing multiple elements inside of one structure. So I like to think of toasters. Bill Gates has not gotten back to us yet, unfortunately. In these toasters, we can store whatever we want. We can put a string. We could put a number. We could put a boolean. We could put some sort of variable. We could put another array. We could put objects. So our toasters or our arrays are just one entity that can store multiple things. So I think of a toaster. You could put a piece of bread in one slice. You could put a hot pocket in the other. You could put whatever you want into these toasters, right? Same thing here. You can declare an array or create it in one of two ways. Literal notation using the square brackets, or object using the constructor way. So here's what an array could look like. You declare a new array. You give it the value of string zebra, boolean of true, and number 21. You can have all these different data types in an array. It does not matter. The really interesting thing about arrays is they are zero indexed, meaning that we start counting our indexes at 0. So New York City is our first element, but it is the 0th index. And we use those indexes to get stuff out of the array and to put stuff into the array. So here, I'm saying new array index 0, that would give me zebra. New array index 1, that is undefined because there's nothing inside of that position in the array. Empty spaces take up positions in the array. If we did new array 3, that's going to give us the 4th element or the 3rd index. Cool. Powering through this, just quick review. I want it in your head here. ATX Pete, hey, thank you for the 2 months. Hope you're doing well. Thank you for being here. Appreciate that. Cool. Objects, like I said, we're steaming through this real quick. I just want the syntax in your brain a little bit here. Objects are just a collection of variables and functions, right? They represent the attributes and behavior, right? The attributes and behavior of something, and it's just a keyed collection. You have, I like to think of a physical object here, whatever its attributes and behavior. So I like to think of a stopwatch. A stopwatch could have a current time property or a tell time method. And so that's what we see here using chat. What type of notation is this? What type of notation is that? What are we seeing here? Cool. Dot notation. Nice. Seems nice. Lovely dot notation. I love it. Cool. Power review here. And then if we're creating objects and we're creating a bunch of them, we might need some sort of factory. So back in the day, we had our constructor functions. Now we have classes. Our classes are just templates for making new objects. If this looks scary to you, definitely go back and look through our JavaScript review. Might even look at our front-end crash course that goes through this as well. And so we have the ability of creating new car objects that have all of these properties and then also these methods. So Honda Civic would have a make model of Honda, a make of Honda, a model of Civic, a color of silver, and a number of doors of 4. But it would also have honk and lock methods as well. Cool. Let's talk about APIs. Chat. What's an API? Chat, tell me what's an API? What is it? What's an API? Ooh, simple interfaces. I love it. A menu, okay. Application programming interface, cool. But what is it? An easy way to do complex stuff. I love it. After party invite. Set of rules for allowing a client and server device to talk. That can be a type of API. Yeah. Cool. I like these. I like all of these. Let's talk about it. So, an API is often just a simple interface for some complex action, right? It really just lets two things communicate with each other without having to know all the nitty-gritty details. We go to a restaurant, remember those? Right? Remember going to restaurants? Remember those things? You would like sit down and food would come to you, right? So at these restaurants, they often had these pieces of paper. Often they were laminated, and they called that a menu. And a menu was like a list of all the food that they would bring to you, right? And so you could point to something on the menu or ask the attendant there. I forget what they were called though, waiters or waitress, something along those lines. Wait something. You would say, "Hey, I want the pad thai, please," and then the pad thai would come to you. It was magic. Right? So you had this interface, this menu, right? This menu, and on the menu is pad thai. So you would point to it and say, "This, please." And then eventually food would come to you. That was an API. That menu was a simple interface. Now, that menu enabled you to talk to the kitchen without needing to know what the kitchen was doing. You didn't know how long the noodles were cooked. You don't really know what sauces they were using. You don't know how they were cutting the vegetables. You don't know any of that. You just had a simple interface, and you got a delicious pad thai coming back to you. All right, that's an API. You had a simple interface that did something complex and enabled two systems to talk to each other without really knowing how the details were implemented. We're going to see APIs come up over and over and over again. Often, we're going to want to do some complex things. We don't want to know how those complex things are done. We're going to make our own APIs. We're going to make web APIs. We're going to have APIs that are built into the software we use all the time, right? But really, it's just a simple interface for something complex. Sam SB, hey, thank you for the Prime. Thank you for spending all of Bezos' money. I appreciate you. Thank you so much. Thank you for being here. Wolfpacker once said, "Come on, Leon, this is more fictional than Independence Day. A bunch of lies in that story." Yeah, these restaurant things, I'm telling the truth. I swear they exist. Some people say they still exist to this day. You can maybe go find some now. Now that things are easing up a little bit. Free Bezos, buddy. Hey, thank you, Sam. Cool. So we're going to see APIs of all sorts. APIs that we're consuming, APIs that we're building. And remember, it's just a way for two, right? Lets one thing communicate with another thing without having to know how those things are implemented. We were able to talk to the kitchen without having to know how the kitchen was going to put that pad thai together. Right now, we're going to be talking about web APIs that we're going to consume in terms of making a request to somebody else's data. So we're going to make a request from our application. It's going to go to an API, and that API is going to send us some data. In this case, we're asking for some JSON back, JavaScript object notation. When it came to our JavaScript, particularly our client-side JavaScript, right, we are able to make requests to other people's servers. So in this case, you can see that I am making a request to the dog CEO API. I'm going to make a request to this server, and it's going to send me back some JSON data. And in that JSON data will be a cute image of a dog. Okay, it'll be a cute image of a dog. Let's take a peek. Let's see if I can do this inside of the console here. Let's paste it in. All right, so you can see, let me make this a little bit bigger. We made a fetch. We had this thing called a promise that we'll get to in a bit. And when the fetch resolved, we got this JSON object. You can see that it's an object, right? You see the curly braces open and close. We know it's an object. And inside that was the messages property. And so let's grab this messages property. And I'm just going to paste it in here. Oh, look at the cutie patootie. All right. Is this your subtle way of telling us Mashi also runs their own company? Maybe. You never know. All right. First try. Exactly. Thank you, Jesse. So it worked, right? We were able to make a request and get some JSON, JavaScript object notation back. And in that JSON object was an image URL. And we were able to grab that image URL to get a lovely image back. So the cool thing about this API is that we have a simple interface. Chat, what is our interface here? The menu is our interface at the mythical restaurant, but what is our interface for this API here? Yeah. Coder check, KCOS, coordinate. Yeah, okay, I see y'all. Yeah, it's the URL, right? It's the URL. The URL is our interface. And for a lot of the applications that we're going to be building today, the URLs are going to be very important. They're going to be our interface to the APIs that we're building together. Okay. So we're able to make a fetch and we get some data back and we're able to see that that data had an image. Pretty cool. Now it's time for the back end. But first, before we get to the back end, we got to do but first. Before we get to the back end, we need to talk about some other really important bits of JavaScript. We need to talk about like what JavaScript can and can't do, what we can do with JavaScript on the back end versus the front end. We got to talk about these things called promises and build up to it. So we're going to get into the back end. But before we do that, we got some topics to review and we have a break to take. So let's go ahead and take our break. Putting 5 minutes on the clock. Please take a break. Please get up, hydrate, do what you got to do. I'm going to go grab myself some more coffee. I'm going to run some ads so you're forced to take a break, but also so that new folks joining us don't have to sit through those ads when they first join. So I'm going to run that. I'm going to get up. I'm going to grab myself some coffee. Please. This is going to be a long day, folks. We haven't even hit Node yet. It's been 2 hours. We haven't even gotten the Node yet. It's going to be a long day. So please get up, hydrate, do what you got to do. Put some break music on. And I'll see you all in 3 minutes, 4 minutes, 30 seconds. And I'm gonna run some ads. Here we go. I'm gonna grab some more coffee. Burb. Hold on. Sorry, Winter. Cheers to you. Thank you for the hydration. All right, I'll be back. Burb. Alrighty, folks. Hope you had a good break. Hope you're able to let your eyes relax a little bit. Get up, let the legs stretch if you're able. Come on back. Come on back. Let's get back to it. Anybody do anything fun over the break? Anybody do something productive? Alright, open the windows. Nice. Ordered some stuff I don't need on Amazon. Sorted through the toys. Oh, that's right. You're in the garage. A bag of Happy Meal toys I have to sneak out and give away. Hey. They were giving out Pokemon cards the other day. That was wild. Ate some mangoes. Whew. Push to GitHub. Let's go. Push every day, baby. Let's go. Push every day. Taking some break time to push to GitHub. Love it. Doing some laundry, eating and watching a review at the same time. Hey, multitask. Grab more water. Let's go. No. Alrighty. Come on back. Come on back. Alrighty, folks. Let's get into this. I'm going to get a little Leon here. We won Angie. They were checking if I fed them or not yet. Alrighty. Let's come back in. Let's get into this back end. But before we get into the back end, we have to talk a little bit about JavaScript and how it works and the things that it does. Wait, BTS has a meal at McDonald's now? McDonald's just wilding. They had the Travis Scott, now they got BTS. They're just going for it. But it works. It works because the Dunkin' Donuts did the Charlie, which is like the TikToker, Charlie D'Amelio, I think their full name is, right? They came out with they were always like eating, they were always drinking Dunkin' Donuts apparently on their TikToks, and this is just what I needed, Leon, as we talk about like TikTok and Dunkin' Donuts. And so Dunkin' Donuts, this is the longest I've sitting at my desk for nearly 2 months. Hey, let's go, Rossi. I'm so happy you're back. I hope you're feeling better. We missed you. Glad you're here. The TikToker, Charlie D'Amelio, they are always drinking like Dunkin' Donuts like in their TikToks. So Dunkin' Donuts is like, let's partner. And so they came out with the Charlie at Dunkin' Donuts. The day it dropped, their cold brew sales went up by like 40%. And then within the week, their cold brew sales are up 60%. Like across all of Dunkin' Donuts. Imagine doing something and your cold brew sales go up 40 to 60%. What? In one partnership. And then their total app installs doubled. Well, sorry, no, it doubled. It went up 50%. Their total app installs went up over 50%. What? Just from adding a drink called the Charlie and partnering. Like, it's wild out here. Like that's what, like when you can have such a large company have their like percentage of sales go up that much and their app installs just from that one partnership. That's wild. So shout out to Charlie making that money. Good on them. Alrighty. Let's talk about the back end. Before we do that, we got to talk about JavaScript. Hey, folks, like I said, this is chill. We're just getting our review in. We're going to have these tangents where we talk about TikTokers. We talk about Domino's for a bit. It's where we got to be. We're keeping it slow and steady. That's the pace we're going for. All right. JavaScript is single-threaded, all right? Meaning that it can only do one operation at a time, right? So JavaScript can only do one operation at a time. I like to think of an example here. I don't know if it's the best example when it comes to like thinking about asynchronous, but I do like the idea of it being like a blocking thing. So let's imagine you are a paper delivery person. Every morning you get up, right? You get up, you get on your bike, you pedal to the first house, you throw the newspaper at the house, and then you sit there and you wait. You wait for the owner to put on their slippers, right? You wait for them to put on their robe. They get up, they put their coffee on. And eventually they come out the house. They grab the paper, they wave, and then you get on your bike. You pedal really, really fast to the next house. You throw the paper against that door and you wait again. Eventually they come out, they get the paper, and they put it on the next one. If that's how you delivered papers, you'd be the worst paper delivery person that ever existed. Now, it might be the most secure paper delivery person ever, though. Like, nobody's stealing those papers. You're literally sitting and waiting. So there might be some benefits to it. But this would be a synchronous process, meaning that you're only doing one thing at a time. You're waiting for that process to finish before you move on to the next one. JavaScript itself is single-threaded, meaning it can only do one process at a time. Right? It can only do one process at a time. But if it's synchronous, only able to do one process at a time, how do we do stuff that we just saw? How do we like make an API request and keep scrolling? Like, how do we ask for that dog photo and then click on other stuff, move around, do other things? Why are we not like stuck waiting for that dog photo to come back before we do anything else? And the reason why, like, things should block. Like, we shouldn't be able to do these things. We shouldn't be able to like do an API request and then like keep moving around. Things should block. But the reason why things don't block is because of the environment. Leon, what would be your drink once Dunkin' Donuts reaches out to you for partnership? So the problem is I drink cold brew. So Charlie already has like that cornered down. It is definitely going to be called the binary upload boom, or the binary. If they let me do cold, if they have the nitro, it's definitely the nitro. I love the nitro cold brew that Starbucks has. That's delicious. I don't know if Dunkin' has that. But it'd be the nitro cold brew, just black, like me, just black, with a little bit of cream. So yeah, the nitro with a little bit of like has to be like almond milk or something like that. Though we can't do regular milk, right? So just black with a little bit of cream, hopefully like almond or soy milk. Or oat milk. If they came out with oat milk, that's the drink. They got to come out with oat milk. So it's the nitro cold brew with just a splash of oat milk. That's the binary upload boom. Yeah. Yeah. Oh, the nitro cold brew, which is just a splash, just a hint of oat milk. All right. So. Back to code. Our JavaScript should block, right? It shouldn't be able to like do all those things at one time. It should be it should be synchronous. It should be blocking. It should not be able to do all the things that it's able to do. And the reason it's able to do all the things that it does is because the environment in which JavaScript is running. And when I say environment, I don't mean like this. I mean this. This is the environment. Right? JavaScript is running, right? JavaScript is running in the browser. And since JavaScript is running in the browser, it gets a bunch of stuff that the language itself does not have, right? We have to remember that JavaScript itself does not have a lot of the things that we rely on. The only reason that we have access to those things is because JavaScript is running in the browser. Remember, the browser is a full program that's running on your computer. That program has access to your hard drive. That program has access to your RAM, has access to your CPU. Like, the browser is a full program running on your computer, and JavaScript runs inside of that program. right? So the reason why JavaScript is able to do a lot of this stuff that it can do is not because it comes with it, but because it's running in the browser, and that browser gives it access to a lot of this stuff. So our JavaScript is running in a browser. And since it's running in a browser, it has access to a bunch of APIs. Yes, APIs. We're going to call these web APIs. These web APIs are things that the browser gives JavaScript access to that JavaScript would not have on its own. So one of the most common APIs that the browser gives JavaScript access to is the DOM, or the Document Object Model. That means all the stuff that we've been doing early on in JavaScript, like if you're coming straight from the front end crash course to this crash course, let me blow your mind for a second. Okay? Let me blow your mind for a second here. JavaScript does not have access to the DOM. Like if we looked at JavaScript like the language, it doesn't have access to the document, the query selector, the query selector, all of the things that we were using when we were writing client-side JavaScript, like the actual language does not have access to those things. The only reason we have access to those things is because JavaScript is running, right? Is running in the browser. What? This melted me to the core. When I first learned this, my mind just like literally exploded. It was all lies. I didn't trust anyone for a little while. It took me a long time to like rebuild trust. It took me a little while to rebuild trust. Because like what? I've been writing JavaScript for a while. Like I've been writing JavaScript for a while, like more than a year, 2 years, right? Like professionally. And I didn't realize this stuff. And so it took me a while to trust you again, Leon. I'm sorry. You gotta learn it this way though. You gotta learn it this way though. Like it hits different when it's a surprise. All right. So wait, document.querySelector is a web API and not JS. Always has been. All right. So these things that we just thought were JavaScript really aren't JavaScript. They were things that the browser gave us that made it so that when we are using JavaScript in the browser, we got access to those things. So when we run JavaScript in the browser, we get access to the document. We get access to query selector. These are things that are not built into JavaScript, right? All right. These are things that are not built into JavaScript. They are given to us because we are running JavaScript in the browser. If we tried running JavaScript somewhere else, we might not get access to these things. So yeah, JavaScript can do all that blocking stuff in the browser because it's handling all that stuff. All that asynchronous stuff, all that stuff that should take a long time, it's handing that all off to web APIs. It's handing all that stuff off to the browser. The browser says, here's a nice, simple API to use. You make a request to this API, and we'll handle all of that blocking async stuff for you, right? So you can go about your day. You can keep clicking on stuff. You can keep doing all your stuff, right? But it hands all that stuff off to the browser. Cool. All right. So if we're handing off all of that complicated stuff to the browser, eventually the browser is going to respond. Eventually the browser is going to say, hey, remember that request you made? It's done. I finished it. Here's the response. And so this is the first big problem we have in that, how do we handle that response? We handed this thing off to the browser. The browser did its magic and it wants to send back the response. How do we handle that response? How do we know what to do when we get that response? We sent a request off to the browser. The browser came back. It wants to do its thing. How do we handle that response? Well, the first way we did it, the old school way, was callbacks, right? Callbacks enabled us to get that response and do something with it. All we get out of JS is a bunch of promises. That's hilarious. Somebody needs to tweet that. All right. The old school way was callbacks. And so let's talk about what callbacks are and how they work, and it'll make a little bit more sense. So in JavaScript, something really cool about JavaScript is that you can have a function that takes in another function as an argument. So we can have a function that takes in a function. We call this a higher order function, and not every language enables you to do this, and not every language enables you to do this like easily. In JavaScript, it just works. All right. And so we can have a function that takes in a function. That's a higher order function. You've seen this a bazillion times. Whenever you've done a click event, you've had a function that's taken in another function. So here's our event listener. It's taking in, it's a click. And once it hears the click, it runs this function. So this is a function that takes in another function. This is an example of a higher order function. Something pretty cool that JavaScript can do. Now, a callback is the function that has been passed in as an argument. So when that function, that higher order function runs, right? Once that function runs, it's going to run this, it's going to run the callback, right? So this callback is the function that's going to run. So you have a higher order function, a function that can take in a function. The argument, like the function that's taken in, we call that the callback. And the beautiful thing about a callback is that it can run once the other function is done. Right? Now, it's important to note that callbacks are not really a thing. They're just a convention in JavaScript. There's like nothing in the JavaScript specification, right, that that like is a callback. It's just something that we like agree to call it. It's a convention. Cool. The cool thing about a callback is that it fires, right, when your asynchronous task or the other function is done. So once the click event is heard and it's done, then it fires that callback, right? So the beautiful thing here is that you can have a callback that runs when the other function is done. So when that other function is done, the callback fires, and this enables us to say, all right, when that asynchronous stuff from the browser is done, then run this function. So this is how we can handle handing stuff off to the web APIs in the browser. And when the browser's done, we know what to do. We say, all right, when the browser's done doing its thing, right? When the browser's done doing its thing, run this function, run this code. So here's a bunch of callbacks. Something really interesting to remember, right, is that set timeout is not actually part of JavaScript. Set timeout, exactly, is an API given to us by the browser. In this case, we're running our code in the browser. It's a web API. It's not JavaScript. If you read the JavaScript specification, there's nothing in it called set timeout. There's nothing in it called set interval. These things that you've been using for a long time is not actually JavaScript. The browser, where we are running our JavaScript right now, like the environment in which we are running our JavaScript, the environment where we are running our JavaScript right now is the browser. And the browser gives us access to all of these web APIs. Set timeout is one of those web APIs. And so here we have a set timeout that'll run after 3 seconds, 4 seconds, and 5 seconds. We're going to hand off each of those requests to the browser. And when the browser is done, it'll run the callback. Thank you, Dom. Appreciate you. Thank you so much. Got new coffee. Let's go. More coffee. All right. Hadoken. Thank you for the 7 months. Let's go. Happy to be here leveling up my game. Let's go. Thank you, Doken. Thank you for being here. General Knox with the 6 months. Let's go. Thank you for being here. 6 months of Bezos' bucks. I appreciate you. Thank you so much. That's my teammate. Let's go. Thank you, everybody. I appreciate the support today. Alrighty. So here we have a bunch of nested callbacks. So we have this one nested inside of this one, inside of this one. And so this is kind of how callbacks were used for a long time, right? The idea here is that we have these higher order functions that take in functions. The callback is the function that's passed in. Once this one is done, do the next one, do the next one. And we wind up with the pyramid of doom, or what most developers affectionately call the callback hell, right? Where it works, the callback will run once the asynchronous function is done, right? When the outside function is done, it'll run the callback. It works, but it's hella hard to read, right? And you get lost in the sauce as you get more and more complex. That pyramid gets bigger and bigger. And so we needed a way to escape callback hell. And when we got the newer versions of the JavaScript syntax, the ES6 Plus, so in 2015 forward, one of the big things that we got was a promise for a new future, right? And they gave us a more readable way to handle our asynchronous code. So instead of having that callback hell, instead of having that pyramid of doom, we were made a promise. Okay? And this promise is a new way of handling, right, those responses that we get back, right, from our web APIs, right? Cool. All a promise is an object. It's all a promise is. All a promise is an object that may have a value in the future. And the really cool thing about this object is that it has a then method. And the then method runs automatically after the promise resolves. So meaning once we get the response back, that's when the promise resolves. Once it resolves, the then method automatically runs. So it just fires instantly. And whatever data we got back, whatever value we got back as that response resolved, that value gets passed into the then method, right? So what we wind up with is an object. And once we got a response back, that object has a value. And once it resolves, that method fires, and that method will have the value inside of it. Now that sounds like a lot of magic, but you've seen this all before. In fact, you've seen this just a few minutes ago, right? Here is our fetch. Our fetch is just a promise. We make a request, all right? We make a request. That request goes to the server, and it returns a promise. Once the promise resolves, these then start firing. So this then will make sure that we're dealing with JSON and not whatever else came back. Then this then will fire, passing that value in through data. Wherever I see data, it's the value that came back with that resolving of the promise. And then I can console log that data. The beautiful thing is that our promises have status. pending, right, resolved, and rejected. If our promise gets rejected or something goes wrong, we have this lovely catch, which is a method that'll fire. So these promises make our lives a lot easier, right? Because if the promise resolves, we can go ahead and have this then fire and get the value. If something goes wrong, this catch fires and we can get that value as well. So promises really did make dealing with these asynchronous requests or dealing with these things that are being passed off to our web API, being passed off to the browser, waiting for that value to come back. We don't need a callback that's just sitting there. We don't have to nest all of our callbacks in the callback hell. We can use something like fetch, which is also web API, to get a promise. And when that promise resolves, right? When that promise resolves, we know that the thens will start firing. So no need for callbacks. We know the then will fire once the promise resolves. Can you explain what data is in that code again? Data is a made up parameter, meaning the value that comes back with that promise is going to be passed into data. So wherever I see data, it's the value that came, right? It's the value that came back. I could have called that zebra. I could have called it unicorn. It could have been called whatever I want. But we know that this dog CEO API returned a value. That value is now stored in data, but I could have called that whatever I wanted. Fetch is the promise? No. Fetch, the response to the fetch is a promise. So you make your fetch, and what you get back is a promise, which is just an object. Whoop. The coaster was sticking to the mug. So we know that fetch is making a request to the server. And what we get back from that request is the promise. All the promise is an object, right? It's just an object. And it has some properties, like if it's pending, or if it's resolved, or if it's rejected, right? And so we have a whole class on this that really breaks down the different states and how it can be pending and how it can be rejected. So if you're really curious about like how this is working underneath the hood, we have a whole class on that you can go back and watch. But the only thing you really have to understand is that we had callbacks, which were really bad because we wound up in callback hell. This syntax just made it a lot easier. We know that these thens fire once this request is done. So take all of the weird syntax and terms off the table. You're making a request, and once that request is done, right? Once that request is done, then these then start firing. So basically, we do some stuff after we get a response. That's all. Oh, I like that example a lot, actually. So Pi said, I'm thinking of fetch like a dog getting the tennis ball, the promise, and that's making sense to me. Yeah, you can think about it like that. So we make a request, right? We make a request using fetch. So we say to the dog, go fetch. The dog runs, and the dog comes back with your object. Comes back with the tennis ball. That's your promise, right? I like that. It's a cool idea. Think about it. Leon, would we ever use this syntax over the async await syntax? That's up to you. Like I said, I have the blessing and the curse of having to show you everything. Meaning that my job is to show you not only the way things are currently done, but the way we used to do things in the past. And the reason why I have to do that is because I need you to be prepared for the different types of companies that you'll join. Some companies are using really old code. You might join a company that doesn't use promises. That would suck, right? But they would expect you to know what a callback is, right? You might be joining a company that that wrote their code base in 2017 or 2016 and only has promises everywhere because we didn't have the await syntax. I think await was 2018. So yeah, maybe they built their code base 3 years ago and it's all promises. You got to know how that works. And maybe they built their code base a year ago and it's all async await. And so you have to kind of understand that it's not really, a lot of companies aren't going to redo everything in a new syntax. Specifically, it's not like async await's not a change. It's just syntactical sugar, right? And so we're going to talk about that in a second. So you might not be at a place where they have any of these things. And so we got to learn just enough of everything so that when you see it, you're not Pikachu face, right? You're not Pikachu face when you see a callback. You're not Pikachu face when you see a promise, right? Like you at least have a recollection of how you're going to use it, and then you spend time getting more up to speed on it. Your first 3 months in the job are kind of learning all the ins and outs of how your company operates, how their code was built, the things that they do and things that they don't do. And so every company is different. There's nothing I can do to prepare you for your specific company, right? But I can at least give you the building blocks of a lot of stuff. Cool. Now, fetch returns a promise. That promise is just an object. That object can have a value. Our then trigger once the promise comes back. So here's an example of some code that would have a lot of promises in it. I can't remember the last time I actually wrote code that said return a promise. Normally I'm consuming them. I'm not creating them. So that's kind of rare for me. But I built these 3 functions that have promises inside of them. So once you call them, the promise should resolve. And so the idea here is that I have house1, which I'm going to call. And then once that promise resolves, it console logs paper delivered to house 1. Then the next then fires, it calls house 2. That promise would resolve. We'll see that printed to the console. Then it would call house 3. That would resolve. And so it turned our kind of like asynchronous task, like these promises coming back, into something that looks a little bit more synchronous. It works without callbacks, right? But the problem is this chaining don't read too good. Like it works. It's our what could be our asynchronous code is reading a little bit more synchronous, right? But chaining don't read too good. Rashid, what is easier to learn for a beginner, Java or Python? Python all day long. Now, easier and what Blah is saying, what is your goal, is a really different question. Because you might have different goals, and those different goals might dictate whether you learn Java or Python. Remember, your language are just tools on your tool belt. Certain languages are good at some things, they're not good at other things. And so you got to really understand like what you're trying to get out of it. How would you practice this knowledge promises? You use them everywhere. Whenever you make an API request using fetch, you are using promises. That's how you practice. When you start building out your CRUD API, all you're doing is consuming promises. Web scraping with JavaScript or Python? Python. You might have to write some JavaScript to help you, but I do all my scripting in Python. When you say it doesn't read good, do you mean for the user? No, I mean for us as the developer. This is hard to read. Like I can't really see what's happening quickly, and it doesn't really read like other JavaScript. Like our other JavaScript doesn't look like this, right? We don't have these like then methods for all the functions we want to call and run. And so it works. It's handling our promises, but it don't read too good. And so to help with the readability, and basically what was a lot of developers saying, hey, I want my asynchronous code to look synchronous. To handle that complaint, saying I want my asynchronous code to look like synchronous code, we got async await, which is just syntactical sugar. Right? It's just syntactical sugar. And what it does is it's a way to handle, right? Just a way to handle our asynchronous responses. And it's really just promises under the hood. So async await is just promises under the hood. There's nothing different. It's just promises underneath the hood. It's just a different type of syntax. We call it syntactical sugar. There's nothing that's changed. It just looks a little different. And the beauty of it is it changes that chaining syntax into something that looks a little bit better. So let's step back here for a second. We had this code here, works. We're able to do all of our asynchronous stuff. So remember, whenever we were making a fetch or using a web API, we had these things that were being handed off to the browser, and we were just waiting. We were twiddling our thumbs, waiting for that response to come back. And when that response came back, we handled it. So we printed it to the console, and then we ran the next function. Then we were twiddling our thumbs, waiting for that promise to resolve. And when it was done, we did these two things. Then we were sitting there twiddling our thumbs, right? Twiddling our thumbs, right? And then this resolved. Then we ran that. So this works. We're able to wait for those responses to come back, for those promises to resolve. But we want our code to look like the rest of our JavaScript, right? We want our asynchronous stuff to look synchronous. And that's where async await comes in. Async await is just a way to handle our asynchronous responses, just a way to handle our promises. And it's just promises underneath the hood. It's just a little bit different of a syntax. We call that syntactical sugar. We have two really big keywords, await and async. Await waits for an asynchronous process to complete inside of an async function. Hang with me for a second. Let's take a look at it. So here we have all these asynchronous promises inside of our code. And once we have a function that has the async keyword, these asynchronous processes will wait until we go on to the next one. And so the beautiful thing is we get this like lovely synchronous looking code, right? This lovely synchronous looking code. Like, look, this looks like our normal JavaScript, but this await is doing an asynchronous task. Like it might be doing a fetch. It might be handing something off to the browser, waiting for it to come back. And once it comes back, it stores that value in house one wait. Right? And it just looks good. It looks like our JavaScript that we've been used to writing. So when we're waiting for these responses to come back, whether it's a fetch, whether it's a response from our server, right? Whether it is something that we're twiddling our thumbs waiting for, eventually that process resolves, that promise resolves, and await is just literally waiting for that process to resolve. And the cool thing is it turns what was our callback hell or our promise chaining into something that looks like our normal JavaScript. And that's the beauty of the async await syntax. It just looks good. We have some questions in here. Do you recommend people grinding LeetCode? I recommend learning the basics, building a project that takes you 100 hours. I recommend that you network your ass off and that you do grind out your code wars and LeetCodes if you want a job. In that order, though. Cool. Alrighty, folks. So this is a lot. And the reason why we have to go over it, all right, the reason why we have to go over it is because we're going to see both this promise syntax and we're going to see this kind of async await syntax in our backend code. But what we have to realize is that a lot of the stuff that we're doing in JavaScript really isn't JavaScript itself. It's stuff that we have access to because we're running in the browser. Right? So what async await allows is more organized, cleaner code, but enabling the handling of multiple tasks. Yeah, pretty much. Async await is just like a cleaner syntax for handling our promises. And what I mean by that is that we have to do a lot of stuff asynchronously, meaning that we're going to make a request to an API, or we're going to have a set timeout or a set interval. All that stuff is happening asynchronously, and JavaScript's really bad at that. JavaScript's synchronous. It doesn't have a way of handling that stuff. All that stuff gets handed off to the browser, and eventually the browser says, hey, whoa, woo, hey, that thing you asked me to do, I'm done doing it. Here you go. Now, since I've handed off the response to you, what do you do with it? And that actually introduced a pretty big problem. JavaScript didn't have a really good way of like getting that response and doing something with it. We had to use callbacks to do it. And that introduced callback hell. Then we got promises, and promises work, but they didn't read too good. They didn't look good. They didn't look like the other JavaScript we were writing. And so then we got a little bit of syntactical sugar, right? A little bit of syntactical sugar. And that syntactical sugar just makes this asynchronous stuff. Like we're telling this to go to the browser. The browser eventually responds with it. And when the browser responds, it puts that response inside of house one wait. Then the browser does this task and puts the response here. Then the browser does this task and puts the response here. So we're still doing that asynchronous stuff. We're still handling it off to the browser. Yet it just reads way better. It looks like our other JavaScript. Is it best to use this syntax? It depends. Depends on the company you're at, how you're doing it. Async and wait seems the most readable to me. I hate the idea of like best practices though. I think early on developers get really hung up on what best practices are. You should do the things that make sense for the thing that you're working on. Yeah. I like me some syntactical sugar in my morning coffee. Is syntactical sugar your DJ name? No, we actually revealed my DJ name. I think it was it Tuesday's class? Alrighty. Where are we at? Cool, we got some good time. I didn't see your... What was the question Dro was asking? I'm trying to make sure I didn't miss any questions here. Is old school fetch and then catch still cool? Yeah, you're going to see it a lot. I think the async syntax just makes it look a lot cleaner. Cool. So this is all wild. You're like, Leon, that's way too much. Like, I'm trying to keep all this in my brain. I need to see something real. And so let's see a real example, right? Let's see a real example here of something where we'd actually use this syntax, okay? So let's look at it. So earlier, we saw the request for the cute dog photo, right? And that cute dog photo, right? That cute dog photo was using the original promise syntax. Let's look at it. I should have put it on the slide before, but I forgot to. All right, here we go. We made a request, right? Hopefully we get a response back. That promise comes back. Then we have this then that chain, right? It's chaining these responses. And so this works. This is how we did our fetches for a really long time, but it doesn't look like our other JavaScript. And so with async await, we have a function. Look at it. Look at this. It's just so beautiful. It's just so beautiful. It's just so beautiful. Sheesh, as the kids are saying these days. It's just clean. Look at it. All right. So we're inside of an async function. We have this lovely async keyword before the function. Then we're going to say await the fetch. So go ahead, make the request. We'll wait. It is funny. It gets the fetch, right? It gets the fetch. And when it comes back, it gets stored. The value gets stored, right? Gets stored in res. Then I can make sure that it's JSON. So like I'm dealing with like JSON. And then I can just console log it. So gone are those weird then chains. Gone is this code that doesn't look like JavaScript and enters in a new age, right? It just looks so clean. It looks so cool. It looks like JavaScript. No weird chaining. I can read this. I don't have to I'm not connecting dots. I'm not trying to figure out. All it's doing, right? All it's doing is waiting for this promise to resolve, putting the value inside of res. If we want to make sure that we're dealing with JSON data, we can do the same line like we used to do with our other fetches, and we can console log that data if we want. How do we catch errors with await? So with the async await syntax, we got what are called try, catch, blocks. Try, catch, blocks. You put your code that you want to run in the try, and then you can put the rest in a catch. Let's see. Do I have some codes? Let me pull up some code here. One second. So here we go. This is one of our real examples that we'll see later today. All right. So here we're inside of an async function, and we're going to make a fetch. And notice how this is inside of a try. So all this stuff is inside of a try. Don't worry. I know this is a lot of complicated stuff in here. Don't worry about that yet. But all of this is inside of a try. So all of this stuff is going to try. Right? All this stuff is going to try. And all this stuff is going to try and happen. If something happens or we get an error, we have this catch down here. Right? We have this catch down here. And what will happen is if we get something like a rejected state of the promise, right? If there's an error or it gets rejected, this catch block will run and we'll console log the error. So we can do this try catch as part of the async await syntax. So this right here would be wrapped in a try block. And then I would have a catch after it to catch if something went wrong or it got rejected. Yeah. And like I said, this is supposed to be a review. So if you have a lot of questions about this stuff, we have a full class on it. You can go back and get all the details should you need them. Alrighty. Can you explain async await one more time? Yeah, sure. Async await is just syntactical sugar that enables you to handle promises. Promises are just objects that you're getting back from a request. So a lot of times we're making requests, whether it's to another API, to a web API that's built into the browser. And since JavaScript is a synchronous language, since JavaScript is blocking, meaning that it can only do one thing at a time, we need to hand off all of this asynchronous stuff to something else. JavaScript literally cannot handle all this asynchronous stuff that we do. Talking to APIs, doing set timeouts, doing set intervals, talking to the DOM. JavaScript cannot do it. JavaScript is synchronous. It does not have the ability to sit around and wait. So we hand all that stuff off to the browser because that's where we're running our JavaScript, right? We hand all that stuff off to the browser. The browser does its thing. But eventually, the browser needs to tell JavaScript, hey, I'm done. Here's the response. And JavaScript needs a way of handling that response. First, we did it with callbacks. Then we did it with promises. And now we have a little bit different of a syntax called async await, which enables us to get that response back and use it. Whether it is to just console log the data we got back, whether it's to do something else with it, it just enables us to take that response we got back from the API, whether it's a web API or our dog CEO API, right? Whether it's something that's coming back from the browser, it enables us to get that response and do something with it. And async await is just a pretty syntax to handling those responses, and we call those responses promises. So that's all it is, just pretty syntax to deal with promises. And this is important. And why it's so important is because JavaScript cannot do this. JavaScript cannot do stuff asynchronously. It has to hand off those asynchronous stuff to something else. In this case, chat. Where is JavaScript handing off all this asynchronous stuff to? Right now, where's JavaScript handing off all that asynchronous stuff we've been talking about? What's doing all the heavy lifting here? JavaScript's not doing it. We've been handing it off to something else. Yep. We've been handing it off to the browser, which the browser gives us access to a bunch of web APIs, like a bunch of code that we can run that the browser just handles. So we hand all that stuff off to a browser API. We hand all that stuff off to a browser. The browser, since it's a program running on our computer, it has access to our CPU. It has access to RAM. It has access to all of this stuff that JavaScript by itself does not have access to. The browser does its job. It does what it needs to do, and it returns a response. Now we know that response is going to come back as a promise, and we need a way of handling that response, handling that promise, right? At first, we did it with callbacks, then we did it with promises, and now we do it with async await. It's just a syntax for us handling that response, handling that promise, and knowing what to do with it. Whew. And the reason why we're going to need this, Fox, thank you for the hydration. Cheers to you. Hope you're doing well. The reason why we need to know about all of this stuff is because the browser is not the only environment. It's not the only place that we're going to run our JavaScript. We're going to run our JavaScript in another place, right? We're going to run our JavaScript in another place, and we're going to need to know how promises work and async await work, right? We're going to need to know how that works in that other place that we're going to run our JavaScript. Chat, where's that other place we're going to run our JavaScript? Where's that other place we're going to run our JavaScript? Yeah. We're going to run it via Node and the Node runtime. So right now we're running all of our JavaScript in the browser, but eventually, right? Eventually, we're going to run that code somewhere else. We're going to run it in Node. Cool. All right. We're going to run it in our smart fridge. Maybe. All right, let's get through this last piece and then we'll take our next break. All right, so let's use a web API. Set timeout is a web API. Set timeout is not built into JavaScript. Christos style, hey. Christos, what's up, Christos? How you doing? All right. It is not built into JavaScript. This blew my mind. Blew my mind. Set timeout is not something that comes with JavaScript. We only have set timeout right? We only have set timeout because we're running JavaScript in the browser right now. So let's use a web API. Yep. Set timeout, set interval are not part of the JavaScript specification. They do not come with JavaScript. We have set timeout and set interval because the environments where we run our JavaScript give us access to them. So pretty much every browser gives us access to set timeout, and Node.js definitely gives us access to set timeout. And so this brings up a really important concept. We had something called the browser wars. Back when all the browsers didn't really play nice with each other, right? And what that meant is that you could write your JavaScript and maybe you wanted to use set timeout. But is set timeout part of JavaScript? So if I wrote my JavaScript that included set timeout, but let's say Internet Explorer did not give access to it, but Firefox did, then the JavaScript that I wrote would only work in Firefox, but would literally break in Internet Explorer. And so that's what caused a lot of pain early in, like when these new browsers started coming into the game, right? IE had a lot of weird things, a lot of security issues, a lot of stuff that was just stagnating. The web almost didn't become the web. And then Firefox rode in on the white horse that it was on and saved the day. But they're two different environments. Even though they're both web browsers, Internet Explorer had its own environment, Firefox had its own environment. And they got to choose what things it gave access to. And so there might have been a time when set timeout was only in Firefox, but not in IE. And that could cause a lot of pain. And so to fix that pain, to polyfill all the gaps where things wouldn't work across browsers, anybody know what we had for a long time that we relied on to write our JavaScript? We've talked about this in the past. What did we have? Yeah, Deb. We had jQuery. What jQuery was saying, hey, the JavaScript we're writing is not cross-browser compatible. It's not working in every single browser. So how about you just write jQuery and we'll handle behind the scenes making sure that it works in every single browser. And so for a long time, we had to use jQuery. Unless you wanted to code all those exceptions by hand, you use jQuery, right? But now all the browsers have caught up. All of the common web APIs that you're going to use, like the DOM or set interval, set timeout, all of the browsers have agreed to use. And so we don't really need jQuery anymore because we don't need that cross-browser compatibility. But for a long time, we did. It was a big worry. Cool. Excuse me. So set timeout, set interval, not part of JavaScript. They only come because the environment where we're running our JavaScript gives us access to them. So our browser gave us access, right? Our browser gave us access to set timeout, set interval, the DOM. That's all we have access to it. All right, here's something weird. Let's go ahead and run this real quick. Let me just run this in the console here. All right, there we go. So we got paper, right? Paper delivered to house 1. Then we got paper delivered to house 3. And then we got paper delivered to house 2. Right? So let's look at the code here. We called house 1, then we called house 2, and we called house 3. So house 1, normal console log. House 2 has a set timeout that takes 3 seconds. So this makes sense. This made sense, right? We would run house 1. That would run just like normal. We'd run house 2. We know it's going to take 3 seconds. And JavaScript doesn't make sense. So that it just goes on to the next one. We run this and we see house 3. So in our console log, we saw house 1, house 3, and then house 2. That makes sense because we know that house 2 was waiting those 3 seconds. So we saw 1, 3, and then once those 3 seconds were up, we saw house 2. All right, there's a waiting. We told it, we have this set timeout. We're going to wait the 3 seconds. So going 1, 3, 2 makes sense because we're telling it to wait. Now here's where the problem starts to get a little real. Here's where the problem starts to get a little real here. Let's look at this next one. All right. Now we have just a normal console log for house 1. We have a set timeout. All right. We have a set timeout, but there's no wait. We're saying don't wait at all. 0 seconds wait. And then normal house 3. So what we would expect is that we would see 1, 2, 3 in the console. So let's go ahead and grab this. Let's go back to our console here. We clear this up. Yet we still see 1, 3, 2. Same output. We got. We got. Right? Even though there was no wait, we still saw 1, 3, 2. So we got. And we're going to take a break. And when we come back from break, we're going to remember, we're going to think about how we don't get got. We're going to go get. Okay? So let's go ahead and put a 5-minute timer up here on the clock. We got for some reason, even when there's no wait, it was still doing 1, 3, 2. So let's figure out how that worked. But for now, let's give our brains a rest. Put a lot of hard work getting through the async await stuff. So let's figure out how we got when we come back. Please take a 5-minute break. Please get up, hydrate if you're able. Do the things you want to do. Wolfpack, just make sure that you have JSON. All is it doing? Think of it as like converting it to JSON for you, or making sure that it is JSON for you. That's all it's doing. All right, folks, I'm gonna run some ads so that you take a break and so that new folks don't have to see ads when they join us. Did you see that there's a Cheer Smack marathon yesterday? I did not, but I definitely would have watched it. All right, see y'all in 3. I am also myself going to get up and stretch a little bit and see how the dogs are doing. Burb. Ooh, please, please, please take a break. Take a break. Haven't yet. Hydrate. Get some coffee in real quick. Can we do a YOLO today? Sure. Running dry on channel points. I got you. We'll do a YOLO when we get back. Whew. "30 seconds, folks. Please do what you gotta do." We're 3 hours in. We haven't gotten a node yet, so buckle in, folks. We got a long ride. You gotta be healthy. You gotta be taking these breaks. Love your background with the cats. Hey, thank you. I appreciate that. I'm a fan. Pixel cat. Alrighty, folks. Come on back. Hope you had a good break. When your break ends where our gots continue to get gotten. Well, we got, but we gonna go get. Are you going to be putting these streams up on YouTube? Yep, everything goes up on YouTube. If you're interested in joining our free software engineering bootcamp, you can do !100 devs in chat. They'll give you everything you need to know. We got a Discord community of about 3,000 folks that want to help you be successful in learning to code. Absolutely 100% for free. None of our content will ever go behind a paywall. None of my content will ever be paid. It will always be free forever. Are there going to be any code alongs? Yep, we're going to get to it. All right, folks, come on back. Come on back. Let's get back to getting got. Show the break music here. Alrighty. Wanders back in. Yep, Drew, everything gets up to, everything goes up on the VOD immediately, and then eventually gets back to YouTube. Alrighty. Today is a backend crash course. So we've been doing a free software engineering bootcamp. We are on class 42 out of 60. And so this is just a review for folks that have been doing the bootcamp and have been following along with the backend just to get some space repetition in, some active recall in, ask a lot of questions. And we're trying to get that review in before we move on to React. So we've been building projects, doing a lot of stuff. And so we're going to just get a lot of review in today. So we're 3 hours into our review, and let's do a YOLO. Who wants to do a YOLO? Let's do a YOLO. Let's do a YOLO for right now. Let me pull it up. I gotta set the prediction. Let me set the code first. Let me go over here. All right, so we'll do a math.random. And let's do it inside of a math.ceil. And we're going to do this times 2. Cool. There we go. That's the code. Check the code to make sure it's correct. Because if it's not correct, that can impact your decision. Close to 100K, what to do. All right, let's go for it. I'm going to set the prediction. Start a prediction. 1 and 2. Got it. All right. 1 and 2 are the options here. I'm so close to 100K before the soundboard became an option. All right, I'm going to keep it open for a minute. Get your predictions in here. YOLO all your channel points in chat. You should see it. Whew. A lot of channel points going up here, folks. Oh, 150K on both sides. I really think you should YOLO it all. This one, I feel like you're gonna be lucky on this one. I feel like this one is lucky. I feel like this one's really lucky. I think you should definitely YOLO it all in this one. If you're gonna ever YOLO it on anyone, this is the one. Don't miss out. I'm telling you right now, this is the one to YOLO it all. Don't be missing out. You know, I'm gonna run it, and you'll be like, damn, I should have listened to Leon. A gentle 2K. All right, let's run it. Alrighty. 3, 2, 1. 1. The winners are 1. 1 has won. 1 has won. Let me go ahead and confirm that prediction. 1 has won. And let's go ahead and complete the prediction. There you go. Who won the most channel points? Who won the most and lost the most? Who thinks they won the most and who thinks they lost the most? Bruh. Flush with channel points for the sounds. I lost 25K. Oh no. 13K, 22K, 35K lost. That's hilarious. High rollers in here. Lost 70K. Oh, you can actually see the predictions next to their name in chat. That's wild. So you can actually see what people did. That's cool. Ooh. Ooh, that's rough. We'll do another one before we end today. We'll do another one. Remind me at the end to do another YOLO. We'll do another one. It'll be fun. We'll do something maybe a little different though. Can I? What does it say? See details. Sorry. Alrighty, folks. Let's keep going here. It's all rigged. Alrighty. I'm not pushing my luck. If I'm a bit okay with basic JS, still shaky with promises, but haven't started working with APIs yet, would it be best to watch the full class VODs or keep up with the crash course today? Keep up with the crash course today. Ask a lot of questions, Frugal, and then go back and watch things that you need to watch to fill in the gaps. So definitely ask a lot of questions. Things don't make sense. Let's go over it. And then, yeah, you can fill in the gaps on anything you need to fill in the gaps with. So like I said, if you're new around these parts, we have 40 plus classes that you can go back to and watch on any of the topics that don't make a lot of sense. So if the async await stuff was shaky, you can go back and watch that. This is kind of, like I said, like review for folks that have been with us for a while. But yeah, go back and check them out if you need to. Alrighty, folks. So before we can understand how we got, we got to understand two really important data structures. So remember, we saw that when we had a delay, it went 1, 3, 2. But even when there was no delay, we still had 1, 3, 2. Right? So with a delay of 3 seconds, we knew that there was 1, 3, 2. But even when that delay was 0, we still got 1, 3, 2. So that was weird. right? No delay, but we still got. So understand how we got. Let's look at some data structures. Remember, data structures are just a way of structuring your data into ways that make sense. And so one of the data structures we're going to know about today is called a queue. A queue is referred to as a first in, first out structure, meaning that the first thing into the queue is the first thing out of the queue. You can think about a line, right? You get in line. The first person in line is the first person out of the line. So you're trying to get a GPU. So you go to Micro Center, you get in line. If you're the first in line, you'll be the first person to get the GPU. You go to the movie theaters. New movie's about to come out. You get into the line first. You're the first person into the movie theater. So a queue is a first in, first out structure. In JavaScript, it's pretty easy to build a queue. We can use an array, and we can push values into our array. So we're going to push the value 2 into an array, push the value 5 into an array, and now our queue has 2 and 5 in it. We would then shift, pulling off the 2 first. So the first thing into the array, which was 2, was the first thing out of the array. So first in, first out. Okay. We also have a stack. A stack is another data structure, but it's a little bit different. It is a last in, first out, meaning that the last item in the stack is the first out. I like to think about pancakes. You're making delicious pancakes. The first pancake goes on the stack, and then every other pancake keeps going on the stack. Eventually, you have a stack of pancakes. The pancake that's on the top, the last one onto the stack, is the first one out. Unless you're a monster and you like rip the first pancake from the bottom, nobody does that. At least nobody here in this community does that. All right, because that would be atrocious. But you can think of pancakes as your stacks. Your last in is the first out. So the last pancake on the stack is the first one off to be eaten. Okay. So once we understand queues and stacks, we can understand a little bit more about what's actually happening with all of these promises and fun stuff that's going on. So let's get back to getting got. So remember, our JavaScript is running in a browser. Right? Our JavaScript is running in a browser. Excuse me. That browser gives us access to web APIs, right? So that we can do things asynchronously. Without JavaScript running in a browser, we couldn't do any of the asynchronous stuff that we do. We wouldn't be able to make fetches. We wouldn't be able to do set timeout or set interval. We only have access to those things because JavaScript is running in the browser. Okay. Now, there's a lot of stuff that the browser or that environment gives us. One of the first things we have access to when we're running our JavaScript in a browser like Chrome is we get access to something called the V8 engine. The V8 engine is what's going to break down our JavaScript into something that the computer can understand. All right, we'll get to that in a little bit. We also have access to all these web APIs, and we also have something called libEvent. libEvent gives us access to something called an event loop. Without libEvent, we wouldn't have the event loop when it comes to JavaScript. And this event loop is a way for our synchronous JavaScript to be able to handle passing off all the asynchronous stuff to the browser and handling the responses that come back. Okay? So we are going to make, say, like a fetch request. How does the browser know? How does JavaScript know how to deal with the response from that fetch? We're going to maybe try and get something from the DOM. How do we know how to deal with when we get it? Maybe we're going to do a set timeout. How do we do a set timeout, have that run asynchronously, and then how do we do something once that set timeout is done? We're able to do all of this because we are running JavaScript in the browser, which gives us access to those web APIs, but also gives us access to libEvent to handle the event loop. The event loop monitors the callback queue and the job queue and decides what needs to be pushed to the call stack. Oh, I forgot to put like the squinty face, the woman that goes like that. All right, so these are a lot of big words. Since I'm going to treat them as disrespect, watch your mouth and help me with this sale. Okay? We're easily distracted by pancakes. All right, let's read this one more time. The event loop monitors the callback queue and job queue and decides what needs to be pushed to the call stack. So JavaScript has this idea of something called an event loop when we're running in the browser, and also when we're running it via Node 2. Here's how the event loop works. Let me show you the event loop, and then we can talk about those big words. So here's our code. We have a console log. We have a console log, a set timeout that has zero seconds of delay. And then our last console log, which is just house 3. We saw that what's going to be printed to the console is house 1, house 3, and then house 2. But why? Why is it not 1, 2, 3 when there's no delay? It's 0. There's no delay. So let's go ahead and take a look at why there's no delay, yet we still see 1, 3, 2. So the call stack is where all of our synchronous tasks go. So each line of code that runs is going to put something onto the call stack. So this first console log runs, and we put that console log onto the call stack. The event loop runs and sees that this console log is on the call stack, and it executes that line of code. So we see the console log in the console. Right. Then the next line of code runs, the set timeout. Since the set timeout is a bit of code that's going to run, it gets added to our call stack. However, set timeout is a what? Set timeout is a what? This is a LIFO. This is a last in, first out. The call stack is a stack. So the last thing in is the first thing out. Set timeout is a web API. Exactly. So JavaScript can't handle set timeout. So what happens is the browser hands that set timeout. Sorry, the browser takes set timeout. So JavaScript hands set timeout to the browser, and the web API starts doing its thing. So now the web API is handling that set timeout, and we're able to go on to the next line of code. Right? We're able to go on to that next line of code. So that next line of code gets added to the call stack, right? But since there was no delay, by today, no delay, that set timeout that got sent to the browser that was being handled by that web API, it instantly completed. But things that are handed off, let me go bigger. Things that are handed off to the browser, things that are handed off to those web APIs, those do not immediately go back to the call stack. When those things resolve, because they're asynchronous, they get pushed into a queue. So this means that we could have a bazillion things being handled off to our web APIs. We could have a bazillion things that the browser's doing. We could be requesting dog CEO photos. We could be requesting cocktails. We could be doing set timeout. We could be doing intervals. All of those things are getting handed off to the browser, and they're all going to complete, right? They're all going to complete at different times. And as they complete, they get pushed into this queue, right? They get pushed into this queue. Now, the event loop runs. It sees that, yes, there is something on the call stack. So it's going to take what's on the call stack and execute that first. The event loop will always run stuff in the call stack before it worries about anything else. So this console log gets console locked. And now, finally, the call stack is empty. So the event loop runs again. It sees that the call stack is empty. And when the call stack is empty, it takes the first thing in the queue and puts it on the stack. Exactly, Joe. It has to clear the call stack before it ever goes to the event queue. Cool. So since the call stack was empty, we grabbed the first thing that was in the queue and put it on the stack. Now that response, that callback, that promise that came back from the web API is on the stack, right? Now that it's on the stack, it can run, and that's when we're going to see the last console log get printed to the console. All right. And the reason all this works this way, even though there was no delay on the set timeout, since it's a set timeout, since it's a web API, it has to go to the browser. And when the browser's done, it doesn't go onto the stack. When the browser's done, it gets pushed into the queue. So we could have a bunch of these responses just sitting in the queue. And once the call stack is done, it's empty, then it starts pulling stuff out of the queue. So that's how we're able to do asynchronous stuff in the browser, even though JavaScript is synchronous. Even though JavaScript would block on all these things, it's not JavaScript that's handling it. It's handling all that stuff off to the browser. The browser completes it and adds it to a queue. And this event loop is constantly checking, all right, is the call stack empty? Because if it is, let's go grab the first thing out of the queue. Rezo, exactly. Because the call stack always executes before anything in the queue. What happens if the call stack isn't empty by the time the set timeout elapses? So Imran, once the set timeout elapses, it always goes into the queue. The web APIs, no matter how quickly or how slowly they resolve, they always go into the queue. They never, under any circumstance, go directly onto the stack. They always go to the queue first. And eventually the event loop will do another rotation and see that the call stack is empty. And then and only then does it come out of the queue and go into the call stack. We could never go straight from the web API into the call stack because JavaScript is synchronous. It wouldn't know how to handle that. Yeah. Do we ever have to worry about stuff from the job queue go into the call stack and having stuff pile on top of it? No. And the reason why we don't have to worry about it is because of the data structures we just talked about. We know that the stack, right? We know that the stack is a last in, first out. It's a stack. So that means when we're looking at something like this, we know that this has to run before we ever do anything else. So it's the last thing that was put on the stack. It has to be the first thing out. So we don't have to ever worry about something coming from the queue until the stack is completed, because that's the way the data is structured. It's a last in, first out. Then we know that as things get added to the queue, the first thing that added will get eventually put onto the stack once it is empty. So the reason we don't have to really worry about all this stuff is because of the data structures that we're using. We're using the stack, which is a last in, first out, and we are using a queue, which is a first in, first out. I like that. I like what you said, that Imran there, Deb. This is why set timeout is inaccurate. There are coding patterns to handle this when doing a counter and other such things. Yeah, because set timeout really isn't waiting that exact amount of time. It's waiting that amount of time plus however long it takes to get out of the queue and back onto the stack. But if something from the queue goes in the call stack, other stuff can pile on top of it. Yeah, technically, but the call stack will always be empty before the queue starts running. Yeah. So you would have to have like all your JS would have had to like execute before you really get to like the queue. Yeah. Now there are two different kinds of queues. There's a job queue and a task queue. Certain web APIs put stuff into the task queue, and some of them put them into the job queue. There's something called micro and macro tasks, but I think that's like above what we need to worry about. But just know that is a thing. Apologies. Can you say again how something gets assigned to the call stack versus the queue? Yes. Things get added to the call stack when JavaScript executes something that is regular JavaScript. Things get pushed into the queue whenever a web API responds. So console log is actually a bit of JavaScript. So that's going to get put into the call stack, right? Set timeout is not actually JavaScript. Set timeout is a web API. So JavaScript can't handle that. That's an asynchronous thing. It's going to like take some time, then it goes. JavaScript can't do that. JavaScript's synchronous. So that set timeout is going to go to the web API. Right? Things that come back from our web APIs, they never go directly into the stack. Things that come from our web API always go to the queue first. Always. Yeah. And it's only once the call stack is empty that we go and get stuff from the queue. Does set interval work similarly to set timeout? Yep, it's the same thing, except you're going to have a lot more callbacks put into the queue. So did you say stack is last in, first out? Yep. And queue is first in, first out. Exactly. Mm-hmm. Cool. Can you demonstrate how multiple web APIs that take varying amounts of time are transferred to the task queue? We actually did this during class, but the idea here is like, let's say we had more set timeouts. Like, let's say we had like another set timeout that was the same thing, but like a 3-second delay. Right? So let's say we have one more, right? Let's say you have one more line here. That's a wait of 3,000, right? So it's a wait of 3 seconds, right? It's a rate of 3 seconds. So what we would wind up having is the first console log gets put on the call stack, right? So the first console log is put on the stack. That runs, and we see the console log here in the console. Then the next line of code runs, which is this web API that takes 0 seconds. That is put on the stack, but immediately goes to the web API. This web API takes 0 seconds, so it's put into the queue. Then our 3,000 runs. So we had the wait that was 0 seconds, and now we have the wait that went from the call stack to the web API, which took three seconds. Then we finally have this last line of JavaScript that runs, and that's the house 3 console log. Now that there's no other JavaScript to run, right? Now there's no other JavaScript to run. The call stack is empty. Now we start going and looking at the stuff that's in the queue. So that first one that was a 0 delay will run first, right? And then the one that was the 3 seconds delay will run after. So what happens when you have lots of asynchronous things happening is they all get handed off to the web APIs, and whenever they complete, they get put into the queue. So some might happen faster, some might take slower, right? But they all get added to this queue. And the beautiful thing is that eventually once the call stack is empty, whatever was the first one in, whatever completed first, that'll run. Then once the call stack is empty again, it'll go for the next one in the queue, next one in the queue, next one in the queue. And so the idea here is that you can have all these different asynchronous things that are running. We don't care about when they'll finish, how they'll finish. They just get added to the queue when they're done. This makes it really easy to write asynchronous stuff in a language that's not asynchronous by default. Sanders said, no offense, only interest. How can this insight improve our coding? So Sanders, this is really important because you gotta know how your code's gonna execute. Like what line's gonna run before what other line? Like why were we seeing console log 132? That's super important to know as a developer, like when your code's gonna run and how it's running. So to understand how your JavaScript's gonna run in the browser and then by extension Node, you need to know how this stuff works. And so you can go way deeper on all of these things, but literally knowing how your code is executing and when it's going to run is something really fundamental that you have to know. And it's something that a lot of developers, honestly, that write JavaScript on a regular basis don't know. And so this helps you stand out in the job hunt. This is a very common interview question. It's one of the things I ask during interviews. Yeah. And so I think that's really important. And then also it's important to understand like how some of the bigger things work underneath the hood. We had all these promises that we're using. We're going to see a lot of async await stuff. And it's important to understand how this works because it'll help you inform like what you do and don't know. Yeah. So I think knowing how your code executes is really important. Yeah. Let my code do whatever it wants. If it runs first, it runs first. I think I'm a control freak. The event loop is fascinating to me. I think it's really cool. I think understanding how it really works is really key. And so I shared 2 videos. The videos are on definitely on our Discord. But there's 2 videos. One by Jake Archibald, which is really important. It's like the big one. And there's one other video too. I'm blanking on their name. If anyone remembers the other video that we watched, that's the big one. I don't know why I'm blanking on their name right now. Philip Roberts. There we go. Thank you, Flopsy. Yeah. So the Jake Archibald video is required video watching. It was assigned during class multiple times. It's where this example actually comes from. And then the Philip Roberts video is super important too. Cool. All right, let's keep pushing, folks. All right, let's get to that back end. Let's get to that back end. Alrighty. Whew. Back end, baby. Let's go. All right, so question in the chat. Does JavaScript have access to the DOM natively, like built in? Nope. Does not. Does not, unfortunately, no. No native access. No, it does not. All right. Now, we noticed that JavaScript needed web APIs to handle all that asynchronous stuff and a bunch of other stuff in the browser. JavaScript didn't have access to the DOM. That means like document.query selector. JavaScript didn't have the ability to do that. What? JavaScript doesn't have the ability to manipulate the DOM. It doesn't. That comes from the browser. JavaScript didn't have access to fetch. Didn't have fetch. It didn't have set timeout. Didn't have set interval. It needed all those web APIs that came from the browser to do all this stuff. All of that asynchronous stuff that JavaScript couldn't do because it's synchronous, it needed the browser to do. Now, it's important to think about that. JavaScript is a language that can only do what the hosting environment allows. Damn, I've been a dev for like 10 years and didn't know some of this. I'm telling you, there's some interesting things here, right? I'm telling you, my mind was exploding when I was watching these videos. When I watched that the Philip Roberts video for the first time, I walked away with so much new things. I was like, what? Yeah. JavaScript is a language that can only do what the hosting environment allows. We've been running our JavaScript in the browser, and only because it was running in the browser could we have access to things like the DOM. So now we want to take our JavaScript and run it on the back end. We want to run it on a server. So we got to ask ourselves, what do servers need? Now we saw really at the beginning of this, we saw like how the internet works. We know that client side makes requests to servers, servers generate a response. So what do servers need that maybe our client side JavaScript did not need? Food, water, lots of love. JavaScript needs a permission slip for everything. There you go, Ada. Yeah, servers need really kind of two big things. They need access to the disk, like your hard drive or your solid state drive, and they need network access. So our servers need these two really important things. Client-side JavaScript doesn't come with either of these out the box. Why does our client-side JavaScript not have access to the disk or access to the network? Why does our client-side JavaScript not have it? Our client-side JavaScript is what? It begins with an S. It is it's at the playground. It's in the what? It's in the sandbox. Exactly. It's in the sandbox, meaning that JavaScript doesn't have access to your disk, doesn't have access to your hard drive, doesn't have access to the internet, because that'd be really bad in terms of security. If we ever went to a website and just by going to the website, JavaScript has access to all those things, no way. We wouldn't be able to use the web. All right, it's just the web, right? We wouldn't be able to use it. All right. So we know that our JavaScript on the client side, right, doesn't have access to disk or network for security reasons. But on the server side, we're going to need JavaScript to have access to these two things. We're going to need JavaScript to have access to a hard drive so it can grab the files that we want to send to the client. The client is making requests, right? The client, we typed in dominoes.com on the client, and now we want to be able to send that HTML. We want to be able to send that JavaScript. But that doesn't exist magically. Those files are on a hard drive or a solid state drive, or we're just going to call it the disk, right? And so our server needs to be able to go onto the disk, get those files so that it can respond. But our server first needs to be able to hear that request, and it needs to be able to respond to that request. And to be able to hear the request and respond, it needs access to the network, right? It needs to be connected to the internet. And so we know that our JavaScript running in the browser doesn't have access to those things that are going to be fundamental on the server. So we need a different environment. What if there was a hosting environment that allowed JavaScript to have access to the disk and the network? Right? We know that when it's running in the browser, JavaScript doesn't have access to those things. But what if we could have a different environment, a different place that we could run our JavaScript? And when we ran our JavaScript in that place, we got access to the disk, we got access to the network. We'd be able to get files for our users, we'd be able to listen for requests, generate responses. Whenever you see that, that's a warning that we're going to play some loud music and some dancing stuff. And so it's been up for 10 seconds, so we're going to get into it. I need the music so hard, the coffee ain't hitting hard enough. So yeah, What if there was an environment that allowed our JavaScript to have disk and network access? Well, we do have it, folks. We do. We got it. It's called Node.js. That's what it is. Node.js, baby. Let's go to the eyes for a second. Sometimes you just need the music, you know? This is a good one. This is a banger for sure. Yeah, so we got Node.js. Node.js is that environment that's going to give us access to the disk and the network, right? Whereas the browser was an environment, but it didn't give us access to that. Node's going to give us access to it. So grateful for this review, making some connections. Space repetition is working. Amazing. Hey, I love it. That's why we do it, right? Hopefully something clicks a little bit differently this time than it did when we were in class. This gives a mood when I watch these back at 1.75. 1.75 is the sweet spot. I love 175. That's why I watch all my videos on. If you're watching this on YouTube right now, don't listen to me in normal speed. You should be listening to me at 175. Traversy Media gets 2. They're the only person I put on 2. Love them to death, but I got to put that on 2x. I wonder if that lady knows she's being watched by thousands of people on a weekly basis. I'm pretty sure. I wonder like what the story behind the GIF is. That'd be a good YouTube series. Oh, don't steal that. That's mine. I got the story behind the GIF. There you go. The story is the beat dropped. Hey, Fox, thank you for the hydration. Cheers to you. Dino for the win. Why do people always come in? I swear, people come in, they say Dino and then they leave. I always find it pretty funny. I think they just see Node on the they like see Node on the main page and they're like, I gotta come in and say Dino. What's going on, 7? Hope you're doing well. Alrighty. So, Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. Node.js is a JavaScript runtime built on Chrome's V8 JavaScript engine. All right, so Leon just said Node is like where JavaScript can run. V8's what I used to have for breakfast when I was younger. Cross with the bruh. I definitely drank a lot of V8 when I was little. Maybe V8's tomato sauce? Maybe V8 is like vegetables. So, all right. Node.js is a JavaScript runtime built on Chrome's vegetable engine. Yeah, all right, vegetables. It's healthy. That's what it is. All right. Alrighty. So all that fancy terms is just a really fancy way of saying the same shit that lets you run JavaScript in the browser can now be run to run JavaScript on servers, desktops, and pretty much anywhere else. Okay. So JavaScript runtime, it's the same thing as like our hosting environment. It's just a place where we're going to run our JavaScript. Chat, where's the only other place that we've seen, right? What's the only other place that we've seen so far that we could run our JavaScript? What was our other environment? The browser, exactly. Yeah. People keep saying smart fridge. I love it. Yeah, it was the browser. So Node is just another hosting environment, another place to run our JavaScript. The cool thing about running it in the browser, if you're running Chrome, and running it in Node, is we're using the same engine in both. And remember, the engine, we've learned, is just the thing that takes our JavaScript and breaks it down into something else that the computer can actually understand. Remember, our computers don't actually understand JavaScript. JavaScript's a decent language for us to communicate our ideas as developers to each other, but our computers can't actually understand it. So the engine comes with exactly RGB. It's basically a compiler, right? It's a compiler plus a bunch of other stuff. So it comes with a compiler that helps break down our JavaScript into something that the computer can understand. But it also comes with like how we manage memory and how we do garbage collecting and some other stuff that's not just straightly a compiler, right? So that's the difference between like the compiler and like an engine. An engine comes with like a little bit more goodies. And so all it is we have a new place to run JavaScript. And that place that we run JavaScript is using something called the V8 engine, which gives it access to the same compiler, the same way we did memory management, all the same things we had in the browser if we were using Chrome. We now have the ability to do that pretty much anywhere else via Node. And the other cool thing, instead of having web APIs, we're going to have all these things that we need to give JavaScript when it's running on a server. Cool. Somebody name the other, like if you're using Firefox, you're not using V8. What are you using if you're on Firefox? Anybody remember? Let's see. Ooh, accordion with the spider monkey. Exactly. Some monkey thing. Yeah, spider monkey. So Firefox has its own engine, and that's called Spider Monkey. I'm gonna come at you like a spider monkey. Where is that from? What movie is that from? So will that change the way the queue and stack process? It could. It's up to that engine to figure out what it's going to use to implement the event loop. I actually don't know what SpiderMonkey's using, but I would bet pretty hard that it's probably still using libevent or something very similar to implement the event loop. Libov and libevent, these are like really like battle tested, tried and true ways to use the event loop. And so I'd be really surprised if it didn't use something similar. Talladega Nights. All right, there you go. All right. So true story. Once again, V8 engine does all the heavy lifting, right? The V8 engine is what takes our JavaScript and breaks it down, right? And breaks it down into something the computer can understand. Without the engine, the JavaScript that we wrote wouldn't be able to be understood by the computer. We talked about the difference between an engine and a compiler. Engine comes with more stuff than just the compiler. It comes with, like, at least in V8's case, memory management, garbage cleaning, all this other stuff that's not strictly the compiler's job. So that's why we call it an engine and not a compiler. And just like the browser came with web APIs, like it came with the DOM, set timeout, set interval, all these fetch, all these web APIs, just like the browser came with all those, Node comes with a bunch of stuff, right? Comes with a bunch of stuff. And that stuff that it comes with are typically built in via something called modules. So Node comes with all these modules. Just like the browser came with web APIs, Node comes with modules. And so some of the core modules, which are just libraries or collections of functions, are basically just functions. Some of the core modules that Node comes with are HTTP, FS. So HTTP gives us access to the network. FS gives us access to the file system, right? And the cool thing about Node is that we have access to millions of other packages. I think it's at like 1.7 million packages that we can get all via NPM. And so not only do we have like these core modules that come built in with Node, but we have the ability to go and get other ones that we want to use as part of Node. So all the stuff that JavaScript can't handle on its own, Node provides to us through these modules, right? We get access to the network through the HTTP module. We get access to the disk through the FS module. We get access to all these other ones via something like npm. So what varies in between engines? Why have more than one? Because each browser got to choose the engine they wanted to use, right? So Firefox was created as a direct response to Internet Explorer. Then, so like when Firefox was first created, it did a lot of things differently. When Firefox was first created, it was the first browser to do like, well, maybe Opera, but it was the first like major browser to do tabbed browsing. It was the first browser that did pop-up blocking by default. So a lot of these things that it decided to do, it couldn't really do with what else was out there. Tab browsing is really interesting because tab browsing is a really hard problem because are each of those tabs like their own are they consuming their own resources? Because if they're consuming their own resources, then your computer is going to get taxed more and more the more tabs you have open. So Firefox really needed the ability to like control their own destiny and how they were going to manage all that stuff behind the scenes, the program that was running on your computer. So they had their own engine. Then when Chrome came around, Chrome decided to build out their own engine, right? Google was like, look, we make all of our money through search. If we make all of our money through search, we need a way of controlling the internet. And so they made Chromium, which is like the open source version of Chrome. And they were actually really cool with Firefox. They told Firefox like way ahead what they were going to do. They were kind of pretty open with it. And then they built Chrome that used its own engine, right? Now, Firefox, Chrome destroyed Internet Explorer, right? Like they went the way of the dinosaur for a little bit there. And now Internet Explorer, Microsoft is saying, all right, well, we want to make our own browser again. But instead of rebuilding the whole thing from scratch, they actually decided to use Chromium, which is Chrome's V8 engine and all that stuff. So the new Microsoft Edge is really just Chrome underneath the hood. So now we've come like full circle. So where we had to have our own engines, now we're all kind of consolidating engines because it's just easier. Makes more sense. So yeah, sorry, that's a long tangent, but yeah, so that's what happened. Zaba said, what are the difference between Node, Angular, and Vue? So Vue and Angular have to do with the front end. They're not a way of kind of handling what happens on the server. Node is all about handling what happens on the back end. Yeah, we're gonna get to MVC later today, right? Model View Controller. And so Vue and Angular are gonna be ways of handling the views, like what the user sees in the end, but not so much like how our CRUD API is set up, how our server is set up, things like that. That's so cool. The whole computer science history is generally incredibly interesting. It's so interesting. Like there's such a good movie to be made here of like the browser wars. I think it could be, if somebody took it on and did it really good, I think it'd be a lot of fun. Also, if you really like computer science history, I really recommend a book called Code by Chris Pertzold, something like that. Code by Chris Pertzold. It goes all the way back to like ships using light to communicate all the way up to like modern computing. And so it's really cool. If you like that history, definitely read Code by Chris Pertzold or something like that. Cool. Oh yeah, look up why we call them bugs. That's a pretty funny story. It is, yeah. Alrighty, cool. So now we have access to a new runtime environment. Petzold, there you go. That's probably what it is. We have access to a new hosting environment, one that's going to give us access to the network and access to the file system. One's going to give us access to millions of other things via a package manager like npm. We're no longer using web APIs because we're not in the browser, but actually C and C++ APIs. So underneath the hood in Node, all of these modules are really using C and C++. We're using things that are like tried and true. We're using libof for our event loop instead of lib event. Like in the browser, we typically use lib event if you're talking about Chrome, but in Node, we're using libof. We're getting all these things that are built using C and C++. And the beauty here is that these packages are super fast. They're super fast, right? And so we get the benefit of like sitting on top of these packages that are really, really fast, that can handle all the things that we need to do. Yeah, Code, the Hidden Language of Computer Hardware and Software. That's the book. Yeah, thank you, Being. Yeah. So we get the benefit of a new environment. That environment comes with a lot of goodies, and the goodies we get are really fast. All right. So to use Node, you're going to have to install it. There are many, many different ways that you can install Node. One of the easiest ways is just to go to their website and click install. That's what I recommend for beginners, not to get anything fancy or do anything fancy. You just click install on Node and you get to it. There are many different versions of Node that you're going to see. And we're going to take a break in just a few seconds here. But there are many different versions you're going to see. You're going to see a lot of times like an LTS, which is a long-term stable. You're going to see a current. And then sometimes you're going to see a nightly. Okay. An LTS is the long-term stable, meaning that it's going to be supported for the long run. You don't have to worry about maintenance or security issues. They'll all be fixed. Current is the most recent version that will have all the new goodies, like all the new things that are getting added to the language, or the environment, right? And so and then sometimes you have like nightly builds, which are like it's the wild, wild west. Things might break, it might not work at all, but you get to test out all the new stuff before it even makes it into current. And so for this class, we're using an LTS, but you could easily just use a current. It doesn't really matter for us in our learning. We're not really using any of the like cutting edge stuff in Node, so we don't have to worry about being on current. But if you're at a company, you're probably going to be on an LTS, right? And the reason why you're going to be on an LTS, right, is because you want that ability, right? You want that ability to know that your code is going to be supported for the long run, right? It's going to be supported for the long run, right? You want to make sure that when your code is running and you have your servers up, you're building your whole company around that language, you want to know that the security issues, the vulnerabilities are going to be taken care of, right? So you would want to use a LTS simply because you know that it's going to be supported for the long haul. Cool. Future planning, exactly. Alrighty. Let's go ahead and take a break. And when we come back from break, we're going to start looking at building a simple Node server. What's currently and nightly then? Currently is like all the new stuff. So if we go to Node, go to like Node's website. I love that Neopets comes up first. If we go to Node's website, you're going to see an LTS and a current, right? LTS is that long-term support, right? Like that ability to know that if you build your company around this version, it's going to be supported for the long haul, right? And then current has all the latest features, like all the new stuff that's not in the LTS. So sometimes you might really need a new feature for your company, but most of the time you want to make sure that you're on like an LTS. That way you know that you're going to be supported for the long haul. And so make sure that you're on an LTS. It's just so that like you're secure, basically, that you're stable. You can build your whole company, your whole application around it. You might not get all the current stuff, but you know that you're supported for the long haul. And then for some things, I don't know if Node has a nightly. I don't think it does, but things like Chrome has a nightly version, right? And the nightly version of Chrome is really fun because you're going to get these like really cutting edge features that you're going to have in Chrome, but like you might not be able to open up your email sometimes. So you could be on the LTS, you could be on the current, or you could be on the nightly for some types of programs. And it's just kind of like varying degrees. I think Chrome has like Chrome, the browser, has stable, dev, and nightly. And so stable is like what all the normal folks are on. Dev is like you're a developer. You want some of the more tested new features, you're on dev. And then nightly is like you're developing for Chrome and you want all the cool stuff to see how it breaks. Can you have both installed? I think in Chrome there's a flag that you can set that switches between dev and stable and stuff like that. So you can switch pretty quickly. You wouldn't want to have both running. It'll cause you some weird stuff. No worries, Robo. Have a good one. All right, folks, let's take our break. Gotta take a break. We're over a little bit on the break time, so I want to make sure we get our break. Let me go ahead and pull up the timer. I'm gonna put 5 minutes on the clock here. Please, we've been going for 4 hours, folks. You gotta take your breaks. You gotta hydrate. You gotta get up. You gotta walk around a little bit. So let me go ahead and put some nice break music on here. And let's start this timer here. All right, midpoint coffee break. Let's go. Oh, I thought you meant like versions of Chrome. Yeah, like you can run multiple versions of Node very easily. Yeah, MVM is a great way to switch between them. There are some other ways to do it too. If a recruiter interviewer asks us how long we've been working on a language framework, what's the best way to answer it? So you can answer it honestly, right? You can say, well, the way I would answer it is I've been developing however, like, so it's up to you. Right? It's how much you want to finesse the answer. If you've been a freelancer for a year, say, oh yeah, I've been coding, and the way you say I've been coding Node for a year, or I've been writing JavaScript for a year. All right, I've been building for a long time, but I've been building Node for a year. Now, what they're going to hear is that, oh, you've been building for a long time. You've been specializing in Node for a year. So that, you could even say that a little bit more specifically. Oh, I've been specializing in Node for a year now. All right. And so that sounds a little bit different than I just started learning to code and now I'm using Node. But I try to stay away from those types of questions. So I've been in engineering for a while now. Been really kind of getting more aggressive with my Node understanding. I've built a lot of full stack web applications. So if somebody asks me that question, I say, yeah, I've been developing for a while. I've been building full stack Node applications for a period of time now. I've built these 4 full stack web applications recently, and then kind of keep pushing. Let them like push and say, no, I want a number. Oh, if you want a number, I've been doing it for X. Let's go ahead and run some ads just so that you actually take a break and new folks don't get to see them. All right, see you on 3. All right, I'm going to take a break too. Burb. Ooh. About 40 seconds left. If you haven't gotten a drink, go get a drink. When does the stream end? I have no idea. Normally my classes are only 3 hours long, but since this is a review session and it's entirely dependent on how many questions you ask, I have no idea. We could be here all night. What dictates what kind of HTML EJS outputs? EJS does. We have no control over that. We're using EJS, and whatever they give us is what we use. All right, folks. Come on back. Come on back. Wait, I'm finished putting my wash in the dryer. Can you recommend a good EJS tutorial video? No. There's only 2 things you need to know for EJS. You need to know the carets percentage sign, and then the carets % sign. One's for variables, one's for regular JavaScript. Once you know those 2 things, you can build whatever you want in EJS. The only other last thing that you need are partials, which we'll talk about today. Yeah, once you know partials and those 2 bits of syntax, you can build whatever you want. The docs are pretty decent for it, but that's it. I don't think I've ever really used anything other than that, plus comments. Yeah. So we'll talk about those today. So if you have questions about those today, let's talk about them. But really, it's just those 4 things, and that's why I like EJS to start. Is because I really only need to know those 4 things: the partials, the equal and non-equal, and I can do whatever I want. Yeah. All right, folks, come on back. Come on back. So yeah, when we get to EJS, let's
Bruh.
Crub. I love it. Will you go through the MS authentication today as well? No, we're going to do local auth today. We're going to do local auth today. And so that's what we'll spend some time on. Are you hydrating with just coffee today? Yes. This is a long stream. I only like 3 hours is peak for me. We're at 4 already. We haven't even hit the goods yet. So I'm definitely doing some coffee today. Need to work on lesson plans for this week. Want to thank you and everyone for today. Hey, Face, glad you're here with us for a while. Cat and all caps water. At least some water. Coffee has water in it. What are you talking about? Coffee has water. It's got the good water. It's water with the go-go juice in it. It really is a wizard mug. It's see-through. I know you better than this, Leon. Cat. Cat's telling me I gotta do something differently. Hold on. I got you, Cat. Don't worry. Reached in the mini fridge just for you. Hold on. Oh yeah. Hold on. Oh, let's go. Oh, so good. Oh yeah, that's the stuff. You want to see the truth? You want to see the truth, y'all? It's been a rough week, folks. It's been a long week, folks. It's been a long week. Like I said, this is always the hardest week of my year. Where's the Coke sponsorship? Yo, Diet Coke, you want to sponsor? Hit me up. You just gotta send me Diet Coke. I don't care about it. I'll put a little Diet Coke in the screen for you 24/7. Whatever you need, let me know. Blog, thank you. Good luck. Alrighty. Let's get back to it. Alrighty, so I'm going to chill the music here. There we go. Sorry, took a second. Coke is also known as syntactic sugar. Baba, we're doing a free 30-week software engineering bootcamp. And so we're live every Tuesday, Thursday for class. Sundays are our office hours. If you have any questions, do ! 100 devs to learn more. What should I eat for dinner? That's a hard question. I'll get back to you. Alrighty. So we started saying, all right, we have this new hosting environment, a hosting environment that gives us access to the disk. It gives us access to the network, and we can start using it. So we know we have these two modules, and modules are really just a collection of functions, right? Collection of functions that, a collection of functions that enable us to do all the heavy lifting. Oh, come on now. I prefer Coke Zero to Diet Coke. So I can see that. Like if you grew up drinking Coke, Coke Zero probably makes the most sense. But my mom always drank Diet Coke, so I grew up drinking Diet Coke. So Diet Coke tastes like home. And so that's why I like Diet Coke over Coke Zero. Coke Zero tastes too much like regular Coke for me. And so I don't like it. It's too sweet for me. Yeah, it's too sweet. So I like the Diet Coke better. Knox, I'm glad I'm not the only one. There we go. All right, so we have these modules. And remember, modules are just a collection of functions that we didn't have to write. They come with Node. And so what we're seeing here is a very simple way to create a server. We are going to require the HTTP module, right? So that's telling the code that we're writing, hey, use this module that comes with Node. Then we're going to require the FS module, which is saying, hey, give me this FS module, right, that comes with Node. And then what we're going to do is we're going to start using those modules. And those modules are really just a collection of functions. And so when we look, create server is really just the what, chat? What is create server here? What is it really? Yeah. It's really just a function, right? And actually, the HTTP module is really an object holding all of these functions, right? And since it's an object holding all these functions, it's technically a method, right? So we're going to call it a method. But if we were able to look at the HTTP module, if we were actually able to like open up the module, we're going to see a bunch of these functions. And one of those functions is the create server function. Create server does all of the lifting for us, right? It does all the lifting for us so that we don't actually have to write the code that sets up the server, like the thing that's like listening for requests and generating response. We don't have to code any of that. It comes baked in with Node through the HTTP module. And the wild thing is that this HTTP module comes with so much stuff. So much stuff. It does all this heavy lifting for us. We don't have to think about it. We don't have to ever think about the stuff that's in the HTTP module. If you were here for the OOP class, we would see that the HTTP module, what? It blanks out what? It does what? It does what? It begins with an A. The HTTP module does what? Yeah, it abstracts. Yeah, it abstracts. We don't have to ever worry about like how the create server function works. Really, it just does it for us, right? It abstracts all those details. We can use it, but will we actually really know what's happening? Not really, unless you really want to like nerd out and read like the documentation. You won't ever really know. You'll just know that you use create server to, well, create a server, right? And so we have this create server method. And the really cool thing is that it just takes in a what? What would that be? What did I highlight here? What is that? It's definitely a function, but what did we learn about today? Yeah, Wolfpack. Yeah, it's a callback. Remember, create server is a method, which means it's a function. So we have a function taking in a function. We have a function taking in a function. That's a higher order function. And the argument, like the function that's passed in, we call a callback. So once this creates server, like once it does its job, it's going to use this callback method, right? It's going to call this callback function. And the callback function is going to use fs, which is another method. It's another method. And it's another module. And read file is another method that comes with that fs module, right? And so create server came with HTTP. Read file comes with fs. And what this does is it enables us to go and grab a file off of our hard drive. FS enables us to go and get this demo file.html off of our hard drive. JavaScript does not have the ability to read a disk. It has that ability because JavaScript right now is running in Node, and Node gives JavaScript the ability to talk to the disk, right? Gives it the ability to talk to the disk because of the FS module, the file system module, exactly, right? And so since we have access to this file system module, now our JavaScript can talk to the hard drive. It can talk to that solid state drive and grab that file and respond with it. So whenever somebody comes to our server, we're going to respond with this HTML file that we got from our disk. This is something JavaScript cannot do on its own. It needs these modules to do all the heavy lifting. And so the cool thing, this is a very, very simple Node server. This Node server will be listening on port 8000. So if we go to like localhost 8000, it'll be listening. And when it hears that 8000, what it's going to do is grab this file and respond with it. Pretty nifty. And so we get all that muscle done for us. We're able to start our own server. And with just these two core modules, we can build our own server. That's cool. It's like reading a file in Python. Exactly, yeah. JavaScript doesn't have the ability to do that, but since we're running it via Node, we do. How is rec and, I'm assuming, response passed to create server? It's not. So rec and response are the two parameters we're setting up inside this callback. And so inside this callback, we're going to be able to handle those two things. And technically, it's probably coming from create server. But it's one of those things where like how that actually works is probably not something you're ever going to really dig too much into. You just know that there's a request and a response that comes to us because we are using create server, right? So we know that we have access to the request that came in and the ability to respond, and that heavy lifting, right? That heavy lifting of like listening for the request and listening to the response, that's all coming from the HTTP module. Now, how that does it underneath the hood is not something that I really understand, honestly, like exactly how it's doing it. You would only really ever want to dig into that like if you are trying to contribute to the node as an open source project. Should this code be executed in a plain JS file? Yes, it's a JS file, but that JS file needs to be part of a node server. Yeah. All right. Let's take a look at a little bit more of a complex backend. So here's a little bit more of a complex backend. I'm going to run this real quick. And don't worry about it. I'm just going to do node server.js. We're going to see how to run files and stuff like that deeper. I just want to get this running. Oh, I got to do npm install. Sorry. So right now I'm getting an error because I don't have Figlet installed. So let me go ahead and install Figlet. Don't worry, I'll make this bigger later. Npm install Figlet. Cool. All right. I just want this up and running so we can see it. All right. So my server is running. We have server running on port 8000. Let me go ahead and go to localhost 8000 so we can see this. Like I said, I'll make everything bigger in a second. All right, so here's localhost 8000. You can see that I'm serving up an HTML file. I can go to a different route here. I can go to like other page. Cool. I can go to other page. If I try to go to a page that doesn't exist, Zumba, I get a 404, and I can go back to the main page. I can enter in a name. I can enter in another name. Whoops, sorry. I gotta do lowercase. Enter in another name. Oh, Leon. Bossman. Baller. All right, so it's working. It's working as we should. It's working as it should here. All right. It didn't recognize John, but it definitely recognizes Leon. Leon. Bossman. Baller. We have multiple pages. All right. All right, we have multiple pages. So let's take a look at this. It should be a very confusing backend. There's a lot of stuff here. How do you keep track of all of those modules? I'm really just using the same modules over and over again. So it's basically the same core modules I use over and over again. And then if I need to do something extra, I look up a new module. That's it. Yeah. What does Figlet do? Figlet just makes it look cool. Figlet made that 404 look like it's pretty cool. Yeah. Isn't it easier to show them Express? What do you think we're doing? What do you think this is? What do you think is going on? What do you just think that we're out here just teaching people wrong stuff? Get out of here. Go away. Go back to wherever you came from. We made some nerds angry. Of course we're going to show them Express. This is a 40-week boot camp. That we 30 weeks. Sorry. Yeah, this is a 30-week boot camp. We've done that. They've all built full stack web applications using Express. We're doing a full review. And here's the thing. When you're teaching people, you don't just jump to the things they're going to use. You got to build up to it. You got to make sure they can understand what's happening behind the scenes. Get out of here. Go. Get. Got. Came in here to get. You got. I love it. We've helped people get jobs. 7 people already jobs. We've helped people make $60,000 in contract work. And this person was like, you got. They came in there like, hold on. Let me drive by here. Let me poop and scoop here. Shouldn't even teach them Express. Got him. Oh, got him. Gonna teach him. Oh, he didn't use Express. Oh, got him. Got him. He got. He thought he was gonna get. He got. Get out of here. How dare you? Super, we're just messing with you. Yeah, we're gonna get to Express. It's all the Diet Coke talking. Yeah, we like to build up the things around these parts. We don't like to just jump into the basics. We want you to understand why Express is so helpful, right? So you can't understand why Express is helpful if you haven't done the pain that is building it from the core modules. But yeah, thank you for pooping, scooping here. Alrighty, so We have HTTP, we have FS, we know what those are doing, right? The HTTP is enabling us to kind of listen to those requests, generate those responses, right? I guess that makes sense. What are you doing? Of course it makes sense. We have the HTTP module. We have the HTTP module that's actually listening to our network. We have the FS module that enables us to listen to the file system and talk to the file system, get things off of our hard drive if that's where it's stored, right? But how did we do that when we were in the browser? What web APIs did we use that gave us access to the hard drive when we were running our JavaScript in the browser? What gave us access to the hard drive? What gave us access to the network when we were in the browser? I was trying to get you. It didn't. We didn't have anything to do that. That would have been really bad. It would have been really bad if our client-side JavaScript could find its way to the disk, get the stuff off of our hard drives. That would be bad. So the browser environment never gave us access to the disk, right? That'd be bad. Like if we go to a website and it could like pull the stuff off of our hard drive. Hey, what's up, Chocos, with the raid of 67 folks? I love this. I just love that about so bad. How you doing? Thank you for the raid. Hope your stream went well. What were y'all up to today? We got a chill. We're just doing a chill back end review today. So what were you up to? How were you? What were you working on? We're just gonna take our time here. We contributed to Casa. Tell me more. Tell me more. What's that? I don't know. Casa. What's Casa? Oh, court-appointed special advocates. That's cool. Oh, an app for Ruby for Good. Okay, that's cool. That's really neat. Did you all finish it? Or is it kind of something you're going to do over a couple of streams? It's fun. We're just going to have a one-on-one conversation right now. Sorry, chat. What made you work on that? What made you say you wanted to work on something to contribute to Casa? We've been going for 4 hours. I can take my time here, folks. What made you want to do that for Ruby for Good? That's pretty cool. They are a celebrity. We're going to take our time here. I want to know what they've been working on. How was the stream, folks that came over with the raid? Did you learn anything? Did you pick up anything new? A tip or a trick? Finished one PR. The second PR had some test issues. So I got stuck, tired, / hungry. Hey, I feel you. It's rough. I can't tell you how many times I stopped coding because I was hungry. And the getting stuck is real. That's one of the things we haven't talked. We talked a little bit about here on the stream. Like, one of my first jobs was like a mover. It was like a moving company. And so I would go to people's apartments. I would take their boxes and put them on a truck. And at the end of the day, my body was just like spent. And there are some times where I got like 3/4 of the way through that job that day. And my body was like, no, that's it. You're done. You're donezo. You shouldn't be lifting anything more. And those days were really, really rough. I feel like we don't realize how much our brain is doing that as we're coding, right? Like, our brain just gets to a point where it's like, nope, done, donezo. You haven't been giving me enough calories. You haven't been feeding me well enough. And then it's like, it's just stop, right? And so that's why we take breaks here. That's why we make sure every hour we're stopping, right? Because you really do hit that like mental your mental focus just goes off a cliff, right? And so that feeling of tiredness and hunger, I feel hits really real. That's cool. I like Ruby for Good. It's an incredible organization that brings devs together to build apps for nonprofits, charitable orgs. It's the best first open source app I know of. Great for new contributors. Let's go. All right, I'm gonna share that out after our stream today. I'll share all those. I'll share that link. That's pretty cool. We have a lot of folks that are looking for kind of some of their first open source contributions. That's pretty neat. So everyone that's doing the bootcamp has to do one of three things. They have to either get a paid client, contribute to a grassroots organization, or contribute to open source. And so we've had people bring in over $60,000 worth of client work. We've had, I think it was 12 grassroots organizations and a whole bunch of open source contributions. So it's pretty cool. Thanks for stopping by. That's pretty neat. I'm going to check out next time you're live. I'm going to swing by because I think it'd be cool to see what you're building. Also, Casa is pretty dope. All right, folks. Hey, I appreciate the raid. And I appreciate everybody that came by. Hello. Welcome. We are doing a back-end review. And we're just at the point where we're getting to Node. And we're seeing some ugly Node code here. All right. It's the wild, wild west here. We're using just the core stuff. Hey, Anonymous, thank you for the gifted sub. Hey, I appreciate that. Thank you so much. We're just doing the core stuff, the stuff that Node comes with, right? Excuse me. And we're able to build a server. It don't look pretty, but it works. And so we're looking at some of these modules that we have here. So this HTTP module enables us to listen to the network, listen for requests that are coming in, and to enable us to respond to those requests. This code's too ugly. I'm going to go watch Netflix. Hey, I feel that way sometimes too. All right. Chat, how did I make a request? I keep saying the HTTP module enables us to listen for a request and then to respond. But how did what were some of the ways that I made requests here, chat? Tell me how I was making requests. Yeah, I was able to hit enter on the URL. That made a request. I was able to refresh. That made a request. I was able to submit the form. That's a request. All right. All of these are different requests. Exactly. Who does that? I can't get over this. Who comes to a stream and is like, oh, shouldn't you be teaching them Express? Doesn't look up who we are, what we've been doing, right? Doesn't I've helped hundreds of people get jobs. I've been teaching for 10 years. This come in. Shouldn't you be teaching Express? I don't think you're doing it right. I think you should be doing Express. This doesn't seem right. I know you've helped hundreds of people get jobs. I know you've been doing this I know you're distinguished faculty. I know you taught at Harvard. I know you taught at MIT. I know you did all these things, but I really think you're doing it wrong. I really think that you should be using Express. Screw that you've been teaching for 10 years. Screw that you taught at Harvard. Screw that you taught at MIT. Screw that you are distinguished faculty at GA. Screw that you've helped hundreds of people get jobs. I really think you're doing it wrong. And I really want you to know that I think you're doing it wrong. So I'm going to type it out and let you know that I think you're doing wrong. Just wanted to let you know that. Go about your day. Have fun. Bye. Toodles. Thank you. See, I get that all the time. It doesn't matter the language. It happens. It's so wild. I just don't get that mentality. I just don't get that mentality. And it'd be different if you came in and be like, hey, let me hang around for a second. Let me figure out what what's going on here? And then you could phrase it like, hey, like, what do you think about Express? Like, do you think Express could be more helpful here? But nah, poop and swoop, poop and swoop. You poop and you swoop. I just don't get it. I would just never do that to anybody. It makes no sense to me. Yeah, they living in my head rent free right now, but I just don't get it. I just don't get it. Poop and swoop. All right. No, I don't think it. I don't want to ban them, but I think it's interesting. Like I just would never do that. Just would never do it. Anyway, cool. So we saw all these different kinds of requests, right? Saw all these. Get out of here, Rudy. We see all these different requests, right? We have all these different kinds of requests, right? We saw that we can go ahead and just refresh, right? That was a request. We hit enter. That was a request. We were able to submit this form. That was a request. Going to different pages in the URL, also requests. And right now, our server is set up to handle all of those requests. And the reason it's able to handle all of those requests is because we're using this HTTP module that can hear those requests, right? Now, there is a lot of other things that have to happen so we can hear that request and know what to do. And as we're building out the backend, right, we're really keenly focused on hearing what request it is and figuring out how to respond. All right? We want to hear that request and figure out how to respond. And so here we have our simple server set up. It's really sloppy. There's a lot of stuff in here that's wild, right? But we have this request that's coming in. We're able to grab that URL with this code here. And we're able to grab any of our query parameters with this code right here. So we're able to say, hey, let's look at that URL, that request that's being made. And if that URL is just the localhost 8000, then this is the code that I want you to run. If that code is /other page, right? Like if that the URL has /other page in it, here's the code I want you to run. If that URL has other page in it, here's the code I want you to run. If it's API, here's the code I want you to run. Right? And so we're able to look at those URLs and do things differently each time. Maybe we're asking for a CSS file, we're going to do something differently. Maybe we're asking for a JavaScript file, we're going to do something differently. Right now, this is set up to just use the core modules to do every single thing that we want. Right? It's up to do everything we want. So could we build out a full web application, right? A full web application that's just using these core modules? Yes, we could. We could build out our whole application just using these core modules, doing all of this like really specific, like listening for each individual page, using the FS module each time to go and get that specific HTML page. We would have to code out all the API stuff in a really weird way. We'd have to code out like listening for our CSS pages. We'd have to code out listening for our JavaScript requests. We have to code out like what happens when we request something that doesn't exist. All of this we can do. We can build out a full web application doing it. We did it together previously in the bootcamp, right? Where we built all this out, right? But it's not really easy to read. It doesn't give us the flexibility that we want going forward. And so could we do it? Yes. But right? But hold on, I got it. Fox, thank you for the hydration. Cheers to you. But how could we do it if we wanted to clean this up? If we didn't want to have to hand code everything, if we didn't want to have everything in one giant conditional statement that's a hot mess, right? What could we do if we wanted to clean this up? Express. Express is how we could clean this up, right? To make sure, right? To make sure you got. That's what happened. You got. They got. They came here thinking they're going to get. They got. Right? We can use Express to clean it up. And Express is going to help us to build out. It's going to help us to build out our web applications. Right? Express is going to do a lot of the heavy lifting. We're not going to have to code out like each of these things by hand. We're not going to have to code out like this massive. We're going to be able to have some structure. We're going to be able to add some patterns and things that are going to make our lives a lot easier instead of having to do this all from scratch and using just those core modules. And so what we do is we're going to add something like Express. Now, is Express the only thing that we can use? No, there are many other web frameworks, but Express is pretty easy to pick up. It's pretty well used, and that's what we're going to be using. It's what we used for the previous classes, and so we're going to use it today for the review, of course. All right, now, if you go to Express's website, you're going to see some text. You're going to see, all right, a fast, unopinionated, minimalist web framework for Node.js with a myriad of HTTP utility methods and middleware at your disposal. Creating a robust API is quick and easy. All right. I got fast. I know what that means. I know what fast means. I know what fast means. What's unopinionated mean, chat? What's unopinionated mean? What's unopinionated mean? These are a lot of big words. I'm going to treat them as disrespect. Doesn't force you to use it in a specific way. I like that. Yeah, it doesn't lock you into a certain way. There are some web frameworks. So when I say web framework, it's just going to make it easier for us to build our web applications. It's going to give us some structure, some common things to do, right? Unopinionated means that we can use what we want to use. We're not locked into doing things the express way. We're not locked into using specific methods. We're not locked into using specific modules, right? If you want to use Node Mailer to handle your email and Passport to handle your authentication, you can totally do that. Express doesn't care what you bring to the table. Dak A, thank you for the 6 months. I appreciate you. Thank you so much. Thank you for being here. Right? It doesn't care which ones you bring to the table. Right? So it's unopinionated. You bring whatever modules you want and Express will work with you. It's not going to hold you to it. There are many other frameworks that say you have to use these modules at these times and this is the way you use them. And so those wouldn't be unopinionated. Those would be very opinionated. Like there's a way you use it. Now, a lot of folks, sometimes when they're starting out and they're new, they really like opinionated frameworks. They want to know the best way to do it instead of having to kind of figure out each piece. And so there are things like Adonis or more ways that are like more opinionated than Express would be. Express is kind of like, I'm going to do one thing and one thing really well, and then everything else you can bring along what you want. And so Express is minimalist, right? It only does like one thing really well, right? And it's a minimalist web framework, meaning that it is fast. It doesn't care what you bring to the table. It's simple, and it just handles one really important thing. And what it handles is setting up, right, your HTTP utility methods, right? It's just everything that you need to be able to basically handle your requests and generate responses. And so it comes with all of these methods that make working with HTTP way easier. It comes with a bunch of middleware that makes that easier, and it enables you to build your API very, very quickly. So what does all that mean? What is HTTP, chat? When I say HTTP, what is that? Main, we don't have a date for the next one yet. Yeah, it's a protocol. It's how the internet, as we've been using it, works. It enables us to send requests and get responses. And so it's the one thing that we're going to need. Like if our server is going to listen to requests and send responses, it needs access to that protocol. It needs to know how to work with that protocol. But that protocol is really intense. Like if you read the book on it, it's like that thick. It's a thick boy, right? And so Express says, you know what? You don't have to worry about understanding how HTTP works. You don't have to understand like how the requests and responses are coming in and going out. We'll handle all of that for you so you can focus on building your API. What's middleware? Chat, what's middleware? Yeah. Yeah, the stuff between the request and response, I like that. So the stuff that has access to the request and response, I like that. Yeah, it's called middleware. It's in the middle. It's in between the request and the response. It's everything that we need to help us handle that request and that response. And so Express comes with a lot of methods that make working with HTTP really easy. It makes handling those requests and responses a lot easy. And we don't have to know all that really funky stuff that we just saw in the last code base, right? We can just focus on building out our API. So our API is just going to be what we want to have happen when we hear those requests, right? When somebody makes a request, our API is the thing that responds, right? We hear that specific type of request and we're going to give out a specific response. That's all it is. So we don't have to worry about all the heavy lifting. We don't have to worry about dealing with the HTTP or the file system, really. Express is going to handle all that for us, and we can just focus on building out our own, and eventually we're going to call our CRUD API for right now, where we can just listen for like, all right, they're making this type of request. Here's the response I want to send. Okay. Wolfpack, thank you for the hydration. Cheers to you. My computer just did something weird. Y'all still here? Hello? Say hello if you're here, please. Okay, cool. Thank you. I don't know what it was. My computer, you know, like when like Windows goes like something turns off and goes doo doo doo. That happened. I don't know what it was though. Cool. All right. Thank you for saying hello. Hey everybody. Hope you're doing well. This is a lot. Cool. All right. So Express is going to do all that heavy lifting for us, and we can just focus in on building our API. Now, we have a lot of new folks, okay? So this is meant to be review. There are a lot of new folks that are here in chat. I see all of you. Wolfpack, thank you for the hydration. Cheers to you. Thank you for the hydration. A lot of new folks. This is a review. This is not the first time we're experiencing any of these concepts. So if you're like, oh, wait a minute, I don't get this. This doesn't make sense. Ask questions. We'll try our best to answer your questions live while we're here live. But we literally have 40 other classes that you can come back to and go deeper on any of these topics should you choose. Okay. So today's review, ask questions if you have questions. We're going to be looking at a lot of code together. So ask lots of questions. Leon, I don't understand what this line does or makes sense. Explain it. I'm happy to explain it. But all of our other classes are on YouTube. Exclamation point YouTube. And the other thing you can do is you can join our Discord. We have 3,000 people on that Discord that want to help you be successful, to learn how to code. And we're doing this all for free. Funny, I see your stretch. I'll get there in a second. We're doing this all for free. Every single thing I ever recommend to you will be free. I have not given out a resource that was not free on this class ever. I will never lock any of my content behind a paywall. Everything will always be free. All the subs and the bits and all that wonderful stuff that actually gets donated to the nonprofit I work at during the day. It goes directly into our emergency fund to help our students with their mental health needs. All for free. So please, if you want to learn how to code, !100 devs in chat will tell you everything you need to know. And then you can watch all of our past classes on YouTube. Join us live every Tuesday and Thursday. We're really happy to have you. Funny, thank you for the stretch. Old Coder Chick, thank you for the 300 bits. I appreciate you. Hold on, I gotta do my stretch. You know, it's not that kind of stream. Ooh. Oh, yeah. It's true. Even the YouTube isn't monetized. Yeah, I'm trying to hold off on, like, I don't want any, like the YouTube is a weird one. So right now the YouTube, I've made YouTube partner, but I haven't accepted it because once I accept it, the ads start. And I don't see any benefit of us having the partner thing on there. So we're just going to not do it. But there's a lot of talk that, that YouTube is going to start running ads even on stuff that's not like partnered, like non-partnered ones. Like, so even if you don't have monetization turned on, they're going to start running ads on it. So if that happens, then we'll turn it on and just donate the stuff to RC. But until then, I like that there's no ads. That's pretty cool, right? Like you can just watch through and not have to worry about any ads. And so I want it to stay like that for as long as possible. But if they turn on ads for non-monetized content, you're going to bet we're going to turn on monetization so we can send that to RC. Cool. So we have this new Express thing, but let's blast to the past real quick. Let's talk quickly about how the internet works one more time, and then we're going to jump into looking at some actual code that uses Express. And so let's do that after we take our break. We're at the top of the hour. Let's take our break, and we're going to start building out. We're going to start talking about like what our API is. What is this CRUD API thing? What are we talking about? We're going to take a look at some code. And so let's take our break, and we'll come back to how the internet works when we start throwing into the mix like the back end and CRUD APIs and all that fun stuff. So let me go ahead and pull up the timer. 5 minutes on the clock here. Can we run our YOLO back? We can do it when we come back from break. We'll do another YOLO. All right, let's go and put 5 minutes on the clock here. Let's go ahead and run some nice break musics. And go ahead and take a break, please. If you're able to, please get up. Please hydrate. We've been going for a clip now. We've been going for 5 hours. So if you're not taking care of yourself, it's going to start to hurt, like literally. So get up, hydrate, move around, do what you got to do. I'm going to run some ads too to force the break and make sure new folks don't have to sit through them when they join us. I watched all 3 John Wick movies this past week. What did y'all do? I worked my ass off this past week is what I did. Yeah. So demo day for our Resilient Coder students was on Thursday. And so my week up to demo day is just like dozens of one-on-ones and helping folks like get their projects across the finish line. So just lots and lots of code, lots of debugging, lots in the muck. And so I actually love it. I think it's so much fun. It's just a lot of work, just a lot of fun. Played a lot of League. That almost sounded like a Seth Rogen laugh. Like, surprise! No, take off my mask. Yeah, I really want to. So two things happened this weekend that I really want to get into. Is the Mortal Kombat movie came out recently. I really want to see it. Haven't had time to watch it yet. And Pokemon Snap come out. I've been like that's all I want to do is play Pokemon Snap. So as soon as this is over, I'm playing Pokemon Snap. That's what we're doing. Yeah. Yeah, it just came out for the Switch. Super pumped. It came out on Friday. So 2 days ago, day ago. Yeah. Are we going to have SQL sometime in the course? Yeah, we're going to do a little bit of Postgres. We won't go like super deep into it, like enough to know how it works, enough to do well in interviews with it, but it's not something we're going to spend super a lot of time on. We're going to spend most of our the really big things we're going to spend most of our time on towards the end are React and data structures and algorithms. So just getting ready for interviews. Saw the new Mortal Kombat. As a movie, it wasn't very good, but as a representation of the story, it was pretty good. That's what I want. It could be hot garbage, but if it's actually like Mortal Kombat and like the lore, that's what I want. That's what I'm coming for. The movie could be hot mess, but I want the lore. I want to feel exactly. I want to feel like it's the early 90s. Loved it. It was super fun. That's cool. One of the things that has me most confusing to me is on the back end, is just how to set up all the files and where to require various things. Can you address this? Yeah, we'll do it together. But really, so honestly, it's just you create the folder and you require the things that you need. And the main place you're going to do most of your requiring is just in your server.js file. That server.js file is going to be like the main setup file. It's going to be where you're going to pull in all the bits that you need, and then everything else is kind of just extra. So yeah. So we'll look at that in a second. But really, whenever you need a package, you require it. That's the bulk of it. Yeah. And then what you're going to notice is that you now have a template basically to build whatever you want. And so the template is basically what you're going to start with all the time. Like you're not going to code a lot of this from scratch anymore. You're just going to clone down a template and start with that. There's views, models, routes. And so we had some videos about all of this. And then one of your big homework was to build out MVC. And so we did have some videos that covered that. And your homework was to like build your own class on that. So make sure you didn't miss those videos and make sure you didn't miss doing that homework, because I think that's where a lot of folks got comfortable with MVC and the views, the models, the routes, and stuff like that. Yeah. Leon, how do you structure the routes path specifically when the project is getting complex? I just follow the MVC pattern. That's what I do. I have my models, I have my views, I have my controllers, and that's it. That's all I do. So it doesn't matter how complex my app gets, it's going to follow that pattern. Yeah. All right, folks, come on back. We'll get into all that. Don't worry. We're going to talk a lot about it. We'll get there. Yeah, no worries. Yeah. What do you build first with MVC? It depends. I like to spend a lot of time thinking about my database and the data that I'm going to care about, and I typically build out my models first and then everything else. But like I said, I'm not starting from scratch. I'm pulling up a template where all that stuff is already built out. Like everything's already there. Like I already have some views, my model, I have my controller. My user model is something I'm going to reuse over and over and over again. So I'm not ever coding any of that from scratch. Very, very rarely. And so I just start with a template. Like I would clone down our binary upload boom. I would delete the post model and start from there. That's it. because everything else is good to go. All right. And so I don't ever really start from scratch anymore. It's the only time I start from scratch is when I'm with y'all and we do a code from the beginning. Otherwise, I'm just using my template and starting from there. Now, I understand everything that's inside that template. I built it all from scratch multiple times. And so the reason why I keep giving you the homework that is comment everything is because you really do need to know what everything is inside those templates. Yeah. Why are there so many places for our files with this backend template? Because your applications get really complex. Like, think about how complex a modern web application can be. You don't want all of that in a singular file. We're gonna see an application that is in a singular file, and it'll just get too hectic over time. As you start to add more and more features, more and more functionality, more and more things you're keeping track of, to have that on one file, you just wouldn't be able to do it. Yeah, abstraction, encapsulation, yeah, sort of. Yeah. Is it okay for us to use the binary upload boom as our template? Yes, that's exactly what you're going to be using. I am going to basically clean that up. Well, it's actually cleaned up already. Cleaned it up a little bit, and then that's what you're going to be using kind of going forward. Cool. Let's talk about a modern web application. So come on back, folks. It's a pain to set up, but I got it after 5 hours. Cloudinary, hey, glad you got it set up. If you look at my binary upload boom code, it now has Cloudinary already set up for you. So others won't have to go through that pain. We got it going for you already. But glad you took the time to get through it. All right, chilled the music. Let's keep going, folks. Hey, welcome, Paco. If anything goes sideways, I'm joining you in Ecuador. No extradition. Glad you stopped by. All right. Let's go ahead and keep pushing. Let me pull up everything here. All right. So we're going to start talking about building. We're going to start talking about building web applications. We're going to build them using Express. All right. And we're going to build out our web API. Okay. We're going to build out our CRUD API. So I really love this article from Zell. If you have not read this article from Zell, please read this article. It's such a good article. They say their API is a set of rules that allow programs to talk to each other. The developer creates the API in the server and allows the client to talk to it. And that's what we're going to do. Right? We're going to build out our CRUD API. Pretty much any web application you can think of, the bulk of what that application is doing is really the same 4 things over and over again. We're making something, we're getting some things, we're changing some things, and we're removing some things. Like any application you can think of, we're really doing those same 4 things over and over again. And yeah, there's some other things that you can put on top of it, but the bulk of our web applications are really just doing those same 4 activities over and over and over and over again. And so we call those activities building out our CRUD API, short for creating, reading, updating, and deleting. And this makes sense because the web that we are using, the protocol that we are using, the thing that Express is sitting on top of is HTTP, or the Hypertext Transfer Protocol. That protocol recognizes 4 types of requests. It recognizes posts, gets, puts, and deletes. These are the 4 types of requests that HTTP understands. And so our applications, our web applications, are built around listening for those 4 types of requests. So we're listening for posts, we're listening for gets, we're listening for puts, and we're listening for deletes. Typically, when we hear a post, we're creating something. Like we're going to maybe add some things to our database. Maybe we're creating something like, if we're thinking about like Instagram, right? Maybe we are creating a new post for Instagram. That would be our creating. When we're on, say, our Instagram feed, that's when we're getting. Whenever we type in Instagram.com, we hit enter and we're taken to our feed. That's a get. We're asking for all those posts that were made, right? Whenever we like something, we're updating likes from 0 to 1, all right? And whenever we delete something, we're making a delete request, and we're going to remove that information probably from our database or something like that. So any of the major web applications that you use on a regular basis, all right, are really breaking down to just those 4 things. And so we can really understand how to do those 4 things and get really good at doing those 4 things, then we can build whatever it is that we want. Really, honestly, once we understand how to do those 4 things and do them well, everything else is just setting ourselves up so that our applications are a little bit more fancy or can do things in a repeatable way, right? So the first set of code we're going to look at is where we have all the stuff we need in one file, and we're doing the posting, the getting, putting, and deleting in one file. And then we're going to say, all right, as our applications get more intense, they're doing more and more things, we're going to need strategies to help separate out all the things that we're going to do. So don't worry about that for now. Let's look at CRUD and think through what we could do. All right. With our web applications, we're going to need to store stuff over time. All right. So we're going to use a database to help us store information over time. And the database we're going to use first is MongoDB. Chat, why do we use MongoDB to start? We're going to get to Postgres eventually, but why do we use MongoDB to start? Yeah. It's because if you know what objects are, you know how to use MongoDB. All MongoDB is collections of objects. That's all it is. So if you know what an object is, you can pretty much use MongoDB. Now there are some quirks, there are some differences, but since you already know objects, you can work with MongoDB really easily. So MongoDB is broken into collections, and we don't call them objects, we call them documents. So we have collections of documents. You can think of each collection as like its own folder that holds certain kind of data. So for the applications we build today, we're really only going to have 2 or 3 collections at most. We're going to typically have like a collection for all of our users, and we're going to have a collection for the things that we're storing. So if we're talking about Instagram, we're going to have a collection for our posts. If we are storing maybe to-do items, we're going to have a collection for our to-dos. And that's it. It's just collections. Our collections are groups of documents, and documents are just a fancy word for objects. So if you know what an object is, you know what properties and values on an object are, you can use MongoDB. All right. The other thing we're going to add to the mix here is our EJS. So if we're building web applications, the whole point is to respond with something that the user can see and interact with. We're still going to be sending HTML. The problem with just like regular HTML is that it's hard-coded. We can't pass values into it. And so what we're going to be using is our EJS so that we can dynamically generate HTML that we respond to the user with. We can send an HTML file that has their username in it. We can send an HTML file that has specific data that came from our database in it. And so that EJS just is like it's like a really fancy Mad Libs, right? You can plug in different pieces of data and out comes HTML. And then HTML is sent back to the user. So here is what a normal kind of like overview of what our applications are going to look like. Okay. Excuse me. Here's what our applications are going to look like. How do you determine what logic to write in your EJS? I think that's where I'm stuck. So you're not really, there's nothing that's too odd with the EJS. It's simply what do I want to plug in? That's all I think about when it comes to my EJS, is what am I trying to plug in here? Am I trying to plug in a singular variable, or am I trying to like loop through and create a bunch of something, right? And so those are the two decisions I make. Like, am I just doing something one off, or am I like trying to loop through and do a bunch of something? That's pretty much it. I'm either trying to create a bunch of something or trying to create one of something. And that kind of determines the EJS I'm going to write. We'll get there, though. We'll look at some of that today. All right. So here is what a normal application might look like. We are going to have our client, and that client, right? That client is going to have a browser, and in that browser, somebody might enter a URL. When somebody enters in that URL and they hit enter, what type of request did they just make, chat? When somebody types in a URL and hits enter, what type of request did they make? Yeah, it's trying to make a GET. Slay said, are you only allowed to have one app.delete? No. You can have as many delete requests as you want, but they all have to have different actions. And the actions are how you distinguish between different forms. Yeah, we're trying to make a GET. So whenever we hit enter, we've made a GET request to our server. Now, our server is going to have some code running on it. Our server is going to have some code running on it. That code is going to be able to hear the GET request. Right? Let's do something else. What happens typically if somebody fills out a form and submits that form? What type of request is that typically going to make to our server? It could be a GET, but most of the time it's going to be a post, right? So there's some code running on our server that's going to be able to hear that post. Cool. Maybe we had some client-side JavaScript that made a fetch and it wanted to update. Maybe we're using some client-side JavaScript to make a like. We're going to see a different way to do it later on today. But maybe we're using some client-side JavaScript, right? Maybe we're using some client-side JavaScript to update our likes from 0 to 1. And when we use that client-side JavaScript to make that fetch request, what type of request have we made to our server? Yeah. And so there's going to be some code running on our server that can hear that put. Beautiful. And last, maybe we have some other client-side JavaScript. Maybe we click that trash can. That makes a fetch that has a delete it's a delete request. And once again, we're making another request. And once again, there's some code running on our server that can hear that request. Cool. That code that's running on our server that can hear these different kinds of requests, we call our what? What do we call that code that can hear all those different kinds of requests? What do we call that? Malenko got it first. Yeah. Blah, you're back. Glad to see it. Hope it went well. That's our API. That's our API. Sorry, cat. I apologize. That's our API. All right. All our API is the code that's running on our server that's listening for these requests and then knows what to do with that request. If we're making a GET, what do we then go on and do? If we're making a post, what do we then go on and do? If we go make a put, what do we then go and do? If we hear a delete, what do we then go and do? Right? That code that hears those requests and figures out what to do, we call that our CRUD API, right? It's listening for the creating, the reading, the updating, the deleting. It's listening for those gets, the posts, the puts, the deletes, right? That code that's sitting there listening and figures out how to respond, that's our API. And when we're building out these very simple web applications, we're going to call that our CRUD API. Okay. Now, once it hears that request, it can do a lot. We can code it to do whatever we want. Sometimes we're going to go and talk to our database and get some stuff from the database. Sometimes we're just going to respond with a file and send that file back. Sometimes we have to go to our database, get some information, plug it into an EJS file that spits out HTML, and then respond with that HTML. Sometimes we hear a request and we just put a new document into our collection. Sometimes we hear a request and we go and edit one of the documents inside of our collection. Sometimes we hear a request and we go and we delete something from our collection, right? And so our API is the code that's sitting there, listening for all these requests, and then we get to write what it does once it hears those requests. That's it. Once you know how to do that, it's all gravy. It's all just like making sure your code is cleaner, making sure it's more maintainable. But really, we're just doing those same 4 things over and over and over again. Yes, we're gonna add some accoutrements here. We're gonna add some authentication. We're gonna add some other things that make our lives a little bit easier. But the idea of just getting, posting, putting in delete, that's not going to change. It's just kind of what we do. Exactly, Tony. It's like what we do in that process that gets a little bit more complex, but it's still at the end of the day just doing those 4 simple operations. Cool. So we had some code that was a wrap name generator. So let me go ahead and pull that code up real quick. So here is our wrap name generator. I am going to go ahead and start this server. All this code is, I don't know why it's so far up. All this code is on our Discord. So if you need this code, it's on our Discord, !Discord. In today's follow along materials section, you'll find all the starter code that we're using. And so if you want the code, join our Discord, grab it from the follow along materials channel. All right, so here is my wrap names express. I made a few changes here that have been updated, but that's about it. Make sure this is the right one, actually. Yeah, it's the right one. Cool. All right, so let me go ahead and start this server. The way I'm going to start this server is just by saying node and then server.js. So node server.js. You can see that my server is now running on port 2021 and I am connected to the wrap database. All right. I'm running on server 2021 and I'm connected to the wrap database. Cool. Let's go ahead and look on port 2021 and see what's happening here. All right. So I got a list of current wrappers. Okay, got a list of current wrappers here. And what we're seeing is we have their stage name and then their birth name. And so this is a full stack web application. And that wasn't the console, that was the terminal. The console only exists inside the browser. That terminal is how I was running my node code. All right, so I have an application here We're on port 2121 as a sign of respect. And we can go ahead and do a lot of stuff. So if I refresh, you can see all of the wrappers that are here. And the cool thing is that each of these wrappers are saved in my Mongo database, right? Each one of them is a document in my wrappers collection. So I can refresh. None of this is hard coded. And so when I refresh, you see all the wrappers. I have the ability to delete a wrapper. Let's go ahead and delete Polo G by clicking on the trash can. And I have the ability to add a wrapper. So let's go ahead and put back Polo G. And let's grab their birth name. Thank you, Wikipedia. Shout out Wikipedia. Let's go back to the application. Cool. I can add a new wrapper. Right. Now, Polo G is the best young rapper out there right now. Crushing the game. And we can do one other thing, which is we can like the number of we can like the wrapper. Right. And so the cool thing is I have the ability to do some very simple things. I can add a wrapper. I can update the number of legs for that wrapper. I can delete the wrapper, and I can refresh the page. So let's go ahead and step back and think through the CRUD functionality that I have here. So what are the different types? What is a way that I can make a create request here? How am I making my create request? What am I doing? What am I doing to make my create request here? It is a post, but what specifically am I doing? Yeah, it's when I add a wrapper. It's when I fill out that form. So what I'm going to do is on my client side, I have a form. And when I fill out that form and I click submit, I am making what type of request to my server, chat? What type of request am I making when I fill out that form and hit submit? It's a post. And the reason I know it's a post is because I'm trying to create a wrapper. I'm trying to add a wrapper. I'm trying to create something. I'm trying to add it to my wrappers collection. Right? Trying to create a wrappers collection here. And so that post request is going to make it to my server. And my server is going to be able to hear that request because it has some code running on it. The code that hears that request, the code that's able to hear that post request, we call what do we call that code? The code that can hear that post request, what do we call it? Yeah. We have our API, which is set up to hear that request. And our API says, all right, I hear you. I hear that you're trying to make a post request. And so when I hear a post request, what do I wind up doing? Whenever there's a post request, chat, what do I wind up doing when I hear that post request? Like, what do I do? What do I do when I hear that post request? Yeah, Jesse. I'm going to take whatever that data is, and I'm going to add that data to our database. I'm going to add that data to our database. All right, so let's go ahead and say, all right, we're going to add to database. Cool. We're going to make a new document. That document's going to be added to a collection in our MongoDB. And then once I am done, what do I do? I've added it to the database. Now what do I do? I've added that data to our database. What's the last thing I do? We'll get there, Brian. Yeah, I respond to the browser and I say, hey, you should probably go back to the main page. Basically, we're telling it to redirect and refresh. Because as soon as that browser refreshes, what type of request have we made? So we're back at the client side. The browser has just refreshed. What type of request is our browser making? Yeah, it's making a GET. And so our server has some code running on it that can hear that GET request. What's the code running on our server that can hear that GET request? What do we call that code? It's our API. So our API has some code that's running that can hear that request. So our code hears that GET request. What does our code do once it hears the GET request, chat? What does our code do? Just heard the GET request. What does it do? I see. There's a lot of different steps here. They're mostly all right, but we got to do it in order. Our code is going to be in order. So we heard the GET request. That means we want to get all the. We just refreshed the page. We have to get all the wrappers. Okay. So the first thing we're going to do is get wrappers from the database. So we're going to go to our Mongo database. There's going to be a collection of wrappers. Right now, we know that there are three documents in my wrappers collection. Chat, how do I know that there are 3 wrappers in my Mongo database collection here? How do I know that there are 3 wrappers? Or sorry, how do I know there are 3 documents? Yes, I messed it up. How do I know there are 3 documents in that collection? There were 2 and then I added 1. Exactly. Because I'm getting 3 wrappers back. I know that there are 3 documents in my collection because there's a document for each wrapper. And we saw 3 wrappers in the DOM, so we know there are 3 documents in that collection. Cool. So we heard the GET request. We went and we got all the documents from our Mongo database. So now we have, all right, we have all of those wrappers. We have all that data. We have those 3 wrappers. We have all this data. Chat, what are we going to do with this data now that we have it back from the database? That ain't a thumb 3. That's an American 3. Yes, I don't know why. This sucks. Don't ever do this 3. Do this 3. All right? Do the non-American 3. Indifferent. Hey, thank you for the 7 months. Let's go. First tree. Hope you're doing well. Thank you for stopping by. You're a really good teacher. Thanks for streaming. Hey, I appreciate that. The great. Hope you're doing well. Thanks for stopping by. All right. We got all this data. We want to send it back. Can we just send that data directly to the browser? Can we just, we have the data from the database. Can we just send it back? No. I'm going to say it's Ezekiel. Ezekiel, hey, thank you for the sub. I appreciate you. Thank you for being here. Nah. What is the browser expecting for us to come back? What is the client expecting to come back from our server? It's expecting HTML. Our data right now is not in HTML format, so we have to format it as HTML before we respond. And Different said, I have a puppy that I'm trying to train in like a week. While their owner is in the hospital, I'll be back after this week. Hey, that's wild. I hope that goes well and excited to have you back when you're done. I know things have been wild. You got the new job, now a puppy. Whew. What is it expecting right now for us to come back? Somebody said, that's not true. You can send anything you want. True, you can send anything you want. But what is our application expecting right now? What is it expecting to come back? Is it expecting just raw data, or is it expecting JSON, or is it expecting HTML? Is it a promise? Yeah, it's expecting some HTML. So we got all this data from our database, right? We got all this data from our database. How can we take that data, plug it into something, and get HTML? What are we going to use, chat? Yeah, we're going to use EJS. So we're going to take that data and we're going to plug it into our EJS. And our EJS is going to spit out what, chat? One more time. What is our EJS going to spit out? Yeah, it's going to spit out HTML. And what do we do with that HTML, chat? Now we have the HTML. Cross, don't you start. Don't you start. It's going to respond with it. Yeah, it's going to serve it up. It's going to respond with it. And so we're going to respond with it back to the browser. All right, we're going to send it back to the client. So that was a lot of steps. We started out with just submitting a form. That form made a post. That post, I love that. That's going to be our new meme. It's going to be our new meme. I love it. That post created a new document in our database. Right? Create a new document in our database. And then when we were done with the post, we said refresh the page. So the page refreshed. As the page refreshed, we made a GET request. Like it heard that refresh, made a GET request. With the GET request, I heard that I needed to go and get the data from the database. Once I had that data, the browser wasn't expecting me just to send raw data back. So I had to take that data, I plugged it into my EJS, and my EJS spit out HTML, and I responded with that HTML. Gotta cook it first. Raw makes the client sick. Cool. Now, I know, especially if you're coming to this as your first pass, I know that this is way difficult to follow all these things that are going on. But if you can understand the get, the post, the put, and delete, you can pretty much understand everything else that's going on. All we're doing is adding on top of this core idea to make things a little bit easier to follow along. Okay, that's all we're doing. So we got our post, we got our get. Let's talk about the last two. All right, let's talk about the last two. And we're going to start looking at the actual code, seeing these gets, these posts, these puts, these deletes. All right. Cool. The what's making it easier, like the new stuff blah? No. Where is the EJS located? Well, we're going to wind up having individual files for each of our views, right? For each of our views. And that's where the EJS template sits. We're going to use those templates and plug stuff into those templates. Yeah. And I agree with out of time. If you have not read through the Zell article on CRUD, you're doing yourself a huge disservice. All this stuff should not be, like, when we're live, this should not be your first time seeing this stuff, right? Because it does take multiple times seeing it for it to click. That's why the reading's so important before class. Digital Fendi, what's up? How you doing? Cool. That one's definitely on our Follow Along Materials channel. It's in there a couple of times. Alrighty. Where are we at time-wise? Let's see. All right, let's talk about this put and this delete, and then we'll take a break. When we come back from the break, we'll actually look at the code, see what's happening, put all the pieces together. I'm cool up to here. The next bit gets me. Yeah, the jump is real, but we're gonna break it down today. We're gonna break it all down. We're gonna try to. All right. So if we look at this application, we understand that submitting the form was the post, refreshing the page was a get. What are some other types of requests that we can make here, chat? First try. What are some other requests that we can make here? We can make a put and we can make a delete. Right now, how are we handling our puts and our deletes? How does someone make a put request here? How does someone make a put here? They click on the like. Yeah. So right now, this code is using client-side JavaScript to make a fetch that the server then hears. When we get to our social network, we'll be using method override, which means that we don't really need client-side JavaScript to do this anymore. I like to show both ways because not every company uses method override. And I think it's actually way harder to understand what's happening without the method override. And so I would hate for you to show up on the job, have no idea how to do the client-side way, even though method override is way, way, way easier. So let's go ahead and trigger our put by clicking on this thumbs up. All right, so I click that thumbs up. Funny. When I click that thumbs up, I had a click event. That click event heard the click and made a fetch to my server. All right. That click event made a fetch to my server. That fetch is going to use what kind of method? I click the thumbs up. What type of request am I sending to my server? Click thumbs up. What type of request am I sending? Exactly. It's going to be a put. I want to update that number. I want it to go from, what was it? I want it to go from 1 to 2. All right. So I'm making a put to my server. On my server, there is some code that can hear that put request. The code that can hear my put request, we call that our what? Our API. Exactly. And that API hears the put. And once it hears the put, what are we going to do? What does our server have to do? First thing, here's the put. What does it have to do? Yeah. Here you go, Imran. You're on fire today. We have to go to our database. And we have to find the specific wrapper's document. And once we find that document, we have to change likes from 1 to 2. Right? We have to change those likes from 1 to 2. Cool. So we heard the put. We went into our database. We had a database. Inside that database was a document. And inside that document, there was a likes that was 1. And I changed it to 2. Cool. So I heard the put. I went to my database. I found that wrapper's specific document. And I changed that document from 1 to 2. Now, what's the next step? What's the last thing I have to do here? What's the last thing I got to do here? I appreciate that, Imran. Refresh the page. The way we have it set up right now, we just refresh the page. So we're gonna do we're just gonna do a redirect. We're gonna redirect it back to that main page. Because as soon as I redirect it back to the main page, what am I forcing to happen? I'm forcing the page to refresh. And as soon as I force the page to refresh, what happens? I refresh the page. Now that forces a get. Right? I reload the page. Forces a get. Now the get's going to do the same thing we talked about. It's going to go to the database, get all of the new data. And that new data, the likes are no longer 1. It's now 2. Could you all hear that? Did you hear my stomach? That was pretty wild. I don't know if the mic's that good, but I heard it. Okay, cool. That's good. It's good to know that my bodily functions are kept to myself. It's the coffee, yeah. And the Diet Coke and the wildness. Dominoes, are you listening? All right, so we force the refresh, which makes a new get. All right. What's the last thing? What's the last thing we have to do here? We handled the get, the post, the put. What's the last thing? Yeah. We got the delete. All right, let's delete Polo G again. I'm going to click the trash can. All right, Polo G is gone. Cool. Let's think about it. On the client side, there was a click event. That click event actually made another fetch. And this time, the request is a what? The request is a what? Yeah. The request is a delete. Nice. So there's some code running on my server that can hear the delete. What do we call that code that's running on the server that can hear the delete? API. Nice. The API hears that delete. Here's that delete. And let's go ahead and say, all right, so here's the delete. What do we do when we hear the delete? What's the first thing we need to do? BB Tone, hey, thank you for the gifted sub. I appreciate that. Thank you for being here. Yeah, we gotta go to the database. Once we go to the database, what are we gonna do? We're gonna find that document. Nice. Once we find that document, what are we gonna do? We found the document. What are we gonna do with that document? We found it. What are we gonna do with it? Delete it. Cool. We deleted that document. And once we're done deleting the document, what are we going to do? Tell the page to refresh. Cool. Page refreshes. After it refreshes, it makes what kind of request? What type of request does it make? Page refresh, what type of request does it make? Makes a get. Get does its business again. However, this time, when it goes and gets the documents, are there 3 documents still? Are there 3 documents still? No. So what we could say is it went to go get and it got, right? Because now there's only 2. right? It's only two. And so we send just those two. Sorry if you're from the UK. I'll do this way. Just two, fuck you, fuck you, fuck you. It's sent back two this time. And that's why we only see two wrappers here. Right? Because we deleted the other one. There's nothing else in there. There's only two documents left. Cool. All right. Let's see where we at time wise. All right. What we're gonna do is we're gonna take a break. When we come back from break, right? When we come back from break, we're gonna actually start looking at this code and trying to understand, like, all right, the get, the post, the put, delete. How does all that work? How do all these things come together? So let's go ahead and take a break. Gonna put 5 minutes on the clock here. Y'all funny. I'm gonna put some music on for you. Please take a break. We've been going for a while now. Y'all can use your channel points to increase the breaks. I ain't on me. You go ahead and increase the breaks. That's on you. Ain't nobody spending their channel points. Y'all want on those YOLOs? That's on you. All right, so we're gonna go ahead and take 5 minutes. Let's Thank you, Imran. We gotta change this to 7 minutes. Cool. Imran's for the people. I agree. All right, let's go ahead and change it. We got 7 minutes on the clock. Please take your break. Please get up. Please hydrate. Please take care of yourself. This is a long time for you to be sitting, exercising your brain. All right. So let's go ahead, set the timer here. Alrighty, folks. If you're able to get up, stretch, fly, what's going on? Hope you're doing well. All right, let's go ahead. I'm going to run some ads here so new folks don't have to sit through the ads when they join us. Also, you're going to take a break. And I'll be Burb too. Burb. 6 minutes, 30 seconds. See you in a second. Please, 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 please take a break. Go hydrate. And that's when I found all the gold. And I was like, what am I going to do with all this gold? So I just left it there. I was like, well, if people follow the exact instructions that I just gave them, they can come back and find the gold and it'll be all theirs. So that's what I did. Yeah. Cool. What's going on, everybody? Hope you had a good break. Come on back. Come on back if you're still not with us. The real treasure was the friendship all along. Good thing I can read lips. Let's go. Did I miss anything during break? Trying to be a self-taught developer and have a job by the end of the year. Well, boy, have you found the right place. We're already up 7 jobs, over $60,000 brought in freelancing. I'm up like what? Like 30 jobs already on the year, not including just 100 devs. So we got you. Alrighty, folks, come on back. Alrighty, let me go ahead and chill the music here. Hope you all had a good break. Hope you're able to chill for a bit. Let's go ahead and chill the music on this end. Cool. I'm making pancakes. Let's go. If this goes long enough, this turns into a cooking stream. That's what happens. We just wind up live streaming. Like, I'm just gonna teach JavaScript while I'm cooking. That'd be hilarious. That's actually not a bad idea. He's making a call stack. Oh, that's good. That's good. I don't call them pancakes. I call them call stacks. Let's go. Quick question. When is coffee too much coffee? I'll let you know. I'm about to find out. I'm about to find out. I fucked around and now I'm about to find out. All right. Not gonna lie, I got a little loopy there for a bit. It was like, caffeine rush. I don't know what it was, but there's no such thing. All right, let's get into it. We got a lot more to go, folks. Got a lot more to go. So we talked about the gets, the posts, the puts, the deletes. We talked through like what they're actually doing. And are we talking to the database? Are we putting stuff into EJS? And so let's go ahead and start looking through how we built this out. So here is our original code. Now this is already running, so I'm gonna close out the terminal here. But all of this is already running, and this was kind of our first run through building out a web application. A lot of the stuff that we see here is not the way we're going to do it going in the future, but it was a way for us to kind of simply get some ideas and see how it was working without kind of abstracting out everything, right? We wind up like putting stuff into their own files. We wind up putting stuff into their own folders, and we start to like make stuff a little bit more maintainable through abstraction, right? But right now we just threw everything into this server.js file and called it a day, right? So if you're new and you haven't been following along with us and you haven't seen the progression, this isn't how we're going to do stuff going into the future. It was just kind of a way for us to see the basics and not add any complexity, right? So we're not using things like Mongoose here. We're not separating out the connection to our database into its own file. We're not doing a lot of stuff that we're going to do in the future, just for the sake of having everything nice and neat together. Okay. So will companies ever do it like this? Oh yeah, for sure. You'll find lots of companies that do it like this. But if you have a pretty big web application, this gets unruly really quickly. I've been hired as a freelancer to come in and fix somebody's code that had it all in one file. It was a hot mess, but that's what I got paid to fix. And so I've seen it. I hope it's not common, but I have seen it. Shouldn't we be using model view controller? Yes, we should be. Cool. All right, so let's look at this and see what's happening. I want to kind of skip some of this stuff first. This is all kind of setup. All this is setting up our node server. It's connecting to our database. Let's skip all that for right now, and let's just look at this code right here. Line 23 through 81. Lines 23 through 81, we would consider our what? What would we consider this, chat? This would be our what? Got some raisins. My power drops. Good old power drops. Yeah, it'll be our API. Have I ever eaten on stream before? I don't think so. This might be a first here, folks. You just witnessed 100 devs history. I just ate a raisin. I had some cashews earlier. That sounds wonderful. All right, so this would be our API. This would be our API, exactly. This would be our API. This is the code that is listening for those requests and does all the stuff we needed to do to respond. Okay. I am using something that actually Indifferent recommended called Prettier. That's making my code look pretty. So it might be a little bit different than we've seen before. Things are kind of spaced out better. Things are on their own lines better. And so I don't recommend using Prettier out the gate. But once you kind of know what you're doing, Prettier can make your code look better, more maintainable. Because if everyone at your organization is using Prettier, then the code winds up looking the same. And so that's why I'm using it here. I want you all, if you've been here with us from the beginning, now it's time to start using Prettier so that your code looks prettier and more maintainable. What you're going to notice is like, Leon, whoa, you're doing a lot of stuff that you don't normally do here. And it's because I'm not doing it, Prettier is doing it. Hence, like the semicolons and stuff like that. So I didn't do it, Prettier did it. Don't come to me about that. I didn't do that. That's Prettier's decision. So Prettier added all those things. So yeah, it's going to make it look prettier. It's going to make it a little bit more maintainable across developers because you will all be kind of, once you save your code, Prettier automatically does all the indentation and stuff like that. Cool. All right, so here's our API. Let's do the get first. So let me go ahead and refresh the page. That was a get request, right? That was a get request. That was made to our server. And my code right here is going to handle that GET request. Yeah, I know that you can remove the semicolons in Prettier. I'm going to keep it standard so that way I'm getting like the cross developer benefit. That's all. Yeah. Alrighty. So here is all the code that's going to handle that GET request. And you're going to notice that I'm saying app.get. App is really just Express, right? So you can see up here, I have required Express. So I required that module called Express. And I've told it to run and stored it in app. So wherever I see app, right? Wherever I see app, right? Wherever I see app, it's really just Express. Because remember, Express is handling all of the wonderful HTTP stuff, like all the stuff that enables us to listen to requests and generate response. Express is going to handle all of that, so we don't have to worry about it. We just use app. So I'm able to do app.get. And you see this / chat. What does this / what does this / mean? What does that mean when I see that in my app.get? Yeah, it means root. It means that I'm on the main page. Like if I was to go to a different page, like we saw in the other app, other page, that would be a request to other page. It would not be a request to root. So if I hit localhost 2121 / other page, this GET request would not fire. This is only for the main page, the root. Cool. So it heard that there was a GET request on that root, on the main page. And once it heard the request, it fired my what? What is this right here? Yeah, it fired my callback. And the beautiful thing about this callback, because we're dealing with Express, this callback has two beautiful parameters. It has request and it has response. Every single thing about that request is now in this request object. And I can use this response to respond. So let's actually do it. Let me console log this real quick. So let's console log request. What the heck? Oh. What? Hold on. There we go. So I have the keyboard I'm using is the Kinesis Advantage 2. Hold on. Can I get this on screen? You can see the tip of it. So that's the keyboard I'm using. And so there's a button on this keyboard that switches the letters to numbers. So it's easier to like have like a number pad. And so I forgot that I had that on. And so as I was trying to type out the word request, it kept giving me numbers. All right. So let's go ahead and save this. And let's go ahead and refresh the page. And I'm going to bring back up my terminal. So let's go ahead and let's restart our server real quick. Node server.js. And let's refresh the page. And if we come back to our terminal, look at this request that we console logged. Right? Look at this. So much information is on this request. This is being sent with every single request. You can see all the stuff about the client that made the request. All this data is here. And so, do we have to understand how to work with all this data? Do we have to understand that? What's handling working with all that data for us? What's doing all that heavy lifting for us through all of this data? What's handling it? Loco got it. Yeah. It's Express. Express is doing all that heavy lifting for us. We don't have to worry about any of that stuff. Express is going to handle all of that for us. Cool. So let's get rid of this console log. We heard a GET request, right? We heard a GET request. And the first thing we're going to do is we're going to talk to our database, right? So DB is holding our database. If we come up here, we're going to see some other things that we got to work through. So we know in the future we're going to use Mongoose, but for right now, I'm just using raw MongoDB and the client that we can use with it. All Mongo client is going to enable me to do is to talk to my database. Right here, lines 7 through 16, this is all the code that I need to connect to my database, right? I'm setting up a global variable called DB, and in the end, the connection to my database is going to be stored in that variable. Next, I am pulling in the connection string for my database that came from Mongo Atlas. I'll explain that in a second if you're new. And I'm also passing in the name of my database. With all of this information, I can connect to my database. I can say, hey, connect to this string. right? That's the connection to my database. And once you have connected, store that connection in the variable DB. So wherever I see DB, that is the connection to my database. Fox, thank you for the hydration. Cheers to you. Trying to get that caffeine overload. There we go. Diet Coke is what's for dinner. It's in the game. All right. So yeah, this is fancy, but all this code is really, right? It's really just so I can connect to my database. That's all this is. We'll do it differently in the future, but all this is just connecting me to my database. And I'm going to store that connection in the DB variable. There's one thing here that we're going to see come up over and over again. And that's this weird process.env.db string. What the heck is that, chat? What the heck is that? Process.env.db string. What is that? Yeah, it's an environment variable. Shh, it's a secret. Yeah, it's a secret. So eventually this code all got pushed, right? This code all got pushed to GitHub. There are a lot of things that I don't want on GitHub. Things that if people had, they could maybe like start using to build out their own applications, but I would be on the hook for paying for them, right? So one of the common things that you see people do is that instead of pushing all of your secrets up to GitHub, you can have a file that does not get pushed up to GitHub. And so this file is our env file, our environments file. And what you're seeing here is that I have required an .env module, and all env is that file that I'm going to be using. So I required .env. It's a package that makes working with our environment files easy and doable. And once I require that .env, I can start using these environment files throughout my Node application. So I'm going to show you what my env file looks like, even though I would never push it to GitHub. So if I go to my git ignore, you can see that I have my node modules folder here. And if I wanted to, I could go ahead and add .env. And once I add .env to my git ignore, right, I would never, like, once I add .env to my git ignore, it'll never push it. Right? Now, James put up a really good thing here. Since I've already pushed this to GitHub, right? Since I've already pushed this to GitHub, even if I add .env now and push, all of my secrets are still in my Git history. So it's not something you can do it afterwards. It's something you have to do from the beginning. Otherwise, your secrets are still there just in the Git history, not in like the actual repo. But if you look through the history, you'll be able to find them. So I make sure that in my git ignore, that my node modules aren't there because that's just a massive folder. And I make sure that my .env file is in there, right? Otherwise, when I push, all my secrets get pushed to GitHub. Now, for this one, I pushed it anyway, just so you could see it. And if you take a look at my env file, you're going to see it just has one thing. It has this DNB string variable and then the link to my Mongo database, right? I need this link to my Mongo database or else I don't know which database to connect to, right? So we're using Mongo Atlas. Mongo Atlas hosts our Mongo databases for us. So we don't have to run them locally. All of our databases are now in the cloud. Chat, why do we start off? Why do you think it makes sense to start off using a hosted Mongo instead of running it locally? especially early on. Why do we run it hosted? It is free, less drama, exactly. We're not worried about setting up Mongo. Setting up Mongo and running it locally can actually be a pain in the butt for a lot of folks that are new. You can connect from anywhere. Yeah. And what are we going to start doing more and more? We're going to start working more and more on with what? In what? In teams, exactly. And so if we're going to start working more and more on teams, we want to have our databases hosted so that we can all work off of the same database, right? If we all want to work off the same database, it makes sense to have it hosted and not local. Saves a lot of headaches setting stuff up, and also makes it way easier for us to work in a team early on without having to run it locally. So that's why we use Mongo Atlas. It's just easy to host it. It gets it up and running, and all you need is that link that it gives you. And once you have that link, you plug it in, and you can connect to this hosted version of your Mongo database. Cool. Let's go back to our server.js. So we are fully connected to our database. We pulled in that Mongo URI from our env file, and we wind up using it here to connect to our Mongo database. The cool thing is, if I was to push this code to GitHub, you would see this file, but you wouldn't know what my connection to MongoDB was. You couldn't take that link and use it against me, right? And use it against me because I would never have pushed my environment variables to GitHub. So that's why we have like these env files. It enables us to have our secrets, but not push them to GitHub or wherever we're storing our code. Does that make sense? Any questions about that before we move on? Everyone in the team will have to create their own Mongo string. Each would need one. You could share one though. If you all wanted to share the same database, you would just share that string with each other. Yeah. Is there a way to host the database on my own system to avoid using Atlas? Absolutely. You can run Mongo locally as much as you want. Yeah. Pain in the butt to get set up, but once you do, you can do it if you want. So I can always add an env file in the git ignore, even if I already pushed to GitHub? No. If you've pushed to GitHub, your secrets are on GitHub. Even if you add the env file, and it's not like on the repo that people are seeing, those things are still in your history. And so somebody that knows what they're doing could write a script that runs through your history to find it. So even though it's not like visible right now in the repo, it's still in your Git history and they can still find it. So it's something you have to set up from the beginning. Maybe a silly question, but if we clone a repo missing the node modules file or folder, how do we best get the folder locally? You just do npm install. So as long as the packages you need, not a silly question at all, as long as the packages you need are inside of your package.json, right? And we're going to do something from scratch where we see all of this. But as long as your packages are here in the package.json, when somebody does npm install, it'll install all of these packages for them. So we put the node modules in our git ignore because it's a massive file. Hold on, let's look at this. Let's look at our node modules folder. Look at all the crap that's in here. Look at all this. For days, look at all these stuff in here. And they're big files too. Look how much room that takes up. So we put that in our git ignore, so we're not like pushing that to GitHub and waiting an hour for it to push up to GitHub, right? So we would delete the repo and repush then? Yes. You would definitely want to get rid of the repo if it's in your history. When you try to get to localhost, I get cannot read property collection of undefined. It means you're not connecting to your database. That probably means that you didn't enter in your own string. Or if my string is already there, like if you pulled down for git, and you tried using my string, you got gat. How did you get got though? Chat, help them out. They couldn't connect to my, even though I shared my database string, they couldn't connect. How'd they get got? This is a good got though. This is a good one. C2S. Yeah, I did not whitelist my IP address. And so since my IP address is not whitelisted, only somebody on my IP address can connect to this database. Yeah. Hey, Kazan, I appreciate that. Yeah, so only right now, only if you have my IP address can you connect to this database. Technically, since I'm behind a VPN, anyone that's using my same VPN server could connect to my database at the moment. Yeah. So if you want it to work on your end, you should create your own Mongo collection, like your own Mongo cluster. They'll give you the URL and then you plug it in. So that's what we would do. We'll see that in a second. Let's get back to what we were doing though. So now we're connected to our database. That connection to our database is stored in DB. Remember, this is just how we're doing it for right now. In our future code, we won't do it this way. This is kind of the old way. So now our connection is stored in DB. And here we have our API. Cool. It's all in one file. We're not doing any MVC structure or anything like that. Just all in one file. All right. So we went to our application. We refreshed. When we refresh chat, all right? When we refresh, what type of request did we make? What type of request did we make, chat? Yeah, we made a GET request. Cool, we made a GET request. And so let's go ahead and look at our API here. We have a GET request. It's on the root route. We're looking good. We have our nice little request and response there inside of our callback. And the first thing we do is we go to the database. We find the collection called wrappers. All right. We go to our database. We find the collection wrappers. And we find all of the documents inside of that collection. Once we found all the documents in that collection, we sort them based on their number of likes, which is pretty cool. It's a little thing I added. You don't have to have that. You could just find them all. But I thought it'd be pretty cool to sort them based on their number of likes. And then once I found all the documents, they're sorted based on the number of likes, I put them into an array. Chat, why do I need to take all these documents and put them into an array? Why do I need to do that? Why do I need to do that? Why do I need to take all these documents and put them into an array? Yeah, it's an array is a good data structure to hold a bunch of stuff, right? So I want to be able to hold all of these documents that came back from MongoDB. So the wonderful, right, data structure I could use right now, right, is I could have them all in this lovely array, right? Now that I have them in an array, I can pass that array through to my EJS. So we went to the database. We found our wrappers collection, right? Once we found the wrappers collection, we went and found all the documents inside of that collection. We made sure that they were sorted based on the number of likes. We then passed all of those documents into an array. And now wherever I see data, data is really my what, chat? Data is holding my what? Data is holding my what? Yeah, it's holding my array. So data is holding my array. And now that I have this array, right? I have this array that has all of these wrapper objects in it. We know there's 3 of them in there, right? Has all these wrapper objects in it. What am I doing with this array of objects? What do I do with them? So find doesn't return all the wrappers in an array by default? No, it does not. When we're using Mongoose, Mongoose does return an array by default, but we're not using Mongoose here. Yeah, we're going to pass this array into our EJS. Cool. So I got this array of wrappers, and I'm going to pass them into my EJS. Let's look at this Mongo collection real quick. Let's log in. I don't know why it kicks me out so frequently. Let's find our wrap project. What? I'm just looking at the Mongo string I used here. YJ93. So make sure this is the right one. Nope, this is the wrong one. I see it's not the YJ. Nope, not the right one. There we go. So this is the right one. Labeled backend review. Who would have guessed it? So I'm back in my Mongo Atlas. I found the right project. I'm going to look at my collections. And you can see I have this wrap project, and I have a wrappers collection. So inside my wrappers collection, you can see how many documents, chat. How many documents are in my wrappers collection? There are 2. Yep, there are 2 documents in my wrappers collection. And so I'm going to pass an array that has 2 objects in it. So whenever we're dealing with kind of this Mongo, we know the beauty of Mongo is that it's really just kind of like objects that we're dealing with. And so what we're going to wind up doing is I'm going to wind up passing in an array that has both of those objects in it. So wherever I look in my EJS and I see the word info, whenever I look in my EJS and I see the word info, what am I really looking at? What is info holding? What is info holding when I look at my EJS? Yeah, it's holding that array. Yep. It's holding that array of the documents I got back from MongoDB. Exactly. Cool. So let's go ahead and look at our EJS, and let's keep an eye out for info. So I only have one EJS file here because I only have one thing that, like one page that we're dealing with. So let's look at our index.ejs here. And if we look, I have this lovely for loop. Right? So info could be named anything exactly. I can call it whatever the heck I want. It could be called Rainbow Unicorn Surprise or Rainbow Unicorn Attack, which is the OP game. Love that game. So here we go. We have this lovely for loop. And so the cool thing about EJS is that most of the time our EJS looks exactly like our what, chat? Most of the time our EJS looks exactly like our what? What does it look like? Yeah, it looks exactly like our HTML most of the time. But the cool thing about EJS is that we can pass in JavaScript. So what we have here is we have a for loop, and I have the ability to plug individual values in. So whenever I want to start a code block or a block of JavaScript, I have this lovely syntax here. This left caret modulus, and then the modulus right caret on the right. That opens up this line of code. Down here, I do the same thing. It's another line of code. All right. Like a prop in React. Yeah, Bruno, kind of the same thing. And I'm closing my for loop down here. Gabby, hey, thank you for the 6 months. Hope you're doing well. Thank you for being here. Cool. All right. So we got a lovely for loop here. All right. Friendly geeks, we're all new folks here. We know that there are better ways to do it. We're of course not going to start with those. So here we have a lovely for loop. All right. This is meant to be a review. We have a lovely for loop. And inside that for loop, what are we iterating through? But what about Express? What do we got here? What do we have? What are we iterating through, chat? What are we moving through? We have a for loop that's moving through what? Yeah, Wolfpack, we're moving through the array of wrappers. Right? We're moving through the array of wrappers. Right? We're moving through the array of wrappers. And as we move through the array of wrappers, we're actually building out our individual LIs. All right. We're actually going through our we're building out our lovely individual LIs. So if we look at our application, right now we have Sir Savage and we have Chance the Rapper. Right? We have them both in here. And so how many LIs did this for loop wind up creating? Yeah, we wound up creating 2 LIs inside this code. What are the percentage symbols doing in the code, Alex? What they're doing is that they're enabling us to plug in JavaScript here. So if we didn't have that caret and the percent sign, EJS wouldn't know if we were trying to write HTML or what we were trying to write. And so that caret and modulus sign enables us to plug in JavaScript, right? So the beautiful thing about EJS is that we don't have to hard code everything. We can plug stuff in. It's a template, right? We can plug stuff into this template. And this syntax helps us to plug stuff in to that template. Yeah, it's similar, Alex, exactly. Right? So if we just do the caret modulus, that enables us to plug in just regular old JavaScript. And wherever you see the caret modulus equal sign, you can think of that as just plugging in like a variable, like one thing, right? So here we have our block of code that's opening, and we have the individual piece of code that we're plugging in. And so we know that there are 2 documents in that collection. So this for loop, right? This for loop is going to wind up running twice, creating 2 LIs. And the beautiful thing is we're going to plug in the stage name, then the birth name, and then the number of likes for each of these LIs, right? So I don't have to hard code Polo G, 21 Savage, Chance the Rapper. The beautiful thing is that I can write just this one for loop with one LI, and no matter how many rappers are in my collection, they'll get their own LI built out. Imran with the posture check. Hold on. I was leaning forward a little too much. That was a good one. Good call. Keeping it dry. There we go. Ooh, all right. There we go. Good posture. Good organization. Let me hydrate. Yash, cheers to you. Thank you for the hydration. Fox, thank you for the hydration. Cheers to both of y'all. Alrighty. It's the go-go juice tonight, Reggie. It's the devil's elixir for this evening. Alrighty. So the cool thing is now we have this like template, and we can make as many LIs from this template as we would like. If we looked in our database, we can see that each wrapper has a stage name, a birth name, and a number of likes that's in our database. So we can see one for Sir Savage. We can see one for Chance the Rapper. Please say the rapper. Right? And so we're able to see that there are 2 of these documents inside of our database. Right? And what we're able to do is to have a for loop that uses both of those documents to create an LI. The first one will pull out 21 Savage, 21 Savage's birth name, and the total number of likes, which I believe was 4. Then the second time this runs, it's going to pull out Chance the Rapper, Chancellor, which is their birth name, and then the number of likes, which I think was, what was it? It was 3. And so what we're able to do with this EJS is to build out a template that we can then plug our data into to generate our HTML. So all of this would run. And once all of this is done running, once we're done rendering our EJS with all this data, chat, what do we do with this rendering? We've rendered all this EJS out. We have a lovely, juicy HTML file. So EJS, we plugged in all of our data, EJS is like, thank you for all the data, right? Spit out, like, vomited out an HTML file. What do we do with that HTML file? Serve it up. Yeah, we respond with it. We respond with that HTML file. All right. We respond with that HTML file, and it comes all the way back to our browser, and we see those two wrappers. Now here's a curveball, chat. Ready? I'm gonna 3, 2, 1. Tell me what requests I just made. What requests with an S did I make? Delete was first, and then what did I do? A get, exactly. We made a delete, and then once we made the delete, what did we do? We refreshed and made that get on the refresh. Cool. Now, why is there only one wrapper? There was two. Why is there only one now? There's only one document now. Exactly. When we made that delete request, I deleted that document. And so when I refresh the page, that other document's no longer there. Let's go look at our Mongo Atlas. Let me refresh here. There's only one document now. So when I made my get, and I went to my database, I found the wrappers collection, I found all my documents, I sorted them based on the number of likes, I turned it into an array. How many objects were in my array? How many objects were in my array at this time? Yeah, there was only one at this time. And since there was only one, I passed that lonely object as an array still into my EJS. Wherever I saw info, that was actually that array with only one object in it. And if I look at my EJS, I only built out one LI, which was Sir Savage, the 21st. And then I was done. I spit out some HTML. And I responded with that HTML that came from the EJS. I ran into Chance during the last mayoral election in Chicago. That's wild. That's dope. Walked by them in their security and said, "Excuse me, fellas." All right. Cool. So we're able to see that the get, all the get is doing is going and getting those documents from our database, piping them into our EJS, and then we're responding with that HTML. That's pretty cool. Questions about that while we're here? Questions while we're here about that? That's a tall order, Jesse. Questions about the get. What the get's doing. Do we feel comfortable with the get? If you don't feel comfortable with the get, now's your time. Ask. All the riffraff have left. We're just here with the true believers right now. So there's your time to ask. If the get doesn't make sense, I want you to ask, please. Put yourself out there a little bit. If it doesn't make sense, ask. Can we go over the info data again? Absolutely. Let's do it. So we have refresh the page. Chat, when I refresh the page, what type of request am I making? When I refresh the page, what type of request am I making? I'm making a get. So here is my code that here's the get on the root route. Because there could be so many other pages. Right? There could be so many other pages. Right? But this is the root one. So I heard a get on the root. What I do is this code right here. I can make it do anything. Oops, sorry. I could delete all of this right here. Right? And make it, I don't know, console log, since blah asked the question. Right? I could have a get request and just make it console log blah. That's it. Let me restart my server here. Let me go back to this main page. Let me refresh. It looks like it hangs. But let's come back to our terminal here. And if we look in the terminal, it just says blah. That's it. That's all I coded it to do. My server heard the request, and all I told it to do was console log blah. That's it. Cool. Now, while that's amazing, it's not really helpful for when we're trying to have a web application. All right, so let's put back what we had here. So instead of just console logging, what more could you need? I know, right? Instead of console logging here, we told it to do a series of steps. All right, we went to the database. Right? We went to the database. We found the wrappers collection. And once we found the wrappers collection, we went and found all the documents inside of that collection. Chat, how many documents are left in this collection? There's just one. So we only found one document. That's cool. We sorted it anyway. Didn't do anything really. And then we put it into an array. So this array has how many objects inside of it? How many objects does this array have inside of it? Yeah, just one. So it looks something like this. Right? It's an array with one object. That's it. Cool. This array gets passed into data. Now, chat. The I've been paying attention question is, why does the array get passed into the parameter of data? Why does the array get passed into the parameter data? But like why? It is to render the EJS. You're correct. But why? How? Why does it get passed into that parameter data? How does it do it? Oh, Power got it. It's the response to the promise. Yeah, it's the response to the promise. The key word here was this then. Whenever you see that then, what alarm should be going off in your head? You see that then, the promise syntax, the promise alarm should be woo 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 woo. All right, the promise alarm is going off. So what do we know? Just by looking at this code, chat, what do we know about this request to our database? What do we know about the request to our database? Yeah, it's a promise, right? That request to our database returns a promise. And the value of that promise object is that array of data. So wherever we see data, It's the value of the promise that got returned. That's all it is. Where we see data, it's just the value of the promise that got returned. All right. So this request returned a promise. And when it returned a promise, right, we were able to handle that promise and grab the value. So wherever I see data, it's actually the value that came back with that return. And so data is holding our array of objects. All right. So data is holding our array of objects. Great. Right now, our EJS is set up to accept what. This is how we get to your answer belong. Our EJS takes in one data structure. What data structure is the EJS expecting? Take a look. Which structure is our EJS expecting? It's expecting an object. Yes. The EJS is expecting you to pass in an object. So we passed in that object. Look at the curly braces. We passed in an object. And our objects have key, value, pairs. So the object I passed in has a key of info and its value is the data I got back from that promise. Right? So that array of objects is being passed into my EJS. So wherever I see info, all that is the key, right? Is the key for all this data. So the word info in itself has no meaning. Exactly. It has no meaning whatsoever. It's just the key. I could change it to whatever I want. Let's go ahead and change it to rainbow. Cool. Called it rainbow. Now, inside of my EJS, I have to match that key. So let's go into our EJS. Wherever I see info, it's now rainbow. Because rainbow is the key for holding that array of objects. Exactly, to 42. And that's what I just did. I changed it here in my EJS. So now it's respecting that key of rainbow. Let's save it up. Let's make sure it says rainbow here. It looks good. Looks good in our EJS. Let's restart our server here. And it all works. Right? It all works. How do you select multiple in VS Code? On Macs, you hold down Command and click, and then I think Windows and GNU Linux is Control, but don't hold me to it. Line 29 now makes perfect sense. I always wonder why it was written like that. Let's go back and take a look. Oh, this one right here. Okay, there you go. Cool. Hope that makes sense. Glad it does, Shells. Where do we declare the name wrappers for the database? That's a good question. So we don't have to, and this is the beautiful thing with MongoDB. MongoDB is so flexible, right? MongoDB is so flexible that you don't really have to set up things ahead of time. If you try to use a collection that doesn't exist, what does MongoDB do for you? So like I try to save to a collection that doesn't exist. What do you think MongoDB does? It just creates it. So down here we have our post. We're trying to insert a document into the wrappers collection. If there was no wrappers collection, it'll automatically create that collection for you. That's part of the beauty of MongoDB. It's just so flexible. It really kind of, I can see how it can be a blessing and a curse, but it really just kind of just make it really easy to build stuff out simply. right? So eventually we'll use models, and the models will be the only way that we talk to the database and all that fun stuff. But for right now, we have it very simply set up. And if it doesn't exist, it just creates it. Yeah. This stuff is making so much more sense when you explain the info. Hey, I'm glad we asked that question then. That's great. Thank you for asking that, Blah. Do you need to match the my first database part in your string exactly? Often you don't have to. It'll just automatically create it. But I like to make sure that mine's all tidied up. With this way of connecting to the database, I like to make sure that my database name matches my Mongo string. And so you'll notice I put wrap in here instead of my first database. So mine says wrap there, and then in my server.js, I gave it the DB name of wrap. But what you'll notice when we do the other way of connecting to our database later on, that it'll automatically create it for you as well. Cross said, at what point should we create a routes folder? Well, right now, how many actual routes do we have in terms of pages? Like how many pages does our application have? How many pages does our application have? Just really one, right? It just has one. So I don't really need routes yet because I don't have multiple pages. Once you start having lots of pages, like when we're talking about the social network, right? We have the home page, we have authentication routes like login, sign up. We have the profile, the feed, individual post pages. And so once we have all of those pages, then routes start to become really important. And then you start thinking about, all right, so we have individual pages that we can navigate to, but each of those pages are doing a lot of stuff. Like right now, yes, this is one page, but we also have update routes, delete routes, post routes. And so when you start to see that, it starts to compound, it starts to get a lot. And so eventually, once you have an application where you have not only multiple pages, but multiple routes per page, then you need to start creating a routes file just to keep that organized. And we'll get there. Cool. This is for y'all, right? We've been, I know, I can't believe it's been 7 hours already. That's wild to me. But I'm doing this for y'all. This ain't for me. So I really hope if you have questions about this Git, this is the time to ask, right? Please ask your questions. Don't make me have wasted 7 hours, right? Don't make me have wasted 7 hours if you have a question that you're not asking. That's all I ask. Right now, it's all I ask is that you didn't make me waste my entire Sunday by not asking the question that you want to ask. So if you have a question, please ask it. That's all. That's the only thing. That's the only thing I want. Honestly, the only thing I want is if you have a question that you ask it about this Git. Are we going to do all of this today? I don't know if we're going to be able to do it all. I think people, we'll see once we get through this, once we get through all this code, we'll take a poll to see where folks are at. Oh no, I don't feel like I wasted my time. The only thing I'm going to feel like I waste my time is if you don't ask questions. That to me, that's disrespect. That's honestly, real talk, that's disrespect to me. I just gave you all 7 hours, and the only thing I'm asking for is if you have a question about this Git that you ask it. That's it. That's all I want. I appreciate that, Coder Chick. Can we do a YOLO? Yeah, we'll do a YOLO before we leave. I really want to know what goes in routes, models, views, controllers. We'll get there, yeah. What did the sort likes by -1 mean? All right, let's go over that. So let's say we had a lot of wrappers in our database, right? Let's say we had a lot of wrappers in our database. So let's go back and add some more wrappers. Let's add chance, and we'll add back polo G. So let's go ahead and do chance, lowercase the wrapper. Birth name is Chancellor. That's a dope name. And let's go ahead and add back polo G. Taurus. So that's a fire name. All right, polo G. Cool. All right, so now I have like this likes I can do. And so look what happens here. 4, 4, but watch what happens when chance becomes 5. Look what happened. Chance is now above 21 Savage. All right. Chance is now above 21 Savage. So the way that this worked, right? The way that this worked is we went to our database. We found all the wrappers that were in that database. But what we did was we sorted them based on their number of likes. And the way we sorted them was from greatest to least. That's what the -1 means. The -1 just means from greatest to least. If we change this to 1, let me save. I gotta restart my server real quick. Cool. So now that it's 1, it's going from least to greatest. You see that now, right? So it just sorted the documents for us. Yeah, so -1 was descending, 1 was ascending. And so that's all it did. And so I'm gonna put, I like the descending. So I'm gonna put this back to -1. Let me save. Let me start it again. Let me refresh. Boom. Now we're going 5, 4, 0, right? We're sorting based on the number of likes. And this is all happening on Mongo's end, right? This is all happening on Mongo's end. And when we sort it by -1, we get an array with the objects going from 5, 4, 0. And if we just did 1, we get 0, 4, 5. So the order of the objects in our array is coming from this sort. Yeah. Is there a reason why it's -1 or 1? In a lot of languages, the reverse, like going backwards, is represented by -1. So if maybe you think of like Python, you do -1 and it sorts from the back. So it's just a very common thing in other languages. Yeah. Sort in this case is a MongoDB thing, right? In this case, sort is not a JavaScript thing. It's a Mongo thing. And the reason why we know it's a Mongo thing is because, look, we're still chained to this database. It's database.collection. Collection, find, sort, to array. These are all Mongo methods that come to us from this package right here. If we didn't have this package, we couldn't use any of those methods. And when we switch to Mongoose, the methods are a little bit different. Yeah, they're a little bit different. So they're all coming from MongoDB right now. So if we look, we have collection, which is a Mongo method, find, which is a Mongo method, sort, which is a Mongo method, and then to array, which is also a Mongo method. So what we did is we went to our database. We found the wrappers collection. We found all the documents into that collection, but we just didn't find them in their regular order. Mongo sorted them for us, right? And then put them into an array. And then we passed that array into the EJS. Somebody said, why would we use, I don't know why it got banned, but I did see it. It said, why would we use Mongoose? Thank you for permitting those, Blah. The reason why we would use Mongoose later on is because we're seeing how flexible Mongo is, right? We're seeing how flexible Mongo is. If there's not a collection, it creates it. A lot of times, if there's not a document and there's upsert, it'll just create it. And that's cool at the beginning. But when you're working with a team of a full engineering team, you might have dozens, if not hundreds of developers. that flexibility starts to cause more problems than it helps. And so you want to make sure that your data has some sort of structure or some sort of sense. So when we get to Mongoose, we start using something called schemas. And Mongoose just gives structure to our Mongo database so that we know what's going in and what we can expect to come out. That's all. Yeah. So we use Mongoose to provide a little bit more structure to MongoDB, just so that we're not guessing what's going in and coming out. We'll get there. How does render work I think we're talking about this right here, this render. So this method, what it's doing is this render method comes from whatever we told Express to set up as our templating language. So whatever we told Express to set up as our templating language, that's what it's going to use to render. Okay. So if we go up to this line, we said on line 18, use the view engine called EJS. We could have told it to use handlebars or Pug or any of the other view engines you might have seen, but we told it on line 18 to use EJS as our rendering engine. And since we're telling it to use EJS as our rendering engine, when it comes down here to the render, it just knows, all right, I'm going to use EJS as my rendering. I'm going to pass in this EJS file. I'm going to pass in this EJS file and this data. And then it just does its magic. It renders out that EJS file using that data. And chat, what does it spit out? What does it spit out for us? What does it spit out for us? Yeah, it spits out HTML for us. Cool. All right, folks, we're at the top of the hour. We went a little over. So let's go ahead and take our break. Let me go ahead and put the 5 minutes back here. Don't worry, we're going to come back to this. Is it possible to do multiple operations in one request? You can either nest or use async await syntax. So I would recommend using the async await, but you can do multiple requests you can do multiple talks to the database per request, if that's what you mean. So let's go ahead and take our break real quick. And when we come back, we'll keep answering questions about the stuff that we have here. We're going to get through the posts, the puts, and the deletes. All right. 5 minutes on the timer here. Let's go ahead and put some lovely musics on. Just want to make sure we get everybody a break here. Thank you, Leon. This is helping a lot. Hey, I'm glad it's helping. Cool. Let's go ahead and I'm going to start the timer. All right. I'm going to run some ads so we can all take a break and make sure new folks joining us don't have to sit through the ads at first. So I will see you all in 3 minutes, and I'm going to take a break too. All right, folks. See you in a bit. Burb. Take your break, please. Hydrate, stretch, walk around. We've been doing this for 7 hours. Please, if you're able to, get up, move a little bit, let your eyes focus on something that's not the screen, and I'll see you back in a bit. Hey. Oh, Imran's the hero. Added 2 more minutes. Hold on, let me add those 2 more minutes. There you go. Y'all better thank the homie for sure. All right, catching back up. In this instance, would it still work as with arrow functions? But need it for 0. I'm not sure I understand that one. Like, where are you looking for the arrow function? If you tell me where, I can tell you. I think this might get dicey if your second request depended on the first. Yeah. I'll show you where we've done this in the past. I'll show you where we use where we've seen this, and I'll pull that up when we get back from break. I know this is a crash course. If I join the Discord, can I still catch up? Yeah, come on in. Do exclamation point 100 devs, and that'll give you everything you need to get caught up. And I'll be updating that tomorrow, just so that it's more up to date with the things that we're doing. Hey, silly, I'm glad. The part I'm a little confused is the structured part, rainbow data. Are you basically saying render EJS along? Yeah, so what we're saying there is that we're just literally passing in an object. That's all. The EJS needs the data, and the way we're passing in the data is we're just passing in an object. That's all we're doing. We're saying, hey, EJS, here's an object. And then EJS is going to use that object. And so the object is really just an array with the key of rainbow. So wherever I see rainbow, that's the array that's inside of that object. What hosting service would you recommend for around 3 static pages for a business? Netlify all day long. If it's ever static stuff, Netlify. Love Netlify. Shout out Netlify. You don't have to pay me for that one. Netlify's the best. With EJS, is there a way to comment without disrupting the code? Yep, you can put comments in the EJS. When we come back, I'll show you how to do it. What does render do? Render just makes sure that we spit out the HTML from our EJS. Cool. Do you have a go-to for checking EJS formatting? Yeah, EJS lint is kind of like the one that most folks use. Yeah. Can you host your React project on Netlify? So it depends on how you have it set up. If everything is static files, you can put it on Netlify, no problem. If it's not static files, then no. Well, easily, I should say. Depends on what your end result is. Alrighty, come on back, folks. Hope you had a good break. Yeah, a lot of folks use Surge these days, and then your backend stuff is on Heroku. We'll get there. We'll get to showing you how. I'm like as always, I'm gonna show you how to do it all for free. You're never gonna have to pay for any of the hosting stuff early on. Yeah. Even like when I was building out the code for the photos being on Cloudinary or S3, the decision came down to, well, Cloudinary gives you 25 gigabytes for free for life, whereas S3 gives you 5 gigabytes for free, but only for the first 12 months. So guess what we're using, y'all? Cloudinary to host our images. So a lot of those decisions come down to that. But the beautiful thing is, all my code is hosted on GitHub for free. All my servers are free on Heroku. My backends are all on Heroku for free. All my static stuff is on Netlify for free. My databases are on MongoDB for free. My static stuff's on Netlify for free. Like, what a time to be alive. that everything can be hosted for free. Like this is wild. Like back in the day, it wasn't this good. Hey Reggie, thank you for the 5 gifted subs. I appreciate that. Thank you so much. Wait a way to come back from break. Thank you for being here. Thanks for hanging out with us for this whole time. What is Cloudinary? So Cloudinary is just it's a place to store your images. That's it, and your videos and other media. Because we will find out that we can't just store our media on Heroku, because whenever new stuff is created and our server resets, it all goes away. Yeah. So we have to find some other place to keep our media stored for the long haul. The 2 big ones are S3 and Cloudinary. But yeah. You can host your front on Heroku too. Yeah, you can. Absolutely. Love her. That's hilarious. That's some OnlyFans content name right there too. Watch out. Get me in trouble. We lost our gnome butts. Yep, all the gnome butts are gone. That's Heroku's being ephemeral that gets that all going away. All right, folks, come on back from the break. Hope you had a good break. Hope you're able to hydrate. Reggie, thank you for the gift of subs. I appreciate that. All righty, folks. Let's jump back into the code here. Just try to make sure there were no questions while I miss. We talked about the render. We talked about all the other good stuff here. Any questions about the get before we move on to the post? Any more questions about the get before we move on to the post? Still can't believe it's 7 hours have passed. Hey, let's keep going. No, I'm on my phone while I stretch. All right, let's take a look at this post then. Let's talk about this post real quick. So let's go to our application here. I'm going to chill the music. Let's refresh. Let's look at this post here. All right, so let's do a new wrapper. What's somebody's wrapper here? Do you chug a gallon of honey after this? No, I don't eat honey. I'm vegan. But we'll find something else, right? I'll do what am I gonna do afterwards? I don't know. Tea. I drink a lot of tea. Dylon. Dr. Dre. That's let's do that. Dr. Dre. Let's do it. Let's do it formal. All right. Dr. Dre's real name. There we go. Oh, rapper. I don't know. I guess. You aren't going to sleep, Leon, if you're drinking coffee this late. The beautiful thing about being bipolar is I don't sleep unless I take my medication. And my medication does not care how much coffee I had. It knocks me out. And so, shout out to my medication, because it doesn't matter what I do during the day, I'm out. All right, so we added Dr. Dre. We added in their stage name and their birth name. And we submitted it. So when I hit submit on that form, chat, what type of request did I make? You tell me his real first name ain't Doctor. Yeah, I made a post. Cool. Now, I could have a lot of posts. All right, hold on. Let me do something in the EJS real quick. Let me get funky real quick. Let me go to my EJS. Let me add another form here. Let me add a bunch. All right, so I have all these new forms. How could I distinguish from all the different forms that could be on the same page on the same route. How could I how could I see Sim? What could I do here to distinguish between all the different forms? Yeah, there we go, Rob. We could give them different actions. So the thing that our server is going to be listening for is not only the post, but the action. So I could change the actions on these. And now, when these forms submit, I could have different posts for each of these forms. So let me go back to my server.js. And instead of having just the post for add wrapper, I could literally copy this and have another post for unicorn. And another one for, what was the other one I did? I don't remember what the other one was. Rainbow, right? So I could have different posts that all are heard in our API based on their action. We're about action around here, right? And so if we go to our server.js, the way we're able to distinguish between posts that are all on the same page is that the action matches to this route. So let me go ahead and delete these. We don't need this here. But that's how I can distinguish between multiple posts. And I'm going to go to my EJS and just clean this up too. We don't need these. Boom. All right. So we're able to be able to distinguish between multiple forms solely based on their actions. Does that make sense? So that's how we'd be able to server side know what form we're listening for. Cool. Alrighty. Now, since, yep, the action in the HTML, exactly. So since this form right here, let's go in and refresh. We can inspect, right click, inspect. Let's look. The action on this one is add wrapper. So since the action on this one is add wrapper, all right, I can listen for that form in my EJS. All right, I'm listening for a post from add wrapper. Once I hear that post from add wrapper, I can then go ahead and do all this lovely code in my callback. Okay. So only when you have multiple forms, you need multiple posts. Exactly. So you'd have a post for each form that submits, if you want them all to be different. Cool. All right. So when we look, let's go back and look. When I submitted this form, the end result is that we could see that the new wrapper that we added, Dr. Dre and their birth name, right? But a lot of steps had to happen for us to be able to see this in the DOM. So we submitted this form. Chat, one more time, when I submit a form, in this case, what type of method was the submitting of this form, please? It was a post. Nice, it was a post. And so here we have our post. The action matches. So here's add wrapper. If we look at our EJS, add wrapper, it's a match. So we know that we are firing this part of our API. Great. So when the form submitted, we went to our database, we found our wrappers collection, and we used a new Mongo method called insert1. What is insert1 going to do, chat? What is insert1 going to do for us? It's going to make a new what? It's going to make a new what? Yeah, it's going to create a new document. It's going to create a new document in our collection. Gotta keep it civilized, right? It's going to create a new document. So insert1 creates that new document. That document We can see he's going to have a stage name, a birth name, and a total number of likes, right? And so the cool thing here is that we're kind of just doing it on the fly right here. We kind of talked a little bit early about why this might be a bad idea. Eventually, we're going to want to use a schema and mongoose and all that stuff. But right now, we're throwing all out the window, right? And we're creating the document on the fly right here. Okay? So whatever document we create is going to have a stage name, a birth name, and a number of likes. Let's look at our Mongo collection here. Let's give it a refresh. Cool. So you can see that we have our different objects in here now, but each of our objects have a stage name, a birth name, and a number of likes. So it's working. We also see that whenever a document is created, chat, what also gets created whenever a document is created? Yeah, it gets this object ID that's created. For every document's going to have a unique ID. Power said, Leon, so the path is like an address leading us to the action, right? Absolutely. So that means if we name my path something like wrappers, another wrapper, add wrapper, yeah, that would be the path that you would see in the URL. So if our form was not on like this route and it was something like we were on / like the add wrap, like we were on, I don't know, thinking of like Papa to Rappa. If we were on a page called Papa, like if that was the URL that we were on, our route would look different. It would be Papa, or what is, I don't even know. How did I spell it? 2P's. Right? We would add Papa like that. So if we were on a different route, the stuff leading up to our add wrapper would be different. So yes. Cool. But we're not on that route. We're on the main route, so we can just do / add wrapper. Cool. Salute. Salute. Alrighty. So we submitted our form. We submitted the form. For Rapper the Rapper, put respect on his name. Is you done or is you finished? That's one of the best interviews of all time. If you don't know what I'm talking about here, it's the Birdman interview on the Breakfast Club. Put respect on his name. Definitely watch it. It's a classic. All right, so we submitted our form. We heard the request. We go to our database. We find the wrappers collection. We insert a new document into that collection. All right. We insert into that collection a new document. And then what do we do? When we're done inserting that document into the collection chat, what do we do? When we're done inserting that document into the collection, what do we do? We redirect them back to the main page, which triggers a refresh. And when we do the refresh, that triggers a get. We go back to our database as part of the get. And this time we get our wrappers again, but this time there's a new one in there. Dr. Dre's in there this time. And we wind up having Dr. Dre in the DOM, right? So the post made the document in the collection, but then we redirect it back to the main page. And when we redirect it, right? When we redirect it, we had a new document that was in our collection. And so when we made our get, we had more data this time, which means more wrappers that make it to what we see here in the DOM. Instead of doing a redirect, could you also just send the new data? Yes, we'll build up to that, Joe. We're not there yet, but the idea is that in the end, if we're trying to build, say, like a single page application where we're not changing pages or routes, we can just keep sending data that updates without having to do refreshes. That is a big thing that we'll get to later on. Big for You said, can we visualize somehow how our database looks like and what is the contents? Yes, this is where Mongoose comes in. With Mongoose, we're going to have our models, and models show us the structure of our database without having to guess or look anywhere else. We can just look at our model and be like, oh, I can see how the data is structured in that model. Since the data is structured in that way, then I can just go ahead and know that the data going to my database looks like that model. And so let me show you a model real quick. We're not there yet, but I think it's worthwhile to show one. Cool. Here's what a model looks like. So here's my post model. So this is a model from the social network that we built, which is like an Instagram clone. And so you can see that any post that I make is going to have a title, an image, a Cloudinary ID, a caption, a number of likes, a user, and a created at property. So anytime I was to create a new post, it's going to have all of this data in it. If I try to create a post that does not have one of these, it throws an error. It won't work. So I know, without having to look anywhere else in my code, that the data is going to look like this. So we're going to build up to this. We're going to build up to this idea of using schemas and Mongoose to give our database structure and control, but we're not there yet. Fox with the hydration, cheers to you. Yeah, I think it's pretty cool, right? Like the idea that like you can have like the schema that gives you structure is pretty cool. Because right now, we don't know what people are putting into the database. We just kind of put it in there, right? We just put it in there. And if I was sharing this code with others, this is pretty dangerous. Because the people I share this with, like the developers I share this with, they would have to like look through all of my code to find out what's going into my database. Once we get to Mongoose and we have schemas, they don't have to look anywhere. They can go look at the models and be like, oh, I know exactly what's going into the database, full stop. So that's why we build up to that. It just gives us a little bit more control and it makes it easier to work with others. Cool. This case though, we created the document, and then once we were done putting that document into our database, we redirected back to the main page, and that triggered another get. The get went and got all the new data, piped it into our EJS, spit out the HTML, and sent that HTML back to the browser. Alrighty. Questions about the post? Questions about the post? Question. All right, Joe, hit us up. Wait, so how are you sending the client, like the front end? Cool. Good question, Joe. So we know that we just created a new document, right? With this line right here, this line 306040, we created a new document in our Mongo database, right? So this is the Dr. Dre one that we just created, right? Just created this new document called Dr. Dre. We created with this line of code. The cheeky thing that we did is instead of like figuring out how to like code up a response, we just told the browser to refresh. We redirected them back to the main page, which triggers a refresh. So let's mimic it together. Page refresh, we got redirected back to the main route. Since we made a refresh, we make what type of request to our server again, chat? What type of request gets sent to the server, right? We refresh back to the main route. That's what that / is, the root, right? On that refresh, we made a get. Cool, so let's take a look at our get. We heard the get. We go to the database. We go to the wrappers collection. We find all the wrappers, which now includes Dr. Dre. We sort all the wrappers based on the number of likes. We turn that into an array of documents, like our array of objects. We have one for Dr. Dre, one for Polo G, one for 21 Savage, one for Chance the Rapper. And we pass that array of documents through data into our EJS file. So our EJS now has this array of data with the key of rainbow. So wherever we see rainbow, that's all of the objects we got back from our database, all the documents we got back from our database. And so if we look at our EJS, we're going to create an LI for each one of those documents that was inside of the rainbow array, which means we're creating 4 LIs, which are the 4 different rappers we're going to see here. We're going to pull off 21 Savage, Chance the Rapper, Polo G, Dr. Dre. So now we have all 4 of those LIs. We created that EJS file. It spit out the HTML that includes all of those wrappers. And we responded with that new HTML file. So yes, we made a post, but that post at the end of the day caused a redirect. That redirect made a new get, and then we did all of the stuff we did before to show all the new wrappers. Cool. What happens if you submit an empty input? Yep, it'll pull empty strings into the DB. Because we don't have any like validation on it right now. We saw some validation when we got to our social network. We saw some of that like that validation to make sure we weren't passing in empty stuff. Yeah. We kind of talked about that -1 likes already, but all that means is that we're sorting based on the likes, and -1 is just descending order. So we're going to find all of the objects based on their number of likes in descending order. Leon, can you please explain? I want to make sure about the rec.body. Yeah, sure. Let's talk about the rec.body. Yep, let's get there. Good question. So if we look at our post, we passed in a stage name that was equal to rec.body stage name. We also passed in a birth name that was equal to recbody.birth name. Remember, whenever we were sending that request, the first thing we did was console log that request. And there was so much stuff on the request, right? It was so much that was inside of that request, right? One of the interesting things is that when we're submitting a form, we have told Express how to go and look at the data that we're sending when we submit a form. So if we look at lines 20 and 21, this is letting Express know, hey, I want to be able to see the stuff that's inside of those requests, right? If you come in from like a way back in the day, you might have heard of something called body parser. Body parser is kind of like built into Express now. And so we use these lines to be able to look at each of the requests that comes through. And so the cool thing is when you submit a form, the information that was inside this form gets sent along with the request. So we made our post request, right? We made our post request, but a part of that request was all the information that was in this form. And so the cool thing is, since we are using these 2 lines right here, we can look at what's called the request body, right? And on that request body, right, in that request body will be the stuff that was inside of that form. So if we go back to our EJS and we look at the form, you can see that this input has the name of stage name, and this input has the name of birth name. When we're looking at the request.body, to find the stuff that was in this form, we look at this name property. And to find the stuff that was in this form, we look at that property. So let's make these funky. Let's make these like stand out a little bit more. Let's call this Bulbasaur. All right, and let's call this one Pikachu. Cool. So now my form has a name property of Bulbasaur, and this other input has the name of Pikachu. If I want to be able to go ahead and grab, right? If I want to go ahead and grab these values from the form, I need to make sure that they're over here. So this will now no longer be stage name. It'll be rec.body.bulbasaur. And this will be rec.body Pikachu. All right. And the reason this works, the reason why this works is because when we make that post, we're sending all this data along with it. Let's show it all. Let's go in here. Let's go ahead and console log. Let's go ahead and console log the request. And let's put some stuff here. Whole request. Cool. So we're gonna say this is the whole request. And let's do another one that's the request body. Cool. This is the request body. And we're just going to do request.body. Cool. Somebody said, what about the stage name before the colon? This is just the placeholder. This is what shows up in the actual form. That's what that is. Yeah. Cool. All right, let's look at this again now. We've made some changes. We've given this input the name of Bulbasaur, and this input the name of Pikachu. Anonymous gifter, what? 5 gifted subs. Hey, thank you, Anonymous. I appreciate that. That's wild. Thank you for doing that. It's even wilder. Like, anonymously? What? That's cool. Hey, I appreciate that. Thank you for the support. That helps a lot. Like, the thing I keep saying is that all of the bits and the subs, that all goes to the nonprofit I work at during the day, and it goes directly into our emergency fund to help folks with mental health. So if they need to talk to a psychologist, they need to get help with their medication, that's where it comes from. And so we've put $4 grand into that fund already, which is wild to me. And so many students have been able to take advantage of it. I really appreciate it. And that that blows my mind, because we legit ran out of money. Like, we ran out of money in that fund, and to be able to be like, boom, stack, right? To keep helping folks that's been wild. So I appreciate it. Thank you for the support. Thank you for the gifted subs. That's wild. And a lot of people have gifted subs tonight. I really appreciate everyone that did it so far. Yeah, I really do. All right. So let's go ahead and take a look at this. We have our form. Our form has inputs with the name of Bulbasaur and Pikachu. When we submit this form, we should see in our terminal here the whole request, all right? And we should see the request body, all right? How much is in the startup fund? I actually don't know. I can take a peek. When we take a break, I'll take a peek. We have quite a bit. That's quite a bit. All right. So we should be able to see this whole request. Let's go ahead. Let me restart my server. And let's come back here. Somebody give me another wrapper, please. Somebody give me another wrapper. Don't you say parappa. Busta Rhymes. There we go. Love it. Trevor. I didn't know this one. I have a very unhealthy Wikipedia habit. I spend a lot of time on Wikipedia. Like, way more than any human should reasonably spend on Wikipedia. So I actually know a lot of rappers' real names just because I go on Wikipedia binges where I do this, but I actually didn't know Trevor. That was pretty funny. Now it sounds good, but it's gone past the good into like I spend too much time on Wikipedia. All right. I'm nasty at trivia though. I'm nasty at science trivia. I got you. All right, so let's go ahead and put in Busta Rhymes. And let's put in their birth name. Oh no, it didn't work. Let's see what happened. Let's take a look. So here's the whole request. Look at this whole request. Look at all this stuff that's on the request. Look at all this stuff. I'm still scrolling. I'm still scrolling. Let's go back down. And if we look, as a part of this request, I scrolled a lot. Here we go. As part of this request, we have this body part here towards the end, right? And on this request body part, you can see that there was a stage name property of Busta Rhymes and a birth name property of Trevor, right? And so the interesting thing that must have happened is I must have not have clicked refresh. And since I didn't click refresh, the old values in the form must have still been there. Like the old name must have still been there, and the old, like the name for the second one must have still been there. So let's try it again. Let's refresh the page. Let me inspect real quick. We can see that the name is Bulbasaur, name is Pikachu now. And let's go ahead and try it again. Busta Rhymes, Trevor, and there we go. I did restart the server. But I never refreshed my client. So my client still had the old form. That's what happened. My client still had the old form. Let's get rid of this if it'll work. The client still had the old form, right? And so since my client still had the old form, I submitted a post that my server really couldn't handle, right? Because it was looking for the old name properties on the body that didn't exist. So now when we look at it this time, we can see that the request body has Bulbasaur and Pikachu. And I'm able to grab the values out of Bulbasaur, which is Busta Rhymes, and the value out of Pikachu, which is Trevor, and use that inside of my application. So I'm able to say, all right, create a document that has the stage name of whatever was in the Bulbasaur input, and create a document that has the birth name of whatever was in the Pikachu input, right? And then we're going to grab both of those values. So in this case, rec.body.bulbasaur equals Busta Rhymes. And in this case, request.body Pikachu equals Trevor George Smith Jr. Cool. And so that's how we do it. The form that we're submitting is the add wrapper form. If we look at our EJS, we can see that the action is add wrapper, so we know that's good. And we get the inputs by the name properties. That's it. 42, thank you for the hydration. Cheers to you. No worries. Cool. Let's go ahead and I just want to go to my database real quick and look at that weird one that we added, right? Let's refresh this. And the cool thing is inside of MongoDB, if you don't like something, you can come in here, right? And just delete the one. So that's what we're going to do. We're just going to delete it. Cool. And if we go back to our page and we refresh, we can see that one is gone. So the other really cool thing about having it host it, like our MongoDB host it, is it comes with this like glorious GUI that's really easy to work with. You can have GUIs for your local ones, but it just comes out the box. Nice. I get this more now. Let's go. That's what I like. That's what I like to hear. All right. Questions about the post before we move on. Questions about the post before we move on. Feeling good? Let's see. Any questions? Any questions about the post? Nope. All right. All good. Yeah, Compass is dope. Can you please show us how to display wrapper added on the page as well as the console? What do you mean on the page? So we have the wrapper added just as a console log here. So we can see in our terminal that we added a wrapper. That's pretty common. You want to add like a, like an H3 or a span? Sure. So you want it to like appear and then disappear. So we could do that with like, it's actually a little bit more complicated than what I think. If you're thinking what I'm thinking, it's actually a little bit complicated. So we'll save that. I'm not going to do that right now because I think that'd be like too much of a tangent. But we could do like could do something like similar to how we do the flash messages, like how we have those messages pop up. We could do something similar to that, where we're kind of just serving up a message that's ephemeral and kind of goes away. Like we could have like, we put in the H3 and then we have like a really hacky way of doing it, right? Would just be to add that H3 and then have some client-side JavaScript that removes it after a second, right? Like that could be a fun thing. Like it pops up and then you just remove it. Like that's a really hacky way of doing it. Yeah, with our client-side JavaScript, exactly. You could do it with Angular Kappa. Yeah, you could. We'll get there. Like React makes that stuff really easy too. Because then we have like state and we can update the state and then things change. Yeah. Cool. But for right now, I think that might be a little bit too much of a tangent, but. Alrighty. Next, let's do the delete. Delete's a little bit less complicated. All right, so here's our delete. Let's go ahead and delete Dr. Dre here. There we go. We click the trash can. When we click the trash can, what kind of request did we make? Do we know? Is there something that like instinctively tells us what type of request we made? Like if we didn't see what happened. I always do that. I always like cover my screen thinking that you can't see the screen. So like I go like this to the screen. I'm like, oh, they totally can't see it now. I'm so used to being in the classroom. Like when I'm in the classroom, I can like literally cover parts of like the, if we're using a TV, I normally have like a TV that I'm projecting to, I can cover. So I keep doing that. What on Twitch? Move your hand, please, Rox. That's hilarious. So if you didn't actually see what, I did it again. Even if you couldn't see what happened, was there any way for you to like really know what happened when I clicked that trash can? Like if you didn't see the result, was there a way of you knowing? That's funny, Wolfpack. Yeah, there's really no way for us to know. Right? Like it's coded, so we can look at the code and know what happened. But when we refresh the page, we know that's always going to be a what, chat. When we refresh the page, it's almost always going to be a what? A get. When we submit a form, it can be a get, but most of the time it's always going to be a what? a post. That's actually not a bad idea. 1, 2, 3. All right. But when we start doing this stuff that's like listening for clicks and things like that, we don't really know what it's going to be. Right? We don't know what it's going to be. Right? So it's up to us to figure out what it's going to be. Now, I'm going to show you a way of doing this deleting request that I think is kind of old school. In the newer code that we're going to use something called method override. So what I'm about to show you for handling this delete is not what we're going to use going forward at all, but there's a lot of code bases that still have this, right? So I'm going to show you like the really old school way of doing it, things that we've done. But if you look at my newer code, if you and your team were looking at my binary upload boom code, you'll know that we were using method override. So know that this is old. This is a caution. I'm going to show you the old school way, and then we'll see the method override way later on. Brian, I don't have to stop. All right, so let's take a look. Chat, what could hear the click on that trash can? What's the only thing that could hear that click? What's the only thing? Smurf, yes. Somebody's gonna be in an interview. Somebody's gonna be in an interview. They're gonna ask you, hey, what's the only thing that could hear click events on the client side? And you're gonna be like, Smurf. Damn it, fuck. Not a Smurf. An event listener. Yeah, our Smurfs or our event listeners are the only way that we heard that click. Right, we heard that click, and so the client-side JavaScript heard that click, and so we have to go to our client-side JavaScript to see where that click was heard. All right. So here, I grabbed all those trash cans. If we look at our EJS, you can see that the trash can is actually using something called font awesome, and so it's this span right here. All right. The span right here has the FA trash class. That's what makes it show up as a trash can. But it's also something that I can grab based on the class. Reggie, hey, thank you for the 300 bits. So we go ahead and we see that we're going to grab all the trash cans. Then what I'm going to do is I am going to loop through all the trash cans and add this delete wrapper event listener to each of them. So we grab all the trash cans, we loop through all the trash cans, adding the event listener to them. Oh, I didn't see the message. 8 hours, you're a real one. Hey, Reggie, I appreciate that. Thank you so much. All right. I can't believe I've been here this whole time, but enjoying getting caught up. Hey, I appreciate that. That's awesome. So we grabbed all the trash cans, we looped through all of them, and we added this event listener to each and every single one. Cool. So now all the trash cans have this delete wrapper function. Let's look at this delete wrapper function. We can see that it's an async function. Woo! We're going to use that lovely async await syntax here, client side. And what we did is we went in and we said, all right, so you just clicked on that trash can. Parent nodes means we went up a level. So let's look at the EJS. We clicked on this trash can. Chat, what is the parent node of this span? Tell me. What is the parent node of the trash can we just clicked on? The LI. Yep. The LI is the parent of the span we just clicked on. You could use closest. There are some things like that you could have used here. But I know that I just clicked on this trash can, so the LI is the parent node. Great. Now, once we're at the LI, we can search for something that has the class of stage name and grab the text that's inside of it. Right? So when we clicked on Dr. Dre's trash can, we said, all right, we clicked on that span that was the trash can. We went up to that LI, And then we looked inside that li, and we found something that had the class of stage name. Once we found something that had that class of stage name, we grabbed whatever text was inside of it. So that text was Dr. Dre. Cool. Then the next line of code ran. All right, we clicked on the trash can. We went up to the li, and then we looked for something that had the class of birth name. And then we grabbed the text inside of it. So if we go back and look at our EJS, we had clicked the trash can. We went up to the li. We then found something that had the class of birth name, and we grabbed the text that was inside of it, which was Andre. Right? That was their birth name, right? Andre is their birth name. Great. So now we have both their stage name, Dr. Dre, and their birth name, which was Andre. So what we do next is we go ahead and we make a fetch with that information. Now, a fetch can be any method. We can make a fetch as a get, a post, a put, a delete, doesn't matter. So we're going to make a fetch to the delete wrapper route. And we're going to say it's a delete method. And we're going to pass in Dr. Dre and Andre. What if we have a duplicate? Then this would grab the first one. Yeah, we haven't handled duplicates yet. Like I said, this is old school. This is how we're going to do it going forward. When we do this in the future, we're going to use IDs and other fun stuff to make each bit of content unique. This is kind of older. And this wouldn't handle duplicates at the moment. All right. So we're going to make a fetch. And the fetch is going to be a delete request. So we have to find in our API a delete wrapper route that's also a delete method. So let's look at our API. We have a delete wrapper route, and it is a delete method. So we know that this bit of code is going to run. All right. We know that this bit of code is going to run when we click that trash can. All right. We click that trash can. We know that we're going to run that API endpoint because the delete wrapper and methods delete. We know that that's a match. So this is going to run. We also know that we're passing in something, a part of the request body. We're passing in something that has the stage name S property and something that has the birth name S property. We know that this is going to be whatever came from up here. So this is Dr. Dre. And we know that this is going to be, we know this is going to be whatever came from up here. So that's Andre. And we pass that along as part of our fetch. So when we come over here, we're inside the right route. We're going to go to our database. We're going to find the wrappers collection. And then we have the delete one method. Chat. What does the delete one method do? Don't worry, we're going to review it again. We just got to get through it and then we'll come back to it. What does the delete one method do? Yeah. It deletes one what? Yeah, it deletes one document. So what we're going to do is we are going to look through all of our documents. And exactly, Thrax, the first time it finds a match where the stage name equals what was passed in, as soon as it found Dr. Dre, remember, this right here is holding the value Dr. Dre. As soon as it finds a document that has the match of Dr. Dre, it deletes it from our Mongo database. That's it. So let's step back. Let's look through all those steps. User clicked the trash can, right? I clicked the trash can next to Dr. Dre. I clicked the trash can that was next to Dr. Dre. What heard that click? What heard that click? The event listener. So our event listener is part of our client-side JavaScript. So we have to go to where our client-side JavaScript is. It's our main.js file. And we're like, all right, we found all the trash cans. Boom. We added this event listener to all the trash cans. Boom. That's the delete wrapper function. Let's go to this delete wrapper function. And what we want to do is we want to be able to know what trash can we just clicked on, right? There's so many different trash cans. Which one? Which one did I click on? Right? So if we go and we look, all right, I clicked on the trash can. And what I want to do is I want to find the stage name and the birth name next to the trash can that I just clicked. Right? Got to find yeah, exactly. I want to be able to find the text next to the trash can I just clicked. So to do that, I know I'm already inside of a click event. The beautiful thing about click events is we have the this property. This stands for the trash can I just clicked. What I'm going to do is I'm going to go up a level from this trash can to the LI. The LI is the parent. So let's look at the EJS so we can see this. Here's the trash can we clicked on. Here's the trash can I clicked on. I'm going to go up to the parent. Here's the parent, the LI. All right, that's the LI. Now, once I'm in the LI, right? Once I'm in the LI, right? Once I'm in the LI, I'm going to look for some stuff. No delete by ID. Of course, we'll do that in the future, but not right now. This is a review of some older stuff we built up to. So in the future, we use method override and we have IDs and all that other fancy stuff. But we got to know what that gives you, right? You just can't jump to it because then you never respect why it saves you so much time. So we're all about respect here. Got to put some respect on JavaScript's name. And so we don't jump right to it. We want to understand. We want to be better than all the other developers, understand why we do the things that we do. Cool. I know, Royal. Welcome. Man, you have a great stream. You know how to teach really well. I'm getting a lot of aha moments. That's what we live for, Blade. That's what we're here for. Thank you for saying that. All right, let's finish this up so we can take a break. We're kind of late on our most recent break, so let's finish that up. Thank you for reminding me, Fox. All right, so we just clicked on that trash can. We go up to the LI, and then what we're going to do is we're going to look for something that has the class of stage name, something that has the class of birth name, and grab the stuff that's inside of it. So that's what we did here. We went from the trash can up to the LI, grab the thing that has the class of stage name, and grab the text that was inside of it. That's stored in the variable S name. So in this case, wherever we see S name, it was really Dr. Dre, right? And then wherever we saw B name, it was actually Andre and the rest of their birth name. Cool. Now, the cool thing is we're sending that as part of the request body. Just like when we submitted the form, there was a request body. When we send this fetch, we're sending a request body too. And in that request body, there's going to be a stage name S property, which is going to be holding the value Dr. Dre. And there's going to be a birth name S property that's going to be holding Andre, their birth name. So we know that fetch goes to our server. And on our server, right, we're able to see, all right, we know that we're in a delete request. The routes all check out. We're good. Let's go to our database. Let's find the wrappers collection. Let's delete one document where in the document, the stage name property, like if we look at our MongoDB, all of our documents have stage name, stage name, stage name, stage name. So find for me in one of these documents where the stage name equals request body stage name S. Chat. In the example we're talking through right now, okay? In the example we're talking through right now, what does request.body.stage name S equal? In the example we've been talking through, what does request.body.stage name S equal? Exactly. It's holding that Dr. Dre value that we got from the DOM. So we looked through all of our MongoDB documents. We looked for a document where the stage name matched Dr. Dre. So we came into our MongoDB. We were all right, Polo G, that's not correct. Here's Dr. Dre. So here is an example where stage name equals Dr. Dre. So we delete it. We get rid of it. It's gone, right? Yoink, it's gone. And so if we refresh, we can see that it's no longer there. We have Busta Rhymes, we have Polo G, we have Chance the Rapper, we have 21 Savage, but there is no more Dr. Dre. Now, what's funny is I passed along both Dr. Dre and their birth name. Did I wind up using the birth name at all? Did I wind up using that server side at all? Nah, I didn't use it. I still sent it. I didn't use it though. Right? So I could get a little bit more specific here. I could be like, and birth name equals blah, blah, blah. We passed along. Like that would work. And like we saw before, like somebody was talking about earlier, this really doesn't protect us if there were two Dr. Dre's. Eventually, as our code progresses, we stop using stuff that's in the DOM, like what the user entered in as text, and we start using the unique IDs, right? Because in the future, the unique IDs, every document has its own unique ID, so we might as well just use that unique ID going forward. But we got to understand like why that's helpful by suffering through this crap. All right. Then once we're done, we respond back. Hey, we deleted that wrapper you asked for. And then once this is done, what do we do, chat? Once the fetch is done, we deleted that document from the database. We respond back to the fetch that everything worked as expected. What do we do? We refresh. And once we refresh, that triggers a what? It triggers the page reloads with the refresh. We trigger a get. The get now goes back to the database. It goes back to the database. Our get goes back to the database. It goes to the database, finds that wrappers collection, finds all the documents, sorts those documents, puts them into an array. But this array is missing Dr. Dre. It's no longer part of the Mongo database, so we have one less wrapper that gets passed into our EJS, which means that we no longer see Dr. Dre in our DOM. Let's go. All right, folks, let's take a break. When we come back from break, we'll do the put. Boom. All right, folks. Let's put some musics on, some lovely break music. We've been going. How long have we been going for? 8 hours and 18 minutes. Let's go. How much longer do you anticipate us going today? I think we'll do a poll on that when we get back. When we come back, we'll figure out how much longer we're going to go. That's wild. All right, 5 minutes on the clock here. Please take a break. If you're able to, get up, hydrate, do what you got to do, and we'll see you in a bit. All right, let's start the timer. This is the best Sunday I've had in a minute. Hey, I appreciate that. Can we make a poll a YOLO? Make that poll. I think we could do that, right? Like we could, like, you pick which one you want, and that's the YOLO. You got 5 minutes. See if you can get them to pee real quick. I have a friend that streams 17 hours a day. That's wild. I mean, like, if I was just like playing a video game, I could stream no problem. 12 hours. Yeah, easy. But the problem here is I kind of got to know what I'm talking about. I got to answer questions and like I got to write code and all that stuff. So That's what makes this different, I think, for me. But if I was just playing a video game, yeah, no problem. And I had a good chat. Like, I had good people asking, like, talking to me and interacting with me. This is my social interaction, right? So if it was just a video game, I was just playing Pokemon Snap all day. I got this. No worries. I'm going to run ads, just new folks joining us. Don't have to sit through them. And you should be taking a break anyway. Yeah, hand stretches are important. Oddly, my wrist was hurting earlier today, but it's not hurting right now. Like before I went live, it was hurting. I think it's all the caffeine. All the caffeine's turned me into a superhero. More 90s rappers in the future, please. I got you. I got you. Who you looking for, Royal? Who you looking for? I'll add them next. This crash course finna be 8 videos on YouTube. Nah, 1 video. You gotta get through it all. All right, folks. Das EFX. What? Get out of here. Rico's on it. Das effects. I haven't heard that in a minute. I'm not even gonna front. Not hip. Y'all throwing out some serious stuff here. New friend of mine told me about you. Nice to see you, dude. Hey, GH, nice to see you too. Sounds like a great friend you have. We're taking a break right now, so if you need to, go take a break. You should be all taking a break. What are y'all doing? I'm about to blow Cat's mind. I had water this whole time. Cat, I think you're probably watching this on YouTube because it must be like 6 o'clock in the morning for you. But I had water this whole time. Sorry. I see it, Risky. It does help. Because it's only... Oh, crap. It's like 9:30 for y'all. I forgot about that. Yeah, it's only 6:30 for me. Yeah, I think we'll probably do the put, and then I think we're gonna have to stop there. I think that's gonna get too late for most folks. We'll see. We'll see what people want. Yeah, we're doing a back end review. So we built up all the way from the beginning, like what the heck is callbacks and promises, and we're seeing those promises now in our nodes. That's why we needed to review them. Yeah. 9:30 for you, 2:30 a.m. What? 3:30 in Sweden? All right, we're gonna stop soon. We're gonna do the delete, and then I think we're gonna have to call it. I think that's too late for folks. I mean the put, and then we'll call it. So yeah, if you want to hang out for another like 10 minutes, that's what we'll do. That's wild. Big ups to everyone that's been here for the whole 8 hours. That's wild. 8.5. We're gonna be at 8.5 hours by the time we're done. That's wild sauce. Yeah, no poll needed. Time zones dictated. Yeah, I agree, MB. Fox with the hydration. Cheers to you. Will you do a part 2? Absolutely. We still got way more to go. I think maybe Tuesday we'll continue. I think maybe Tuesday we'll just pick up where we like Tuesday class time. We'll just pick up where we end. So I think that's what we'll do. Fox, thank you for the hydration. Cheers to you. That's wild, Jer. That's wild. It gives me confidence for a 24-hour stream sometime. Just need to prep for it a little. Thanks for putting in so much time in on Sunday. Hey, happy to. Glad you're here, Risky. All right, folks, come on back. Come on back. So let's go ahead and we'll do the put. Then we'll do the put. We'll do a YOLO, and then we'll raid. I think 8.5 hours. I don't think we're gonna get any more like value, I think everybody's brain's going to be fried. So I think we should just follow up probably on Tuesday. I did have a lecture I wanted to do, but I think on Tuesday we'll kind of pick up where we ended. And yeah, so I don't think we're going to get any more. Like, I think our brains are probably pushed to the limit here. I think 8.5 hours is wild. I know it's review, but still. So let's finish the put, and then I think we'll do a YOLO, and then we'll do a raid, and I think we'll call it there. Or I might just start playing Pokemon. I don't know. I might just start playing Pokemon, honestly. All right, let's go. Let me chill the music here. All right. Let's go ahead and let's on Busta Rhymes, we're going to click the thumbs up. All right. Let's click the thumbs up. And when we click the thumbs up, we can see that there's now what was a 0. Excuse me. What was a 0 is now a 1. And we also see that there is some reordering that happened. Cool. All right. So what could hear that thumbs up, chat? What could hear me clicking on the thumbs up? What could hear clicking on that thumbs up? Yeah, it's the event listener. And so the event listener is part of our client-side JavaScript. So let's go to our JavaScript file. Once again, we have grabbed all of the thumbs up. Right, we grabbed all the thumbs up, and we stored them in this thumb text. Then we loop through all the thumbs up, and we add this event listener to each one. So there's an add like event listener on every thumbs up. All right. Imran, you're a trooper. Good night. Have a good sleep. That's wild. I know it's really late for you. So props for putting in hard work on a Sunday. Kudos. All right. So we grabbed all the thumbs up. We added an event listener to each of them. And whenever we click on a thumbs up, we're going to call the add like function. So let's come down here to this add like function. And we're going to do the same stuff we did before. We're going to go from that thumbs up to the li, and then grab the stage name. We're going to do the same thing again, go from the thumbs up to the li, grab the birth name, and we're going to do one other thing. We're going to go from the thumbs up to the li to the number to the likes, and grab the number of likes. But why did I wrap the number of likes in this like number method? Why did I do that? That's wild. Yeah, because otherwise it'd be a string. Yeah, I want to keep numbers, right? I want to use the numbers because the number of likes. So I don't want it to be a string. We definitely want to make sure that it's a number. All right, and then we do kind of the same thing we saw with the delete. We're making a fetch that has the add one like route, and it's a put. So let's look at our server.js. We're looking for a put. That's a get. That's a post. That's a put. All right, here's a put. Is it add one like? Yep, that matches. That matches. So we know that we're inside of the right fetch. We're going to pass along as part of the request body. What was their name? The name was Busta Rhymes. So we're going to pass along the stage name of Busta Rhymes. We're going to pass along the birth name of Trevor, and we're going to pass along the number of likes, which when we clicked, what was the number of likes? What was it? At the time that we clicked, what was it, chat? Yeah, it was 0. Right? It was 0. Cool. So we passed along Busta Rhymes, Trevor, and 0. So we can go ahead and we can look at that route. We can see that stage name. All right, so we're inside this route. We're going to go to our database. We're going to find the wrappers collection. Right? I don't, Rudy. I find that hilarious. And we're going to update 1. All right, we're going to update 1. So what do we think that does, chat? What do we think update 1 does? What do we think update 1 does? Yeah, it updates it. It edits it, right? It updates just that one document. Cool. So we're going to find just one document where the stage name is Busta Rhymes, the birth name is Trevor, and the number of likes is 0. All right. So it's going to find one document where all 3 of those things match that came with the fetch. Once we find that match, we're going to set the number of likes equal to the number of likes that came through plus 1. So in this case, it's going to be 0 plus 1. What's the extra capital S for? I just did that so it's a little bit easier to see that this was the body that was sent along, just to help set it apart. That's all. You could have called this whatever you want. I just threw the big S on it just to make it a little bit different so it stands out a little bit different. So that's just how you know that we're grabbing that value, and that value. That's all. Yeah. And so set is a Mongo property. The set's just a Mongo property. All it's doing is just literally setting whatever property we put here to be whatever value we put here. So what we're going to do is we're just going to set the likes property to be whatever value is right here. So update 1 found this document. Once it found this document, we set the likes to be whatever is right here. So in this case, it's 0 plus 1. So we literally set the likes property to 1 because 0 plus 1 is 1. So if we were to actually be in the database looking at this, we would find, all right, here's a stage name of Busta Rhymes, found it. Here's a birth name of Trevor, found it. Likes is 0, found it. What set is going to do is take this 0 and replace it, not from 0, but to 1, right? Because we did 0 plus 1. So now likes is 1. And so if we actually refresh it here, we should see, all right, there you go. Busta Rhymes likes is now 1, right? The methods were a little bit different nowadays. Some of the methods were deprecated, and the methods that we used with Mongoose are going to be a little bit different as well. So some of the fine ones and updates and things like that are a little bit different, and some of them have been deprecated. Yeah. Cool. All right. So all we did is we found one, right, that matched all of this criteria. Once we found it, we set the number of likes to be whatever was there, which was 0 plus 1. So that's 1. And then we had this piece right here. These are some extra tidbits that you don't need, right? That's full crud. Let's go. Exactly. It is full crud. We have these extra little tidbits here. I could remove this object and it would still work. All this other object does is passing along another option. And what it does is, well, what if there were multiple documents that had this match? Because we're not using IDs yet. And since we're not using IDs, there could technically be multiple matches. What this is saying is find the matches in descending order. So move through your documents in descending order. And whatever first one matches, that's the one you're going to update. So if we had 2 Busta Rhymes, what's the plural of Busta Rhymes? Is Busta Rhymes already plural? That's how you know it's been 8 hours, folks. I'm not even high for this shit. So if we had 2 Busta Rhymes, right? If we had 2 Busta Rhymes, okay, 2 Busta Rhymes that were in our database, right? What this will say is go from descending order, and the first one that you find, that's the one you're going to update, then stop. right? So if there were two matches, like if this right here found two matches, we're just going to find the first one in descending order, and that's it. This upsert true means if we didn't find the match, it's just going to create a document that has all those values. So if there wasn't a document that matched this, we're going to create a new document that has it. That's it. That's it. Ooh, that's it. So we don't even need this. These are just kind of extras. We could just delete that and it still works perfectly fine. But you're going to see these a lot in some older code bases, so it's important to kind of know what happens. So we found it, we updated it from 0 to 0 plus 1, which is 1. And then once we're done, we respond it back saying, hey, we added a like. And then what did we do, chat? What did we do after we responded to the fetch? What did we do after we responded to the fetch? We did a refresh. Once that refresh happened, it made a GET request. The GET request went to the database, got all the new documents, and the Busta Rhymes document was a little bit different. The Busta Rhymes document no longer had 0, it had 1, and that's why we see the 1 in the DOM. And that's CRUD, baby. You came to get and you got. Exactly. You didn't get got, you came and you got. Came to get, and that's what you did. You don't go and get. You got. You didn't get got, you got. You know what I'm saying? Feel me? Feel me? First try. Now it makes sense. That's actually really good to hear. I'm glad. We don't get got. We go get. Hey, let's go. This was a Sunday well spent. Hey, I appreciate that. I appreciate that. That means a lot. Nice timing on that one. That was a good one. Well, in fact, that was a great one. All right. I promised a YOLO and then a raid. But before it did, hey, I appreciate that. Now before we do the YOLO, I really want to make sure that people have any questions about the put. We answer any of the questions they might have about the put before we do our YOLO. So let's answer any questions and then we'll do our YOLO. Nicole's had a good question. I missed it. Let me see. Why do we use location reload instead of redirect for put requests? That's a great question, Nicole's. And so the reason why we're doing reload is because we are responding to this fetch. So above all else, we need to respond to the fetch that was made, right? So we have to respond to this fetch. So once we respond to the fetch, we're back client side. We're not on the server anymore once we respond. And so since we're back on the client, we just tell it to reload. That's all. Since we're back on the client side, we don't have the redirect. We tell it to reload because the fetch came from the client, went to the server, and we respond it back saying we did it, and then we tell it to reload. Are there any other ways to edit update other than set? There are so many other Mongo methods that you can have. There's increment. So like if you want to increment up by 1, we could have used increment instead of set. That would have worked. It's probably the better one to use, honestly. There are a bunch of them. So we'll see them when we get to the social network. I use a lot of other ones there. But yeah, so we could have used set, we could have used inc, we could have used a bunch of them. And so you can go to the Mongo documents and see all of the helper things that you have available to you. Cool. Other questions while we're here? Did I miss any? Yo, shout out to folks that have been here this whole time. That's wild. How long have we been going for? We've been going for 8 hours and 40 minutes. Almost 9 hours. That's wild. All right, let's do a YOLO. Let's do a YOLO, and then let's do a YOLO, and then we'll do a raid, and we'll get all of our channel points back by doing the raid. Remember, if you do the raid, you get way more channel points, so it's always worthwhile to come by, do the raid, send some love and positivity out. So let's go ahead and do a YOLO real quick. Let's start a prediction. We're gonna do our usual 1 and 2. So let me pull up the terminal here. Let me do a fresh terminal so people know there's no console. So they know there's no funny business. And then I think I'm going to do a raffle too. Let's do a raffle. To do all of the swag packages that I still have to mail out, I got more masks. So I'll do a raffle. I have extras, so I'll do a raffle for a mask too. For sticking it out on a Sunday. So let's go ahead and do the YOLO. Math.seal. Math.random. You know what would be a really fun stream? A stream that's all YOLOs, but some of the code is broken. So we just do a consecutive amount of YOLOs, and you got to read the code really quickly. And based on if the code is right or wrong, you know which way to YOLO. Would you all like to do that? I think that sounds a lot of fun to me. Would you want to do that for one, like a community stream or something like that? I think that'd be a lot of fun. All right, cool. I'm going to write that down, and then we'll do it. I don't know where my pen is. Somebody remind me. Where did I put my pen? Must have fell somewhere. All right, I'll remember it, but remind me if I don't. I think that'd be fun. And you like look at the code and know how you want to YOLO. All right. You sent me a DM. All right, thank you, Fox. Cool. All right, so we have it set up. Let me grab it here. Starting the prediction. Prediction is open. Go ahead, 1 or 2 for the YOLO. Fry, now that I've been through like the storm that was this past week, I got you. We're gonna do some fun community stuff. I'm really excited to do it because the bulk of my all my hard stuff was last week. So now I'm excited to be able to do some more fun stuff, get the stream team and blog team going better. And so, you know. Alrighty, folks, get your YOLOs in. Whew, got 100K on both sides. Let's go. Rudy, I've just been staying in LA. I haven't gone back yet because of the pandemic. I'm not traveling at all. All right. People are feeling 1 tonight. Oh, that's about. I'll be the best 600 ELO you've ever seen. Alrighty, folks. Let's go ahead and run it. Here we go. 3, 2, 1. 1. One's got it. It's been a 1 day. That's all I'm going to say. Let's go. All right. Let me go ahead and confirm the prediction, and then we're going to start a raffle. Choose an outcome. The 1's got it. Complete the prediction. Boom. All right. Give me a second to open up Streamlabs here. Bop, bop, bop. All right. Give me a second. I'm setting up the raffle. Here we go. Start a giveaway. This is for a Learn with Leon, Micro Leon mask. And we're just gonna call this Learn with Leon swag, but this is just for the mask. I don't know what this is connected to, but if you win, this is for the mask. So you can do !raffle in chat. !raffle, that'll enter you into the raffle. So go ahead and do that. Everyone, you deserve to enter this raffle. You've been here for so long, so let's go ahead and get a raffle going here. Go ahead, !raffle. This is open to anyone. I'll send it anywhere in the world. All of them are going out soon. go ahead. I'm going to keep it open for a little bit while longer. Exclamation point raffle. Get in here. Go ahead, folks. You got this. Going to leave it open for like another 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, let's close it up. Lost the tab. All right, here we go. Closing the entries. There we go. All right, it's closed. Let me go ahead and pick the winner. Coding Spren. Hey, congrats, Coding Spren. Send me a mod mail on Discord, exclamation point Discord, and we'll get that coming your way. All that stuff is going out this week if I haven't sent yours out already. So you should expect something soon. You'll get a message from me on mod mail, probably like Monday or Tuesday, letting you know it all went out. All right, folks. What a Sunday. Wow. We still got more to go, but we're going to end here just because people need to go to bed. We've been going for, how long have we been going? Let's see. 8 hours and 46 minutes. Way to be a trooper. Respect all the hell out of all of y'all for being here for almost 9 hours. Let's go. So proud of every single one of y'all in this chat right now. Way to rep. Way to be here. We're gonna end this. Yeah, with over 200 people here after almost 9 hours. That's wild. Let's go ahead. We're gonna do a raid. Let's go ahead and send out the raid right now. It looks like Adafruit is streaming. That's pretty cool. Let's go send them a raid. Let's send some love and positivity. Keep the love going. Send them, if you haven't given them some follows, give them some follows. Make their night. Let's do this. All right. Queued up the raid. I'll see y'all over there. We are raiding in 6 seconds. Do the raid. You get more channel points. You can come back and YOLO them. All right, folks. I'll see y'all over there. Have a good night. Peace. Good night, everybody.